So yeah, a typical SPA will have a lot of pros. It's pretty easy to implement now using the technologies that I mentioned. React, Angular, all of these make it pretty straightforward to implement it. Navigations are fast. It's pretty much instant once you load the first page. Server processing is very cheap. All you have to do is like serve one static HTML file, right? Your one node process could serve like thousands of requests per second. And you don't even get too much traffic because only the first request for a session will come to your server. Subsequent requests will directly contact your API. So essentially, it's really good. It's a good model in general. So this is what it generally looks like, right? You have your HTML, which is pretty small. You download it. Once the HTML is downloaded and parsed, the CSS download starts. Your JS download starts. Your JS parses. That's when your client-side code will kick in. You make API calls, you get the data, and you get your first print in your first render. Now this obviously doesn't look too good, right? I mean, your first render is all the way over here on this side of the screen. That's bad. Okay, so the cons here are obviously you have an empty page for a really long time. You have rendered nothing until that point. An interesting issue that comes up with single-page apps very frequently is that your SEO gets jeopardized. The first HTML that you see here is pretty much empty. So unless a crawler can execute JavaScript, wait for you to make API calls, and then re-render, the crawler won't be able to crawl all your content. And obviously, the JS bundle is huge. It takes a long time. An interesting metric here is a good one to follow is that you generally take around 1 millisecond to parse 1 KB of JavaScript. And keep in mind a gotcha here that you might be serving gzip content, so your bundle might look like 50 KB. Ungzipped, it's going to be 500 KB, and that's the time it will take to parse it is 500 milliseconds. So apart from download, it will take half a second just to parse your JavaScript before it can execute. Keep that in mind. So what do you do over that, right? To improve it, you come up with new methods. So what we did with Flipkart Lite was we came up with the concept of app shells, which essentially means the initial HTML that you serve from the server is not blank. It contains the loading state of your page. And obviously, this needs to be context sensitive. If you request home page, you need to serve a loader which looks like a home page. For a list page or a product page, it needs to look like that. So how we solved that was build-time rendering. I've talked about it earlier. It essentially means that at build time, you know that there is no dynamic content in this here. So you can essentially generate this HTML at build time. And it just becomes a static HTML that you have to serve at runtime. So it's pretty cheap. The biggest pro here, no more empty page. What you see in the first render is the loaders. So what happens now is your first paint happens the moment your HTML and CSS are ready. HTML size is not huge. It's pretty small. It's just the loaders. And your rendering is blocked on CSS downloading, which is again sequential after the HTML. So your first paint comes here, which is much better than going all over here. Okay, so that's the first upgrade. Now the con obviously here is that this is still not meaningful. It's better than an empty page. It's still just the loading state, right? The user can't really do anything about it. If he's on a slow connection, he's just staring at a loader for like 5 seconds, which is pretty bad. So that's that. So to solve that, one approach we tried was, why not try server rendering? Even if you're using the modern, client-side stacks, what's preventing you from running it on Node, right? You can render your full page on the server for the first request, and everything works pretty much the same. And your client will re-render the page when it has the data. So your first paint becomes meaningful. Your SEO gets solved. That's the biggest benefit. The HTML generated from the server contains all the content that you want your crawler to see. And this is what it looks like. Now observe here, you add a waiting time to your HTML because your server needs to make API calls, render the data. You have to keep the cost in mind of the rendering or templating, whatever you're doing, the API calls you're making, connection times. Then the HTML download and parsing happens. Then the CSS downloads once HTML is completed, and your first paint moves here. So if you see, your first paint has moved again a lot to the right, and these diagrams are not to scale. right? I purposefully avoided adding the timelines here because I will get to that. In the future slides, it will just get squished to one side. Okay, so this is where your page becomes interactive, which is again a lot of time. So another so the cons here are that you get significant increase in server load. That's the biggest con, right? Rendering a page on the server using client-side technologies, like you either need to use something like React DOM, render to string, or you need to use Phantom JS or Rhino, some way of mimicking the DOM on the server, which gets pretty costly. So there's a significant increase in server load, right? Your HTML download size increases like enormously. A loading state will be what, like 10 KB of HTML? That can fit in one HTML chunk, right? So the moment you get a response, you're done. This HTML can be like 800 KB, 1 MB of HTML, just pure HTML, depending on what page it is. It's going to keep downloading forever. Your response times have increased because again your server is processing a lot, and your JS file is still huge. So it doesn't become interactive until all of this is ready. That's like too many cons, right? Yeah, so this approach doesn't work. So next update. The next thing we tried was the concept of universal apps, that you render only SEO critical content on the server. Client continues to work the way it was, and most modern libraries can reconcile the changes. So what that means is that by SEO critical content, I mean things like the title of the page, the meta tags, and things like that. So at least you got some content out in the first paint. So what happens here is that you could render just the header, footer, and meta tags from your server response and load everything else on the client. And the pros here are obviously your server load becomes much lesser. You're not making those API calls. You're not processing that much HTML on the server. Your SEO is not as good as full server rendering, but it's still better than doing nothing at all on the server. And your header and footer can load quickly. You can still show loaders in the first paint. You get a big boost in the perceived performance. And the cons obviously are that your first paint is still slow. You are still trying to run client-side code on your server. You're still trying to so for example, at Flipkart, we are heavily into the service-oriented architecture. So even SEO for us is a service. We give it a URL of a page, and it tells us the meta tags and the page title and stuff like that, and the like huge piece of text you put in the footer always, right? Who likes that? So yeah, that is still there. You still don't have any organic content in the first paint. You still have loaders. Like, what does the user do with that, right? And your your file is still huge. So you don't get much benefits there. So the next update would be, you are anyway doing all this. Just for a minimal extra cost, you might as well just render the first fold. It's again getting closer to the server rendering, but bear with me here. You just render the first fold of the page, right? You can lazy load the rest. So what that looks like is essentially this: that instead of showing loaders, you show some content on the screen. You know what's going to be in the first fold for like 90% of your audience. You can get metrics of what the browser resolutions are. Now an interesting pitfall we ran into here was, the moment you render this kind of HTML, how your typical HTML looks like is you have your body tag, your div tag, which contains everything, your HTML, and then you have your script tags, right? If that HTML has images in it, like IMG SRCs, those images are going to start downloading immediately. And what happens is it will not necessarily block your JavaScript resources, but it is going to contend for the network. And if those images are large, for example, these banners here are pretty huge. You are going to sort of delay loading your JavaScript even further, which is bad. So an interesting thing we did here was concept of progressive images. It has been very popular for some time. Medium specifically has been doing this really well for a long time. You load much smaller images, lower resolution images first, and then you replace them using JavaScript using the high-res images once they are downloaded. And you start the download later, of course. And the browsers, interestingly, will automatically blur them. So you don't even need to use CSS blurring for most of the browsers. The benefit you get is huge. This image here could very well be 300 kilobytes. the full resolution image. This small one is hardly 300 bytes. Like, that's the benefit you get, right? So you put in progressive images along with this. Your client side is still pretty fast. Pros are that your server is making the API calls now. There is a benefit to it. The plus side is that making API calls from server is generally better because now you're making API calls server to server, which is within your data center ideally. And you get rid of all the latencies of the network. You get rid of connection lookups. Like your server can have an etc host entry for your API server. You don't even need to do a DNS resolution. You get organic content in the first paint, and the best part is that you have anyway made an API call to get all this data from the server. You might as well send it to the client. Why does the client need to make that API call again, right? You can just append it to the end of your HTML, like after the script tags or something, and your scripts can read from that JSON itself. The client doesn't need to make up a new connection, and the API server doesn't need to process it again. So a big con at this point was still that your JavaScript is still huge and everything will get blocked on that. So the best part, the interesting part we worked on here was that you split your JS bundle into different chunks based on the page that you're on, right? Once you think about it, it's like a really no-brainer. That's how jQuery used to work. I mean, once you have jQuery, every page used to have its own JavaScript, like whatever is needed on that page. You don't load the checkout JavaScript on the home page, right, unless it's needed. So you only load JS required for the current page, and your subsequent JavaScript resources can be loaded when needed. It's like pretty obvious once you think about it. So this is what it looks like for us. This is the old one. You had one app bundle which was like 206 KB, huge bunch of JavaScript there. And once you split it based on routes like home page, product list page, offers, search, browse, product, and all, these are the sizes. So you get like, you need only 32 kilobytes of JavaScript to render the home page, right? So this looks pretty fancy, and believe me, it's pretty easy too. So how do you break the JS bundle? Right, you have to define split points in your application. So your code will have like a 200. You will have 200 components, and you are bundling them together somehow using Webpack, Browserify, or some tool like that. And these tools make it easy to split the code actually. So all you have to do is you replace your import statements with require.ensure. That's pretty much it. Like that's really it. Import is, I will explain why, okay? So import is statically analyzed. So when you import a file at the top of any script, like one component imports another, it becomes a hard dependency of that component, and that this component cannot render without that. For example, if your parent component, which is rendering your entire page, will obviously be importing all the pages because based on the route, it has to render all the pages. So if you import all of them become hard dependencies of just your shell of your layout. So essentially everything gets bundled into your initial entry chunk, which is app.js. So splitting that, if you use require.ensure, it's essentially an async way of requiring files. It literally what it means, right? It just ensures the file is there when it's required. So Webpack or whatever tool you're using, Webpack specifically will automatically download that JS file when it's needed. Right, so Webpack and React Router work hand in hand for this really well. Try it out. I have a code sample here too. I will show it to you. Sorry. Yeah, so this is what I was talking about. Your typical routes JS file looks like this. That you import your page at the top, then you define your routes that if you are on /about, you render this page as the component. Or if you're using the JSX format, you do path is equal to this and component is equal to this. Pretty straightforward, like one lines of code. To split it, all you have to do is this, that instead of just doing component, you do get component and then require.ensure of that page, of that file, and you call back with that component. When Webpack sees this require.ensure, it will not bundle this file until this route is executed. So when the browser tries to execute this route, that's when it will download this file. And if this looks too ugly, there is a loader for this for Webpack. Like there used to be, there's an app for that. There's a loader for that. Pretty much everything you can get a Webpack loader or a Babel loader. It's called the bundle loader. You do an async require of that, and this essentially, this syntax looks pretty much exactly the same as this one. Instead of just component page, it becomes get component async require. So this is what you get in the timeline after that. You are waiting for the API calls and stuff to happen on the server, your HTML downloads, your CSS downloads, and the moment the first chunk is ready, right? So you get a full render at this point with content. Now if you look carefully, this JS is much smaller. It's pretty much the same size or smaller than your CSS because you're not splitting that CSS. And you get your first render here. Now this is not to scale because the JavaScript earlier was going all the way till here, and your first render was like somewhere there off the screen. Now it has moved here. So that's the benefit you get here, and all your JS is downloading in parallel while that's happening. So why it's downloading like that is because this is what your typical HTML looks like. You have your style sheet at the top, you get your server rendered HTML here, and you have a bunch of JavaScript files here, right? And earlier it was just vendor.js and app.js. By the way, I hope everyone is splitting their code into like vendor and app for long-term caching. Like React doesn't need to be rebuilt every time. You just serve it once and it can be cached in the user's browser, so they don't have to download your React or Angular again and again. Your application code can be separate. So there are some interesting gotchas with this approach. You need to have hashing for cache busting. Like I said, if you're serving your vendor and your app.js, right? Suppose you do a code deployment tomorrow, you need to be able to tell the users or their browsers that you need to download the new file. So to do that, you need hashing. So you add hashes to your file names. Right, so you take the content hash of the file and you append it to the file name. So if your file changes, your hash changes, file URL changes, the browser requests the new one automatically. And you can essentially indefinitely cache all of those files. Now what happens is, I am talking specifically about Webpack here because that's what we are using. When you split your JS bundle into smaller chunks, Webpack needs to know that if I hit /about from the example, I need to load page.js. Right, and it needs to know page.js is in which bundle, what's the file name, what's the hash. So Webpack adds a lookup table to your entry chunk. So because entry chunk is guaranteed to be there, that's the first chunk that's loaded for any page. Typically that's like all your common modules are there and this lookup table is there. Now what happens is if you make one change on product page, say, right, your hash changes, what it causes to happen is that your lookup table changes, which means your entry chunk changes, which has all your common changes, which have not changed. Are you following me here so far? Okay. So what happens here is that your entry chunk changes, essentially you end up invalidating all your cache, right? And you lose long-term caching. So you need to take care of this. Webpack allows you to add a manifest plugin here, which essentially pulls out the lookup table into a separate file. It's like a small 100 bytes, 200 bytes of a file. So only that file changes if any file changes. So we actually turn the gotcha here into a big pro for us, right, into a big benefit. That now what happens is all your bundles are separate, chunks are separate. If you change a piece of code on, say, the product page or checkout page, right, only those JS files need to be downloaded for the client. If a client doesn't go to the order summary page, right, he doesn't download any new JS. No other JS has changed. Everything renders pretty much from cache, which is blazing fast. So we have converted an issue here into a pro. But it's still not fast enough, right? There is a lot more you can do. So PRPL is what we tried next. That's a pattern that has been popularized recently by Google for their Polymer apps, but it's a pattern in general. So you can apply it to any technology as such. What PRPL stands for, it's an acronym. It stands for this PRPL, that you push your critical resources for the initial route, keyword here being push. Then you render the initial route, which is what we are doing already with chunking. You pre-cache the remaining routes, and then you lazy load and create the remaining routes on demand. So essentially when you load homepage, you only download homepage JavaScript. Then while homepage is downloading, a server can push more content. So if you are using HTTP2 here, you can easily do this, right? HTTP2 supports push, well and good. If you're not using HTTP2, I will get to that. All right, so you render an initial route, and then you can lazy load other pages JavaScript as needed. So this is what preloading looks like, right? So all your script was at the end, so it still stays there, and you essentially add link rel preloads to your head. Now, how many people are aware of this kind of thing, that there's a link rel preload? Okay, few. All right, interesting. So I'm sure there are other talks which will go deeper into this. Just I will do a quick update on this. So link rel preload essentially tells the browser to download these files in parallel to the HTML without blocking, but not to evaluate or execute that file. So these files will download in this order along with the CSS, but won't execute until the script tag comes in, and they will execute in this order. So you can download in a different order and execute in a different order, which is really cool. I will show you how. Okay, so along with that, since if you don't have HTTP 2, which is the case with us due to some infrastructural challenges, we are still on HTTP 1.1 as of now. So one way to mimic the push of content is essentially, what does push mean, right? That you don't block your resources downloading on your HTML downloading. You can do that with HTTP 1.1. All you need to do is convert your HTML response to transfer chunked encoding. What that means is that since some parts of your HTML are essentially independent of your page content, for example, your header, footer, your meta tags, things like that, your CSS, your JavaScript bundles are independent of which page you are on. You can push them out as soon as you get a request. You don't need to figure out what API do I need, what data do I need to render that page, right? And then you send those first for the resource download to start, and then you do a smart use of preload, prefetch, and defer. So preload is what I showed you. Prefetch and defer are other options that you have, which function a little differently. Again, there will be other talks detailing on this. So this is how we do streaming using Express, right? In your route handler, you set your content type explicitly. If you do response.render, it automatically sets it. Response.set you need to do. Then you write your HTML head tag up to the opening body tag, which has all your link preloads and your style tags. And you write it and you flush it to the user. At this point, the HTML stream has opened. And this is like, as soon as you get the request, this is all static. This is milliseconds after, like you've responded with the head part of your HTML in milliseconds after getting the request, right? Then you do your whole server rendering. This could be templating, this could be Angular, this could be React, whatever. And you write that, and then you write your script tags, and you close your response, right? This is what some very basic streaming looks like. And this is what it looks like for the client on the timeline. Your HTML is, okay, so this maps to the same blue chunk that was there on just the left side, zoomed in, right? So this HTML is still taking, let's say, 500 milliseconds to download. Now your CSS can start downloading at like 50 milliseconds after getting the request. How cool is that, right? And all of these things don't block the HTML. If you do a preload, nothing is blocking your HTML from rendering or parsing. Your HTML continues to work the way it was, but now you're downloading these resources in parallel, right? So what happens with your HTML is downloading in this part, and it's parsing for a lot of time. So if you look carefully at the timeline, you're going to see this happening in parallel. So it starts in milliseconds. Your first paint happens here as soon as the HTML, some part of HTML is ready. And your full page render happens once your HTML is complete. That's when you get the last script tag and it has executed. So this JavaScript will execute here once you see the script tag. And you can load your JS chunks which are not needed on that page later after, so it doesn't block the interaction with the page. So obviously the pros here are that your CSS and JS resources can start downloading immediately. It's all happens in parallel, so you can make use of this feature of the browsers. Your page is ready to render as soon as HTML is ready, which is pretty fast, right? The con here obviously is that now your server needs to keep a connection open with the client. So, I figured this out after I implemented this, that what happens is, suppose your Express is fronted by Nginx, right, a reverse proxy. Even if you're streaming content, Express is generating a stream, Nginx will buffer that stream. And once Express closes that stream, Nginx will send the entire HTML together to the client. Like why? Like you lose all the chunking, lose all the streaming benefits, right? Nginx does that for a reason. The reason is that your Express server becomes immune to client latencies, right? So if a client is really slow, if he's on a 56 kbps modem, right, from the old ages, he's going to take like 5 minutes just to download your HTML. It's like I said, it's a 500 KB HTML. At 50 kbps, it's easily going to take 10 seconds. So now what will happen is your Express server will need to keep a connection open with the client if Nginx is not buffering. And Express being running in JavaScript in Node, it's single threaded. It can only do one request at a time. So unless you close that response, it cannot take a new request. So for 10 seconds, your Express server is blocked from taking any other requests, right? So that's the benefit and the issue with buffering in Nginx. And it's very easy to turn it off. You just have to give one statement in your Nginx config, proxy buffering off. It will turn it off. And another con on inside here is that your client can download only limited number of resources at a time. So don't make everything parallel. So this is what it looks like in real life. This is a screenshot from the production Flipkart site. This is what I was talking about earlier. This is the blue part for the HTML, and everything else happens after HTML is complete. So this is your first paint at around 2.5 seconds, and this is your complete render, DOM complete at 3.5 seconds. If you stream it, essentially what happens is these blue chunks you see here are downloading HTML, and the light blue is parsing. This is, by the way, Chrome DevTools on Chrome Canary with the network enabled in timeline. So you can see how your network requests are happening. So now your CSS is downloading, JS is downloading in parallel. JS is split into chunks, and your first paint is at 1000 milliseconds. Your first paint with meaningful content is at 1 second, which is the benchmark we had set for ourselves. And your DOM complete also happens faster because now everything is happening parallel to this. Essentially, you move the whole chunk here to the left with this one small trick. An interesting thing here is your first paint event by the browser is here, but what is this duration? Like, how did these images started downloading without preload if HTML was not there? So the interesting thing we noticed is that visually, if you see, so you can also capture screenshots in this. Visually, your first paint actually happens here, but the browser tracks it here. This is what we figured, right? So what this led us to believe was that browser waits for certain steps to certain conditions for it to be considered as painted, but for the user what matters is visually is it there or not. So if you're working on this kind of the cutting edge of optimizing using all these technologies, PRPL and all, you can't really depend on things like DOM content loaded and the window onload event to track your performance. You have to start tracking custom metrics, and you can use things like the request animation frame and user timing API to track such things. For example, you have this performance.mark as part of the standard now. It's a window.performance.mark. It essentially marks this as a point in the timeline. Now the beautiful part about this is that this is a standardized API, which means websites like web page test understand this point. Just by the virtue of doing this, webpagetest.org, SpeedCurve, DareBoost, all these technologies which track, which do synthetic testing, just by putting this line in your code as the first thing in your before your HTML, these tools will mark this point on the timelines on their websites. You don't have to do anything about it at all. This is all. And you get these custom metrics. You could do performance.measure to track how much time was spent in the API calls, how much time was spent in rendering, things like that. So these are things you should track, right? You should track all these custom metrics, which is very important. Cool. So the key takeaways here are that you have to solution differently for mobile and desktop. You have to treat performance as a feature. That's what we do. It's not just a side effect or a byproduct of what you're building. Biggest thing, you can't optimize what you can't measure. You have to measure it again and again and again, and every single thing. You can split JS bundles into smaller chunks. You can preload those chunks smartly, but don't block your main thread on that. And real user monitoring is important. Synthetic testing doesn't always work as you expect. Okay. Cool, so that's all. Thank you. Do we have time for Q&A? So that's my Twitter. The slides are available at this URL if you want to take a look.
Yeah, just something real quick.
Sure.
In all the measurements and all the graphs you showed, what were, did you throttle your DevTool speed to a certain?
Yeah, so the graph that I showed here, the real graph is actually throttled at 3G. Yeah.
And so when you did all these measurements and all these optimizations, how does the latency of the network figure into this? Are you only relying on the speed of the network to figure out what to preload, when to preload, how to do chunking, or are you also taking latency into account?
Definitely. So like I said, by virtue of making API calls on the server, you get rid of a lot of latencies that you're going to run into. Another bunch of latencies are just setting up these connections, right, with your CDN or with your server. So for that, there are other tags, like you can do DNS prefetching, or you can do a pre-connect. Like I talked about link rel is equal to preload, there is also rel is equal to pre-connect, which will essentially set up the HTTP connection for that resource, but download it when it's actually requested. Right? So we are doing all that, and that removes all the latencies from these requests. Right? But yes, those are considered, and when you throttle in Chrome, it also adds a latency to the connection, apart from lowering the speed.
What was the major gotchas when you started working on the Flipkart Lite to choose a React over other JS?
Sorry, can you repeat that?
To choose a React over other JS. What was the major goals you wanted to achieve that time?
Okay. All right. So how we approached choosing React? Okay. So we took this decision like really long back, almost 1.5, 2 years back, of building all this on React. That's before we started work on Flipkart Lite. The reason we chose React was, I will tell you the procedure we went through. So we started building our own rendering library, right? And we built the entire component system, we built the dependency system, and all that stuff. And that's when we realized that React is the one which suits our needs the best, right? That is what our library was looking like. And React, being maintained by Facebook, has a ton of other features that we could not have built or maintained, right, on just with a small team. So that is the approach we usually take, that we figure out what we need to build, what we need, because only when you try to build it yourself will you be able to tell what are your exact requirements, right? Like things like Angular has things like factories and services and all, which are really good for some use cases, not for us, right? So I'm not saying build everything in-house, right? Use ready-made tools where applicable, but yes, you need to understand your requirements very clearly. Specifically for us, if you look at React versus Angular, if that's what you talk about, React is more of just a rendering engine. It's just the view layer. Angular has a lot of other stuff. It's the entire MVVM architecture. We wanted more flexibility. We didn't need double binding. We needed single binding. A lot of such things. And combined with Redux and all, we could build a very customized architecture of how we make API calls and how we fetch data, how we cache it. So that's how we took the decision. Will it? So the only request going to the node server here is this HTML. All of these are going to the CDN. They're all different URLs, right? CDNs are meant to take this kind of a load. CDNs are built resilient. They have a lot of caching. They have a lot of resilience to these kind of multiple requests from the same client. We also use, we keep the connections open. So if you make one request, the connection remains open for a few seconds, so you don't have to set it up again. So you can optimize that. Yes, definitely. So if you split your resources into these multiple chunks, right? So instead of making 5 requests, now you're making 10 requests, right? So of course, your server will suffer if you make too many requests, especially if you're using Express and Node, right? Like I said, it's single-threaded. CDNs, on the other hand, are built to take like millions of requests per second, so they can handle this load quite easily.
Hey, hey. To enhance the
Okay.
performance of this SPA, have you considered the approach of multi-app architecture?
Sorry, of
multi-app architecture.
mighty app architecture.
Multi-app.
I'm not sure I get that. I'm not aware of it.
Okay. I'm just asking to increase the performance of single page application. Have you considered the multi-app architecture approach?
I'm not aware of the mighty app architecture. Let's discuss outside. You can explain what it is. We can probably discuss more on it.
Cool, thank you.
Cool. Any more
Hello?
questions? Yeah. Where
Hello?
are you? Okay.
Here. So, great insights.
Thank you.
So you mentioned for server-side rendering, you are using React DOM, render to string, right?
Yeah.
So that's a synchronous call, right?
That is a?
Synchronous call.
Yes, it is.
So how you scale the number of requests per seconds?
Right. Okay. Good question. So yes, server rendering with React DOM has a significant cost. The reason why I said full page rendering on server is costly is because React DOM, experimentally, these are not published numbers, but experimentally we have seen like an exponential increase when you increase the DOM size. So we sort of found the sweet spot where it does not like take a whole second to render, but it finishes in within a few milliseconds, but we are still able to render some content. You cannot work around the blocking model of that. React DOM will block the thread. You could spawn up a worker, give your DOM to that to render and then get it back. But there's still a significant overhead in just threaded communication. So yes, that is a cost we are living with. That is where you actually scale horizontally. You add more machines if you can't render those many strings together.
Okay. So we have like built a small library kind of thing, which is like a caching on top of React rendering. So basically, if your component is a pure render component, then based on the props, you can just cache it,
Right.
markup.
Yeah, definitely. So React, there are a bunch of libraries for React also, or for Webpack, which will allow you to cache pure components quite easily. And an interesting insight we learned there actually was that in React, you can define classless functions, right, as pure functions. Those are actually not cached by React. Actually, what is better is that if you define, you'd use react.create class, or you use a class like extends component, and you do a should component update false if it's a pure function, right? Obviously with a shallow compare. That is actually much faster. React doesn't, doesn't memoize pure functions. So that's actually something that we looked into, and that gives a lot of benefit.
Okay. Thanks.
I guess since we have for questions, right? Lots of questions for Abhinav and can be taken outside. Thanks a lot, Abhinav. I think this is a great start of the conference.
Thank you.
Thank you everyone for putting your phones on silent. You probably just heard one, and I'm sure that will be silenced as well. While the next speaker is setting up a bunch of quick announcements, we'll be distributing feedback forms at the end of this talk. Please take your time to fill out feedback for all the talks you attend during the day. Feel free to catch some of us if you want to give us verbal feedback. Feel free to populate the feedback form with as much comments as you like. We'd really like your feedback and see how we can make the conference experience better for you and the content better for you as well. There are food coupons that have been handed out to you when you registered. For those who bought No Frills ticket, you can buy food coupons to purchase food. Tea will be served up downstairs, and the fine folks at PayPal have sponsored cupcakes for everybody over here. So sweet start to the morning.
Hello.
Okay, so next up, Ankit Solanki's talk on the basics of web performance measurement.
Hi everyone, good morning. Can everyone hear me? Okay. Hi, so I'm Ankit. I'm one of the co-founders of ClearTax, and I'm here to talk about the basics of web performance measurement. So, like, before we get into it, I just want to talk about like what is actually performance measurement. What do I mean by performance measurement? So, like, take an example of a startup building an app. You are very resource constrained. You will have few developers, and you have to deliver features. You have to do customer support. You have to build a great experience, and also make sure that the product is fast, because speed matters. It really helps in conversion. So, yeah, being aware of the performance profile of your application makes a very big difference. And using performance measurement, you should be able to figure out what is the critical path of attack, in the sense that what is the low-hanging fruit, what is the thing you can tackle first. Like, you can try to go about improving your site blindly, but actually knowing what is happening will make a huge difference, and you'll be able to fix anything that is wrong faster. One second. So yeah, this is sort of the overview of the talk I'm actually going to do. I'm dividing it into 4 sections. Knowing your users, understanding what it is you're actually measuring. Then you can actually spend time looking at your site yourself and figuring out the simple parts and fixing them. And finally, we come to real user monitoring, which is actually monitoring the performance of your site for end users. So yeah, knowing your users. Can everyone read the text? Okay, thanks. So I can't really talk too much about this. I'm sort of keeping it as a homework assignment. By knowing users, I mean that you have to understand the use cases you have. Are you building a desktop site? Are you building a mobile app? Are you building something that is both? Do your users use 2G? What cities are they distributed in? How are they actually using your app? One of the first sort of most important recommendations I can give is don't just go by data. Actually understand how the user is approaching the site, how they are using the site. Like, you can actually do a face-to-face session, see how they are using it, how do they feel with it. Otherwise, you can like take a phone call and get feedback. That really makes a huge difference. So let's come to the understanding part, and I may cover some of the basics here, and like I may just run through it a little faster, because I'm hoping that everyone is aware of the basics. So ignore the large diagram. It's just for this slide. I'll go into it. I'll break it down into different sections, and we'll go into it. So this diagram is basically the different timing measurements that the browser gives you. The browser has a navigation timing API that is standardized on all modern browsers. And you can use this API to actually measure page load times from the client. And so again, I like to divide this into 3 layers of performance you can think about. Network, backend, and frontend. Dividing it into these layers makes sense to me, because like, there are some things you can think about in isolation, and there are some things in your control, some things that are not in your control. So you can focus on the parts that you can actually control now. So let's talk about the networking. These are the measurements that the browser gives you for the networking aspects. Very high level, let's just talk about the first page load of your site, because that is the worst case performance. The first page load, let's say your user is coming in via Google search. The browser will have to do a DNS lookup. DNS lookup, so the browser gives you measurements for the domain lookup start and end time. You can measure how much time it actually took to find the IP address from the DNS host name. Then once the browser knows the IP address, it will start doing a TCP connection. The TCP connection again is a sort of 3-way handshake. It takes few round trips to actually establish the connection and start it. And I'm sure that most of you are on SSL. So like after the TCP connection is established, you actually do a SSL negotiation and key exchange and all of that. And finally, if everything is ready, just before the HTTP request is about to be sent, the connection end event is fired. So using these measures, you can actually figure out how much time it is taking for the browser to connect to your server. And probably this would be like the front-end proxy server you're using, the Nginx server. So typical times for this are very varying. It depends on where your server is hosted. DNS is typically fast, like should be around 10 milliseconds. TCP connection handshake really depends on the latency between your browser and the server. So if it is taking 3 round trips to establish a connection, the ping time really makes a difference. And again, SSL negotiation will have a few round trips. So it really depends on the latency from your browser to the server. And the best thing you can do over here is, like if you're serving an Indian audience, host your application in India. You'll have like a 40-50 millisecond ping time instead of 250 millisecond for AWS in US. And that is a huge, huge benefit. Like you'll cut down your load time, your connect time by a large margin. Like recently AWS launched a region in Mumbai. Azure is there in India, DigitalOcean is there in India. So even if you're using cloud services, there is almost no excuse to not host in India now. So yeah, coming to that. So there are not too many things you can control in the networking layer, but you can host in India. You can use CDNs. CDNs, typically most applications will end up using CDNs for images, or if you have a proper build setup, you'll put the JavaScript and CSS files bundled and distribute on a CDN. The reason to use a CDN again is they are experts at this. They will have edge locations throughout the country, throughout the world, and the CDN server will be closest to the end user. Depending upon the resources, depending upon your site, you may actually put the whole site behind the CDN. So it really depends on what you're building. Let's say an expense tracking application typically will have the resources and the CSS files in a CDN. But if you are building a video streaming site, you may end up investing a lot in the CDN layer from day one. And again, at the networking layer, one of the most critical things you can do is reduce the number of redirects. So as I said, that first connection, there will be the TCP connection, the SSL connection, and so on. And if you redirect the user to a different domain name, it's going to cost a lot, especially on a mobile phone. Like if there are a couple of redirects before the actual page load is started, then the user is going to see a blank screen for 3-4 seconds before even the request comes to your server. So for redirects, the simplest thing you can actually control is you can set up a canonical server name in your Google Webmaster Tools. By that, what I mean is, typically every site would have almost like 4 variants, with www, without www, with HTTPS, without HTTPS. And you end up redirecting to one version. So in Google Webmasters, you can actually set, okay, this is my canonical URL. And Google search results and so on will actually show the correct path. And like if you can avoid doing a mobile redirect, like m.something.com, that is also great. So next, we are coming to the backend layer. Again, I won't go into too much detail here because we are not talking about the backend at this conference. But again, the basic thing is that you want to optimize for your response time. You want to make it as fast as possible. Sort of high-level suggestions that I can give is, when you are looking at backend, let's say you are doing a full-stack development, don't look at the response times on like the mean response time or the average response time. Look at the percentiles. Look at the distribution of response times. Look at the 90 percentile, the worst case 99 percentile, and this will like inform how your design is functioning. So the browser will give you like these 3 timing measurements you can use. Request start, when the HTTP request goes to the server. Response start, when the first byte comes back from the server. So this can be called as the time to first byte really. And the response end. This is when the full HTML of the page is sent back to the browser. And like depending on your server configuration, if you're using a streaming methodology, you can get the response quite soon. So yeah, let's talk about the front-end section. So front-end, you have a lot of different measurements given by the browser to you. So I'll just quickly go through them one by one. So basically, this DOM interactive is the timestamp given to you when the full HTML is passed and the whole DOM is created. Typically, this is almost the same as the DOM content loaded, which is like the document ready event in jQuery. This is when you typically start initializing your JavaScript application and start setting up everything. So there are cases where, like, even though the DOM is ready, your document ready event may not fire. We'll go into that later. The browser also lets you measure the time taken by the event handler itself. In the sense that if you have a document ready event listener, you can measure how much time it took for the event handler itself to execute by taking a subtraction of the event end, event start time. And finally, you have the load. The load event is when, like, document ready is, DOM content loaded is for the main sort of document without the sub-resources, without images and so on. While the load event is, you have all the resources loaded. So mostly, like, when you are talking about front-end development, you are mostly looking at the first event, not the load event. So now, like, this looks like a very straightforward process, but it's not really a linear process. There is a lot of complication that comes in. Let's actually look at the diagram here. Okay, so, like, the browser doesn't do these things in a sequence. It will, as soon as the response comes in, it doesn't wait for the whole response to parse the HTML. It will start parsing in parallel. It will pipeline. The execution is like a pipeline. And as and when it reaches a script tag, it will start fetching the script, executing it. So there are a few interesting cases here. Like, if you don't have any CSS or JavaScript in the page, parsing the DOM is like, okay, your document is ready to render. But you'll of course have you'll have some CSS and some JavaScript there, right? So the behavior of the browser is, when it executes the script tag, is dependent on the location at which the script tag is present. For example, you can mention that the script tag is async. That will not block the browser and it will continue processing. But if you have a script tag and you have a CSS tag before the script tag, typically the browser will not even execute the JavaScript until the CSS is loaded, and it constructs the CSS object model. Because your script itself may be like looking at some element, they may be looking at the width or the color of some element. The browser can't really predict what the script is doing. So it will wait for the CSS to be passed and then execute the script. So there is a lot of interdependency between these steps. And while this is happening, again, you have a layout happening. The layout will be sort of, again, it will not wait for everything to end. The browser will start making the layout while these processes are happening. And as and when it has a proper structure of the page, by the layout, I mean, like, it figures out which element goes where, the height, width, the margin, padding, all of those things. And based on the layout, it will figure out what is the rendering path, rendering tree, which elements are visible. And using that, it will paint. So the first paint of your browser may actually happen before your document content loaded event is fired in some cases. It may happen afterwards. It really depends on how the actual scripts are structured. You may have cases where you get like a flash of unstyled text without some CSS being handled. Or you get flash of invisible text where you are waiting on some font, but the layout is sort of complete, so you get a blank page without the text, or so on. So again, all of this is mainly looking at a static page. But since you are building an application, like on the document loaded event, you'll start initializing the application, you'll start setting up the event handlers and updating the HTML and everything. So now again, JavaScript will execute and the whole sort of cycle continues. So yeah, it's not really a very linear process. There is a lot of interdependency between them. The timing measurements that you get are for the initial load. But after that, you have to instrument it yourself. So okay, let's quickly go through some of the steps you can do yourself and figure out what is happening with your application. So I'm sure everyone is very, very comfortable with your browser dev tools. So I'll not go into that. But there are a bunch of tools out there that you can use to leverage, like to actually look at your site from a different angle. One example is HTTP archive. HTTP archive is sort of like a internet archive is for, hosting previous versions of site. It's like a public domain crawler which will host history of your website. HTTP archive hosts sort of the performance profile of your site. Like it crawls the top million sites of the world, and for every site it will like figure out it will take care of measuring the load times, response times, the performance profile, and it will give you the data to study. So you can actually download the whole data from HTTP archive and study what is like the average site in the world looking like. You can look at your own site in this HTTP archive and see how it looks like. And web page test is again a sort of community project. It's sponsored by Google. It's what you can use to actually like open your site from different locations throughout the world, different browsers, different connection profiles, and test the performance. And there are a lot of other tools there as well. So yeah, these tools really, really help a lot in measuring your performance. One interesting example I wanted to give was using HTTP archive. You can actually look at, so one second, let me just zoom in a little bit. Okay, so using HTTP archive, I'm looking at clear tags right now. And for some reason, these thumbnails didn't load, but it actually shows you the film strip, the loading progress. You can look at the history of your site in the sense that over here I can select, compare what clear tags is right now to what it was in November. And I have this open. It shows you my data over time. Now it looks like November last year, our site was much faster. It was 3.5 seconds to load. Right now it is 4.5 seconds. We have 1 second extra. But we are doing a lot more things now compared to November. So that's a trade-off we have to make. And you can actually like look at the whole the whole waterfall model of your site. You can compare against the previous version and so on. So this is really very powerful. So now I'll just talk about the very sort of low-hanging fruits you can tackle first. The first thing you should be looking at is like content sizes, because it really doesn't matter like how you are splitting your JavaScript and all of these things if you are loading like few MB worth of banner images on the top of your page for the user. So like take care of the very simple things first, because that is going to make the most difference. Reduce number of images, reduce number of fonts you're loading, or don't load a font if it is not required. Like make sure you're using gzip and cache headers and everything. These basics are really important, and make sure that you have covered the basics first. And again, the size of JavaScript and CSS makes a difference, especially on a mobile device where the CPU power may not be too much and executing the JavaScript may be slower than what you'll see on a desktop. So like you'll see this term a lot when you're looking online for resources, the critical rendering path. The critical rendering path is basically all the steps required to show something on the screen, the first paint. So knowing what is happening to your site, looking at your performance profile, you can use different strategies to actually improve like reduce the critical rendering path. And like you'll come into terms like perceived performance over here, which is basically like if your site is going to take 5 seconds to load, regardless of what you're doing, might as well show something to the user before 5 seconds, even if it is like the layout of the header, footer, or something like that. So this is a very interesting problem for single page applications, and like we had we'll have sessions on this later in the day and tomorrow to how to optimize for rendering something to the user quickly when you are building a single page application, for example using React or React. So basically like these things, the really core basics of performance really help in like while you are developing your site as well, because if you are aware of them, if you are aware of the performance profile, you can actually make the right decisions while implementing. Like so it really depends on the team size, what you're working on. 2-person startup may not have the resources to focus on all the optimizations possible, while a 20-member team may actually have someone dedicated for performance and so on. But knowing the concepts will help avoiding mistakes before they are made. So finally, we come to the real user monitoring section. So this is again like a buzzword. Everyone talks about real user monitoring. It's basically taking this timing performance measurements that you see from the browser and sending it to a analytics software or to your server for collecting it and analyzing it later. So like this diagram that we see that we had seen earlier, it's basically a browser API. So you do performance or timing, and you'll get all the timestamps. So these are UTC timestamps, and you can look at the difference between them to figure out the load time and so on. So every page load will have this data available for you, and this is available on all modern browsers, like almost all browsers. So you can actually look at the usage pattern. I think like mobile Safari recently has dropped support for it, but otherwise almost all browsers have it. So the good news is that you really don't need to build a lot of tooling to measure performance right now, because let's say you're using Google Analytics, which I'm sure most of you are using by default. Google Analytics actually collects these performance measures by default, and it will send to Google Analytics server for so one thing you need to be aware of is that Google Analytics by default collects these performance measures in a sampling mode. It will only collect the performance measures for 1% of all sessions on your site. But you can configure it in GA by setting a sample rate. You can say you want to sample 100%. So all sessions will be sampled. And like there is also a fixed limit, like the number of sessions it will allow. So I think like 25,000 or 50,000, some number of limit that is allowed per day, depending on your site, depending on whether you're on the free version or the enterprise version and so on. So like if you're not very familiar with Google Analytics, Google actually has a demo analytics account that you can add to your account, which has a lot of data pre-populated in it. And I'll put the link here. I'll share the slides later. You can actually add a demo account to your GA profile, and you can study all the sections which are pre-populated and figure out what is happening. So hopefully if internet is working, I'll do a live demo of what is happening. Otherwise, we can look at some screenshots. Okay, so is this visible to everyone? Okay, so I'm looking at a demo account on Google Analytics. So this is like sort of the default view you see. If you go to the behavior section and look at site speed, this is where your performance measurements are actually going to be present. So you'll start seeing all these numbers over here, like the average page load time, or you can look at domain lookup. You can look at different measures. Let's go into it a little more detail. So this section will show you the average time over average load times over a time period, and you can compare against a previous time period as well. So compare to last year, for example. You can see a difference. So it's the average is fine to look at. It's actually quite useful, but the more interesting thing is going into this distribution section. So the average may lie, because you have some users who may get the site loaded in 1 second, some users who get it loaded in 10 seconds, and you want to know exactly what the performance profile is. So the distribution over here is actually sort of the most critical part. This shows you a grouping of whatever metric you have selected. So for now it is load time. Let's say document content loaded I want to look at, because this is when your initialization and everything happens. So the average time is 2.9 seconds for this data. But if you look at the performance buckets over here, most users were in the 1 to 3 second range, but some users around 20-25% of users had more than 3 seconds, and like 3% of users had more than 10 seconds of load time. So you'll see the sort of distribution you see, distribution you get. This will help you in understanding the exact sort of profile. For example, let's look at server response time. So typically when you look at server response, you'll again see a sort of variance in the response times based on whether the request was for a static asset or not, whether it was a cached request, whether it needed some DB lookup and so on. So you will see a lot of variance. Okay, some requests are very fast and some requests take more time. So again, you can go into it in very granular detail. You can go into it by like selecting a specific geographic region. Let's say you are building an app which is available in few cities. So you can compare Indore versus Delhi or something like that. And the other great advantage is Google Analytics has a lot of powerful segmentation capabilities. By segmentation, I mean it can look at a subset of your users. Let's say you want to look at people who are on mobile. So this is like a built-in segment. It will create a group over here. So right now we have two segments selected, all users and mobile traffic. So if you look at the distribution, you can see the difference between them. So for example, the page load times. The page load times may be very different. So for normal, all users, the average case is around 5 seconds. Mobile users, it is almost 8 seconds. And you can see the distribution, how it happened. So the like segmenting the users, looking at a specific set is very useful. You can create segments like people who came in via search query and looked at your site, people who ended up doing a transaction or converting and buying something on your site. You can create segments based on a lot of different conditions. So there are built-in segments, but you can create custom segments based on any Google Analytics property you have. So that was a very quick demo of what GA does. So you have to be aware that Google Analytics is very powerful, but it is also limited in some ways. One of the main limitations is that it is going to give you aggregate data. It is not going to give you individual data, in the sense that you can't really, you can't really study one specific user's performance issues. Let's say someone raises a support ticket saying that it is not working for them. You can't really drill down into that in Google Analytics. It also, up to a certain level, it will give you data even if you put the sampling rate as 100%. After that, it is going to start sampling data and it is going to give you limited sort of metrics. So sometimes, like if you actually have to troubleshoot a problem, it makes sense to actually like do a remote desktop session with the user, or if the user is technically savvy, ask them to share a HAR file with you. So like some recommendations I would give if you are using Google Analytics is that you should build dashboards, custom dashboards with these measures. I'll quickly give an example here. So you can actually build dashboards for your key metrics like this, and you can put it up on a board somewhere. Even the dashboards, in this case, it has a lot of the technical timing metrics. You can actually segment the dashboard also. So you can say, let me show mobile traffic and desktop traffic separately. And remove all users. So now you have two groupings over here, mobile and desktop, and you can see the load times and everything separated by the segments. So this is very useful. You can set up, you can configure these type of dashboards to be emailed to you daily if you want. You can set up alerts on this. So you can actually go into alerts and set up a custom alert. Like you can put rules like if load time in some region goes above 5 seconds, send me an email, and so on. You can also very interestingly look at historical performance. So like let's say you changed, you upgraded the React version and so on. You want to see how it impacted the performance of a site. You can like study the average times or the mean times before the change, after the change. You can compare them and you can see the distribution. So it's very useful. So yeah, so Google Analytics is what I was focusing on because it is available for you. Like almost everyone uses it, but there are a bunch of other tools which will do this for you as well, like New Relic, Pingdom, and so on. At scale, let's say you are really focusing on performance and you really want to optimize, you can actually collect this raw data yourself and send it to the server in a beacon. And you can, let's say you have an analytics pipeline in the backend where you have some standard stack like Logstash and so on set up for collecting metrics. You can put the browser metrics into that as well. So again, what I was talking about so far was navigation timing API that is for load times. In today's world, load time is just like the beginning of the site's journey, right? Once the application is loaded, you have a lot of interactions happening. The whole front end is basically the application for the user. So like what you want to also do is you want to measure timings after load. You don't want to just measure the basics. And there are a few options. Like as mentioned earlier, there is this user timing API that is like a W3 standard and available on browsers again. You can use that to measure timings and it will come up in the DevTools timeline. It will show up as, like, I'll give an example of, let's say you have a few components. You want to see the render time for that specific component. You can use that. So in GA by default understands the navigation timing API and it takes it, but it doesn't understand the user timing API, which is the W3 standard. So if you want to put this information in GA, you have to use a specific API like this, which is sending some timing information for a specific component. So lastly, I wanted to talk about prioritization. So it really depends on your use case, your team size, what you're focusing on. But you have to understand the users, you have to understand the problems you are facing, and optimize for 80%, 90% cases. You may not be able to go to 100%. So, like again, performance is an art. Being informed, understanding sort of the broad picture will let you prioritize and quickly make decisions on what is most critical to fix. And like, I also want to say that like performance is a goal, but it is not really the end goal. Let's say you are building a filing website like ClearTax. Getting the users to file actually is the goal. The usability of the site, the product is the end goal. Performance really helps in everything, but it is not the only measure you should look at. So yeah, that's about it. Any questions?
Please raise your hands when the speaker is answering a question so that we can pass the mic around.
Especially regarding the Google Analytics, how does it apply for a single page applications?
So as I said, that GA by default will take up all the load timings and initial site rendering information and all of that. But if you want to understand the behavior after the load, you want to use these type of events which you are instrumenting yourself. And you might ideally want to put a wrapper function which will, put it both in the W3 standard timing API as well as in GA, so that you can see it in the DevTools timeline as well as you can send the event to GA.
Based on the navigation, I can track.
So yeah, based on your application, basically.
Thank you.
Hi. So I have a question about the privacy of the data. So in this particular case, I believe we are publishing the data to Google's analytics servers. So do they offer some kind of a productized mode of it so that if I don't want to publish my data to them?
So Google Analytics is sort of ubiquitous on the site, on the internet. Almost every website you go to will have Google Analytics tracking code installed. it's really a control on the browser side, where you can block GA scripts from executing with adblock or something like that. For application developer's perspective, GA has very strict privacy controls. Like you're not supposed to put any personally identifiable information in GA. You're not supposed to put a user's email address ever. All the information in GA is anonymized and it's aggregate. It never goes into individual user level detail.
Questions?
So there are no more pressing questions immediately here.
Okay.
Ankit's available outside after
yeah,
this
we
talk.
can chat outside. Thanks.
And I hope you'll share your slides on Twitter and also put it up on TalkFunnel. A couple of quick announcements before we break for tea. The t-shirt counter is open now. If you have purchased a t-shirt or have purchased premium tickets, you can collect your t-shirts from the t-shirt counter now. And if you'd like to submit a flash talk, which is a 5-minute session, please share a brief description of your talk, your name and your contact details on a piece of paper with either Sandhya or me over here. We'll make an announcement about the selected flash talk soon after lunch. Flash talks is happening this evening. Please check the schedule. Thanks a lot and enjoy the tea and cupcake sponsored by PayPal. Thank you.
Harshal, can we set up Zainab with a headset? Can we set up Zainab with a headset? Can you not hear me? I don't know.
Hello, 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 check, hello. Hello, check, hello, check.
Harshal, Zainab is here.
tracks like. Hello. Yeah, it's actually better than the other one.
Hello, hello. Hello. Yeah, I can. Yeah. Okay.
Hi. The banana cake is good.
Somebody, oh, sorry. Okay, we'd request everybody to settle down now so that Ankur can begin the next talk. Can we have people settling down in their seats?
Check, check.
We should start now. Okay, we'll start the next talk now. In case you didn't receive a copy of the feedback form, please feel free to come and take one before the lunch break from one of us over here. The next talk is by Ankur Sethi, who will be presenting a case study of web performance and the building of Aditya Birla Online Fashions. Not working.
Good morning, folks. My name is Ankur Sethi. I work for a consulting firm called Alaris Prime. And this morning, I'm going to be talking to you about how we built the new version of abof.com. That's abof.com. abof.com is Aditya Birla's online fashion retail brand. And if you open abof.com right now on your mobiles, it looks something like this. So before me and my team stepped in, abof.com was your regular old website. It was powered by something called IBM WebSphere Commerce, which is a traditional web framework in the sense that it renders some HTML on the server, sends it down the pipe to the user, and then on the front end, some JavaScript is added on to enhance the user experience. And WebSphere's Commerce uses the Dojo toolkit to actually build its JavaScript widgets. But because abof.com was a very, very fast-growing website when we stepped in, and a lot of teams had worked on it over the past couple of months, there was a lot of jQuery code that was also present on the front end on abof.com. And because of this mismatch of technologies, and because of different frameworks being used on the front end, they ended up with a huge payload on the front end, which actually degraded their front end performance quite a lot, despite the fact that their backend was blazing fast. It was really fast. So let's look at some numbers. When we stepped in earlier this year, around February or March, it took about 20 seconds before something showed up on the screen on a 3G connection if you went to abof.com. And that's a lot for an e-commerce website. That means most of the visitors who come to your website using a slower connection are just going to bounce off. When we stepped in, by we, I mean Alaris Prime and some folks from ActiveSphere, who are one of your sponsors today. When we stepped in, we rewrote the entire website as a single-page application using React. And once again, let's take a look at some number, but before we do that, I'll just use my computer to control this. Okay, so before we do that, I'm going to define a term. I'm going to define a metric that we use to measure performance. And this metric is called time to first paint. And to understand time to first paint, I'm just going to show you a video. So let's quickly look at how a page on abof.com loads. So this is This is the page you get if you go to women's dresses on above.com. And right there, at around 3 seconds, when you start loading your page, something gets painted to the screen. And when I say time to first paint, this is what I mean. Time to first paint is the time from when your user makes a request to your website to the time when he actually sees something on the screen. And time to first paint is a really, really important metric, especially on e-commerce websites, because this is what decides if your user is going to stay on your website, wait for your products to load, and actually interact with the website, or if the user is just going to get bored and bounce off. So throughout this presentation and throughout this talk, and in fact, throughout this entire project we did at ABOF, time to first paint is what we looked to optimize. Our goal throughout this entire process was always to get something on the user screen as quickly as possible. Now let's take a look at ABOF's numbers. Let's take a look at what ABOF's numbers were before our team stepped in and after our team stepped in. So when we stepped in, ABOF.com would, on a 3G network, on a mobile phone, would take about 20 seconds to load. After we stepped in and after we optimized the website and rewrote it in React, we got that time down to some 2.2 seconds, 2.6 seconds. That's about an order of magnitude improvement. And if you look at page load times, which is the time it takes to load the entire page with all the assets, all the images, all your CSS, all your analytics, everything, the entire page load. That time was initially some 27 seconds, but after we were done with the website and we delivered the React rewrite, that came out to be about 9.4 seconds. So once again, that's about 3 times faster. And a quick comparison video with a bunch of other e-commerce websites in India. These are slow motion videos taken on a 3G network. And so the video is a little cut off here, but on the top left corner, you'll see abof.com loading. And on the bottom, you see Flipkart, you see Amazon, and you'll see Jabong and Koovs as they start loading. So I'm just going to play this video real quick. So once again, at around 3 seconds, you see that abof.com has something on the screen, while nothing else is loading yet. Let's just continue this video for a bit. And around 4 seconds, you see Jabong loads. Flipkart is loading. And around 9 seconds, you'll see that abof has now finished loading. And everything else is still loading. Flipkart is at 13 seconds now. Where's Flipkart? Guys. All right, so if you want to take a look at this comparison video, you can go to that URL. It's available on YouTube. You can take a look. This was taken about 3 months ago. I think Flipkart recently pushed some optimizations that has actually made them really, really fast. And Ankit talked about it in the morning. So that's really great. I'm glad everyone's paying attention to web performance. All right, so let's talk about how we went about doing this, how we went about optimizing ABOF's web performance. So ABOF was a ground-up rewrite in React. And while doing this rewrite, we followed 3 main principles throughout our development process. And these principles are, number 1, be impatient. You want to start painting to the user's screen as early as possible, as quickly as possible. You want to get something there. You want your user to start interacting with your website as quickly as possible. Principle number 2 is be lazy. Because we are in India and we have to optimize our websites for low-end Android devices. We're talking Moto Gs, but we're also talking devices by Micromax and Lava Mobile, white label Chinese devices. And these devices don't always have the latest web browsers or the fastest processors. And they're also on flaky 3G or 2G networks or what's called Li-Fi, which is a Wi-Fi connection that's actually really, really slow. So on the device itself, you want to do as little work as possible. Principle 3 is set quotas. For everything you do, for every computing resource you have at your hand, whether it's the number of network requests, your bandwidth, CPU time, memory, the number of DOM nodes your device can handle, you need to set baseline quotas for everything. And a good strategy for doing this is to begin with the kind of devices you're targeting. So once again, ABOF's customers are, let's say a typical ABOF customer uses a Moto G to visit the website, and visits the website using a 3G connection. So you already have two constants here. You have a mobile device and you have a network type. Using this, you can set up some quotas some limits that you want to not hit during development. You could say that your payload size is never going to go above, say, 100 kilobytes. That's all the JavaScript you're ever going to load. Or you can say that the number of DOM nodes you're going to put on the device are never going to exceed, say, 5,000. And once you set these quotas, it's important to make sure during the development process that you're testing to see that you're never shooting above these quotas. So that was rule number 3. I'm going to quickly talk about my tech stack. As I mentioned before, this entire project was powered by React and the React ecosystem. But by and large, the tech stack doesn't matter. If you're building a front-end app, all the principles I'm going to talk about are going to be more or less the same, and they're going to be more or less applicable across frameworks. But still, let's take a look at the tech stack we used. So we evaluated 4 front-end frameworks across 5 criteria while we were doing the project. And the main competitors were React and Angular. And the 5 criteria were rendering speed, payload size, availability of tooling, and whether we could render on the server or not, and community size. So React pretty much checked most of our checkboxes. Angular 2 failed at mainly payload size and the availability of tooling. The framework was pretty immature. And Vue and Riot, they're newcomers to the front-end framework game. And our main issue was with these frameworks was that there's not enough community for us to pick it up. But as I said, the framework by and large doesn't matter. So if you'd like to talk frameworks, I'd be more than happy to answer your questions afterwards. But for now, let's just move on. And when we used React, we also bought into the React ecosystem. And we used Babel to compile our ES6 and some ES7 code down to ES5. We used Gulp to automate our tasks. Webpacks for bundling our code and optimizing our code. And Webpack is a really powerful tool. If you guys haven't checked it out yet, and if you guys haven't used it in a project, I highly encourage everyone to test it out. In fact, if there's one tool out of all of this that you should learn, it's Webpack. And we use Redux for managing our data, and a bunch of other small libraries, but more or less we stuck to what you see on the screen right now. We actually hand-rolled a lot of code for ABOF instead of using an available library, because in a lot of cases, third-party libraries give you more features than you actually need, and you end up downloading more code to your user's device than you actually need to do. So remember, be lazy. Let's take a look at the architecture of how the entire abof.com website is structured. And to look at that, let's look at this really bad diagram. So the interesting story about this diagram is that I was looking at my emails when I was preparing this presentation, and I saw that we had actually sent this diagram to the folks at ABOF at the beginning of the project to explain to them what we were going to do. So this is our professionalism in display right here. Okay, so let's look at what happens when you load abof.com on your mobile device. If you follow the arrows that are labeled with the Roman numeral 1, you'll see that your client makes a request to a load balancer. And the load balancer forwards the request on to a Node.js server that's in the top right corner, a Node.js server that's powered by Koa.js, which is a web framework similar to Express. And the Node.js server actually is running your entire React app as a universal application in the backend. A universal application is a front-end application that can also be run on the backend on Node without actually pulling up a web browser. So the Node.js server is actually running all of abof.com, everything you see on the front end, on the backend inside of Node. And as soon as the request hits the Node.js server, it renders some initial HTML for your user to see and sends it back to the load balancer. And to render this HTML, once again, follow the arrow down to WCS, which is IBM WebSphere Commerce, which comes with a REST API. So to actually put together this initial HTML page, the Node.js server makes a request to WCS, collects all the data it needs, puts together the HTML page, renders it on the backend, sends it back to the load balancer, and it's delivered to your client. Once the page is loaded on your client, all further requests are, if you look at Roman numeral 2 here, all further requests to build the page and to load more products or filter products or search or whatever are directly going through the load balancer to WCS. So the Node.js server is no longer in the picture. And the good thing about this entire architecture is that the initial server that gets sent back from Node.js is actually cached in the load balancer. So most of the time, in fact, it gets cached in our CDN. So most of the time, if you go to above.com, you're not actually even hitting our infrastructure at all. You are just pulling down some HTML that's being stored on a CDN. Only when you start looking at page number 2, for example, do we actually make a REST request to the API, to the above.com API, and start loading further products. So for above.com, we have a very specific page load strategy, which builds up the page, builds up the listing page for a product step by step. And throughout this presentation, I'm going to use that URL as an example. So if you guys want to follow along, you can load that up in your browser, load that up in your DevTools, and follow along with me. And let's take a look at these 3 steps very quickly. Let's take a look at these three steps visually before we actually start digging deeper and talking about them. Stage 1 is when we render the HTML on the server on Node.js and send it down the pipe. And this is our be impatient principle in effect. So if you go to above.com and turn off all JavaScript, you will see something that looks like this. This is the initial HTML that gets rendered on the server and sent back. So if you can see that it has a header, it has some filters, some sorting information, and a list of products. If you scroll down, you'll see that there are about 12 products on this page. There are no images. There is no interactivity because there is no JavaScript. You can't actually use a filter. You can't actually sort by popularity. You can't do anything. But because this page loads so fast, because even on a slow 3G connection, this comes down in about 3 seconds, your users are going to begin interacting with the website pretty much immediately. And this gives your user a very specific feedback. This says, okay, something is happening. This website is loading. You have come to the right URL. And this feedback is very important when you want to prevent your user from leaving your website. You'll hear about perceived speed. So this is something that's part of improving the perceived speed of a website. Stage 2 is loading the JavaScript. The JavaScript will, once the JavaScript loads, it will add interactivity to the website, and then go on to load images, account information, for example, what your username is, what your email is. If you've added something to the favorites, this is when that stuff gets loaded. If you have something in your cart, this is when that stuff gets loaded. And when the JavaScript loads, your page is going to look something like this. So now you see we have a hamburger menu on the top left, top right, my right. Yeah. And we have filters, we have popularity, we have all the product images loaded. And if you are paying very close attention, you'll see that we've also loaded the font. That's also something we do using JavaScript. But there's some stuff, some information that still hasn't loaded. And if you are on a really, really slow connection, that's the only way you're going to observe this, this particular screen. Maybe throttle your DevTools to GPRS or 2G to see this. So when you open the hamburger menu, you'll see that the top area of the hamburger menu says Hi Guest. We still haven't loaded the user's account information. We still don't know who our user is. And the reason we defer loading this account information and we defer putting this in the initial payload is because we want to keep the initial payload really small. We don't want to show the user anything that's not necessary. This is secondary information that the user is going to probably interact with, say, 5 seconds or 10 seconds or maybe even 30 seconds after the page is loaded. So we don't really need to load it immediately. Once again, be lazy in effect. And if you wait a couple of seconds, you'll see that the user's account information is now loaded. Now instead of saying hi guest, it says my ABOF, and clicking that will take you to your user profile. If you look at the top right, you'll see that there's a heart icon with a badge saying 3. That means the user has added 3 things to favorites. And there's a cart icon. There's nothing in the cart yet, but if you had added something to your cart, you'd see a badge there as well. So this is information that gets pulled in after the initial page is loaded, after all the images are loaded, and after all the JavaScript, all our React components have essentially been initialized. The third and final stage of loading is when we load everything else. Everything else that's an add-on. So for example, third-party scripts. ABOF uses a third-party service called Metail to add some additional functionality to their website. So this is when that third-party scripts get fetched. This is when Google Analytics get fetched. And anything else that might not be core to the user experience, this is when it gets fetched. So once again, you will observe this only if you throttle your Chrome DevTools to a really, really slow speed. If you see down there on the bottom left, there's a gray bar saying see how it fits. This is the Metail script being loaded. And that's how an ABOF page is built up slowly, one by one, by sending down essential information first and then pulling in all the auxiliary information that's required for the page later on. And now let's dig deeper into each of these stages. Let's take a deeper look at what's happening behind the scenes, starting with HTML. So to begin with, why load the initial HTML first? Why go through the pain of setting up a Node.js server, a Node.js service somewhere in the backend, and getting it to render your website? Well, the reason is that your browser will start painting to the screen as soon as it receives a little bit of HTML and CSS. So if you want to optimize your time to first paint, which is what we wanted to do for ABOF, the best strategy is to send down a small chunk of HTML and CSS down to the user as soon as possible, because you want to improve the perceived speed. You want to give your users the perception of speed, even if your website is not actually fast. So sending down this initial chunk of HTML makes it feel like something is happening, and it assures the user that he's typed in the correct URL, that his network is not down, that his mobile phone is still working, and it just makes sure that the user stays around for the later stages of loading. And here's something really interesting. This is a small video of a website loading in Chrome. This is a new tab page, and let's quickly take a look at what happens when you actually type in a URL into the URL bar and hit enter. So let's take a look at that once more. So as soon as the URL is typed, the loading indicator is different. And as soon as the browser receives the first byte of data from the server, the first byte of HTML, the loading spinner becomes different. And this is how most web browsers work. This is how loading indicators in most web browsers work, whether they are mobile browsers or whether they are desktop browsers. So what you ideally want to do is make that loading indicator go clockwise and dark as quickly as possible, because that's the point where a user will know that the website is loading correctly. And this is something we actually optimized for. We wanted our loading indicators to be clockwise and fast. We didn't want them to be anti-clockwise and slow. So for ABOF.com, we load the first 12 products. We render the first 12 products on the server, and we send them down the wire. Depending on what kind of website you have, whether it's an e-commerce website or whether it's a web app, this is going to vary for you. For a lot of websites, loading, say, 50 products is something that works for them. For some websites, loading 1 or 2 products works best for them. This is something you will have to A/B test and figure out for yourself. Now we've looked at the why of sending down HTML down the wire initially. let's take a look at how we do it. This is a term you might have heard. This is called universal rendering or isomorphic rendering, which basically means that a web application that is intended to run in the user's browser on the front end is designed in such a way that it can also run on the back end without a browser, without a DOM, inside Node.js. And instead of rendering to the DOM, it can produce a string of HTML that can then be sent down the wire. That is called universal rendering. And if you guys are not familiar with React, there's a bit of React knowledge that's required for the rest of the sections, but I'm going to explain everything as quickly and as best as I can. A React application is basically a tree of components, a tree of UI components. And this is the tree. This is what the tree looks like for abov.com. In fact, if you open abov.com in Chrome and look at the React DevTools, this is the tree that you'll see. And each component inside this tree looks something like this. This is once again an example from actual abov.com source code. I hope nobody sues me. This is a component called badge. And as you can see, a component is basically a function that takes in some parameters and returns JSX. JSX is on line 9, there's a span tag. And JSX produces a virtual representation of what your UI is supposed to look like. So this code, when you actually render this component using React, this doesn't actually produce anything in your browser. It doesn't give you a DOM. It just produces an object hierarchy telling me that a badge is made up of a span and the span has certain properties. So just take a look at the screenshot. On the top right, next to the heart icon, there's a 3. That's essentially what a badge component is doing. There's a library called React DOM that takes this virtual representation of a badge or any other component, or in fact your entire tree of components, and puts it in the browser. There is another library called React Native that takes the same tree, the same virtual representation of your UI, and puts it on a phone. And in the same way, there is React DOM comes with a utility function called render to string, which accepts a render tree, a UI tree as an argument, and gives you a string of HTML. And this is how we render a React app on the back end, because a React app is completely divorced from the browser's DOM or any of the browser's API. We can run it anywhere there's a JavaScript runtime. So we run it on Node, and we use the render to string function that React DOM gives us to render our component tree to HTML and then send it down to the user. Now, it's a little bit more involved than that, but this is something I'd be happy to talk about outside after the talk. And I can actually show you exactly how we set this up with Node.js and with Koa.js. For now, let's talk about stage 2, which is loading the JavaScript and then loading all the auxiliary information. Once again, why do we do this? Why load all the auxiliary information like account information or information about the user's bag? Why load it later on? Why not just send it down with the HTML initially? Well, this is why. When somebody comes to a web page listing dresses or listing jeans or listing clothing, they want to look at clothing. They want to look at dresses and they want to purchase dresses or purchase whatever you're selling, essentially. They don't want to look at their account information. They don't want to look at their favorites. This is all auxiliary information that's not needed at the time the user is coming to your website. And every bit of auxiliary information you add to your web page is going to add some extra costs. So you need to prioritize your user's intent. For every web page you build, for every web page you're optimizing, you need to figure out what is the one thing that the user is coming to this page for. What are they doing? And because of this, it's not very useful to load all the user's account information, profile information on first load. So we load it asynchronously afterwards, after our React components have been rendered, after the entire page is functional, and the user can already interact with the website. And so, an interesting scenario that happened to us after we built above.com was, so the first stage of the project was just building the listing pages and the home page. The second stage of our project was actually optimizing the checkout flow. When you actually go to your cart and check out a product and go through the steps to actually order a product, that was the second stage of the project. And at that stage, our priorities were completely reversed. Because for a checkout flow, you cannot proceed with checkout unless you have a user's details at hand immediately. You need to show the users what his cart looks like, what his addresses look like, what his username is, in fact, even. So our priorities in that case were completely reversed. We began with loading the account information and the cart information, and then we loaded everything else. So once again, you have to figure out whenever you're optimizing your web app, what the user's intent is. At a very high level, let's take a look at how we load the JavaScript, essentially. Because when we are rendering things on the server, we're rendering the first 12 products and sending it back to the user. We know that the page number 1 of our product listing has been loaded. We know that 12 products have been loaded, and we have the details of all those 12 products in our browser somewhere. So how do we know, how does React, when it runs on the front end after all the JavaScript has loaded, how does React know the state of the web page? How does it know what has already happened, what has already been rendered to the browser, and what still needs to be rendered? How do we figure that out? Let's take a look at that at a very high level. First, React takes over. React runs, and it essentially it knows the root element where our app is being rendered, and it takes over. It takes over that root element. And how it does that, if you open above.com in your dev tools and just take a look at the elements panel, you will see a script tag that has this huge chunk of JSON that you can see on the screen. If you format this correctly, you'll see that this is what it looks like. This is a variable called initial state. Everything that happened on the server, the details of everything that happened on the server while rendering the initial HTML are present inside of this somewhere. You can see that there's information about the cart, there's information about the environment, there's an entire product listing there. We know what our breadcrumbs look like, we know how many products we have, we know everything. This is the information React uses to take over the page, essentially. And this is where you need to know a little bit about Redux. This is something called a Redux reducer, and this basically takes care of our state. This is the magic sauce that takes care of our application state. And this is a reducer for one of our menus, our navigation menus. As you can see here, there's an initial state here that looks completely empty in the beginning. This is line 9. This is where the app starts. This is the menu, by the way. And this is our menu component. And if you look at line number 31, 32, and 33, you'll see that there's a static function available in there called prefetch. Now, this static function has nothing to do with the browser. Once again, this is just a function that makes a REST call. So on the server, when we are pre-rendering our code, we call this prefetch function on our component that needs some data fetched. And this prefetch function will then fill in this initial state, which will be serialized as JSON, sent down the wire with the page on our initial render, and then this will let React take over the page. And once React takes over the page and React is running, it then fills in the blanks. It pulls in product images asynchronously, it pulls in account information, love products, bag items, site footer, if any extra information it needs to essentially render the page. And our components have been designed in such a way that if a component's initial state does not contain the values it needs to render itself, it will make a REST request. So if we want to pre-render a component on the server, all we need to do is define a prefetch function on that component, and that function will be called on the server, and the initial state will be filled in. So when the component is rendered on the front end, it just won't make the request it needs to make to get its data, because it will already have its data. But on the front end, if you leave that initial state blank, which is to say you leave out that prefetch function, your component will make the required request on the front end and fill in its data. Okay, step 3, everything else, which includes third-party scripts, analytics, and whatever else we might want to add as an add-on to the web page. Once again, why? Why do we want to render, why do we want to delay loading all these things? Well, progressive enhancement is a loaded term. It means a lot of things. It is generally referred to as adding an extra feature to a web page after it has loaded, adding an optional feature to a page after it has loaded. But in our case, we consider things like analytics as optional features as well, because analytics are really important to your business, and it's really important to do user measurements. But honestly, to a user, and especially to a user who is already on a limited device, on a limited connection, to a user, analytics is a roadblock. It slows down your loading process. So you need to have some respect for users and some respect for the kind of devices and networks they are running on, and progressively load whatever third-party analytics that you need to load. So in our case, after everything is done loading, after React is loaded and all our components have fetched the data and everything is done, after the entire website is functional in all respects, only at that point do we go ahead and actually make a request to load the Google Analytics script that starts collecting data on the page. And only at that point do we start loading the third-party service we use, which is Metail. But analytics are important, and I want to take a couple of minutes to quickly talk about analytics. So when we built ABOF, and we shipped an initial version of the code, we realized that we were losing a lot of analytics events. And that was because we were deferring our analytics script. We completely forgot that a ton of analytics events happen on the front end while the page is loading, like your DOM content loaded event, for example. And all these events have some triggers attached to them inside of Google Analytics that let the business team measure things. So what was happening was we were losing a ton of analytic events. And how we solved this particular issue was, when the page was loading, when the website was loading, if our analytics events weren't loaded yet, we simply queued them up. If our analytics script wasn't present and analytics events were happening, we just queued them up. Now this required some extra work, working with the business teams to figure out what kind of events they were interested in. But it was totally worth it because we sped up the loading time by quite a lot. And to do this, we built a Redux middleware for essentially queuing all our analytics events. And I'm going to very quickly run through this because we're running low on time. This is a Redux middleware that will quickly check to see if an analytics script is loaded or not. And if there's no analytics script loaded on the page when a particular Redux action is happening, this will just put the Redux action in a queue. So if you look at line 16, you will see there's a capture analytics event function that's called for every single event that is happening on the page. And over time, as your page builds up, you will end up with 20 or 30 analytics events inside of an array, which will then, if you look at line 9 up there, as soon as your analytics script loads, your Google Analytics script loads, all these events will get pushed into Google Analytics. And that's how we handle the problem of actually making sure that all the analytics were being captured, as well as making sure that the analytics script was being deferred and being loaded as late as possible in the loading process. All right. So this is how a page on abov.com loads. This 3-step process is why everything is so fast. And And this is a general strategy that we have applied to all our other projects, which is pretty much breaking up the user flow, breaking up the loading of a page into primary data, which is the data you want to show to the user immediately, secondary data, which is data which might be useful, but the user will interact with it later on, and third-party scripts and add-ons and progressive enhancement. And whenever we build something, we make sure that the primary data is visible to the user as quickly as possible. And that's why abof.com is so fast. There's something I haven't covered yet in this talk, and something that is a talk of its own, which is app performance. We know how to load an app really fast. We know how to make it really fast. We know how to optimize the time to first paint to be as low as possible, but we also need to keep the app fast, especially for abof.com, which is an infinitely scrolling grid of products. As soon as you reach page 10 and you have 120 products loaded inside your screen, things start to get slow. And that was something that we spent a lot of time optimizing, especially on slow devices. So that is something I would really love to talk to you about. So if you want to talk about app performance, you guys can meet me outside. Testing load times is, we've already had talks about this, but I'll just tell you the tools we used. We used web page tests, page speed insights, and just loading the web page on different mobile phones, on different networks, on different Wi-Fi connections, just to see how it works. And if you've been to 12th Main in Indiranagar on a Friday night, you know how bad networks get. So you should probably go get a beer and go there with your phone and open the whatever website you're testing and try it out there, because that's the best way to test performance. Yeah. All right. Testing app performance, test on real devices. Best thing to do, questions. Yeah.
Here. Hi, Ankur.
Yeah, hello.
Thanks for the great talk. I'm a little concerned because are you saying that time to first paint is the only thing that you considered when you're saying fastest e-commerce website? Because it seems like your time to first interaction is actually fairly slow and you don't even get the images in until you've loaded all your JavaScript. So
yeah, so that's a great question. So for this talk, I concentrated mainly on time to first paint. The time to first interaction is would be something around a second after time to first paint, because our JavaScript payload is so small. It's about that much, yeah. On a 3G network, that loads reasonably fast. And at that point, you are actually able to, so because you have about the first 12 products loaded, and because you have a lot of data already loaded on the page, time to first interactivity is pretty low. The React stuff mainly pulls in the images, and it mainly populates some menus. So that's a trade-off we made, essentially.
Yeah. Did you face a problem of memory leaks?
We did, yes.
So how did you go about?
How we did it is that we did not, but how one would do it. So, the thing we did was we made sure that while building a React code, we were not re-rendering, we didn't need to. I can talk about that in a bit, like details about that. Basically, there's a function called should component update, which tells React whether a particular component should re-render or not. We that for all our top-level components, especially the infinite scrolling grid, we were running false from that method unless we actually wanted to re-render it. And another thing we did was made sure our DOM nodes, the number of DOM nodes we had, was as low as possible. But if you are building an infinite scrolling grid, and this is something how I would have done different, is you probably want to recycle your DOM elements, which is to say that instead of loading new elements for every single product you load, have maybe 20 DOM elements to represent all your products, and as the user scrolls through the website, reuse those DOM elements. You don't want to increase the number of DOM elements.
Okay. Okay.
But besides the DOM, we didn't have any JavaScript memory leaks because the JavaScript portions of the website are not very complex.
Okay.
Yeah.
Hi, Ankur.
Yeah. Right. Okay, the question is, we're using something called Visual Website Optimizer. Why are we using that? I think that's an SEO tool. So that's something we did not add. I think that's a business tool that the folks at ABOF use to, I think, figure out the hotspots on the web page where people are interacting and stuff like that. I think it's a company based out of Delhi, right? Yeah.
Yeah. Can you hear me?
Yeah, I can hear you.
Yeah, my question is on the queuing of the Google Analytics events.
Uh-huh.
You said you built your own middleware to queue the events.
Right.
Google Analytics provide events. So why did you choose to do it again on your own?
Okay, so the question is that Google Analytics itself lets you queue events. Why did we choose to queue events in a Redux middleware? That's a really good question. So a lot of these events that happen on the front end actually happened with us in the case of ABOF on the back end when we were doing our initial render. Because we were rendering the first 12 products on the server side, there were a couple of events that needed to be handled on the server. Now, this is something that can be fixed with a different analytics strategy. But the business team at ABOF at that time could not overhaul their analytics strategy. So we had to be backward compatible with everything that the old website had. So essentially, this was one of our page load events, which for us became time to page render on the backend. So all those events had to be queued up in the backend, and then they were sent down the wire in the initial state to the front end, and then Analytics loaded. Then we put it in Google Analytics queue. So this was kind of a hacky solution to a problem that could have been avoided, but we had to be backwards compatible, essentially.
Got it. Thanks.
Yeah, so you have this static HTML rendered from the server first, and then React takes over and then replaces that, right?
Exactly.
Which, if the state is same, it's going to be exactly the same. But even my boilerplate React application, I often got warnings saying that your server render is different from your client render, and you get that huge bunch of red text which says that React's rendering it again. So have you experienced that, and how do you make sure that it doesn't happen?
I have experienced that, but I've only experienced that during development. If you actually run it on production, this sort of stuff usually doesn't happen. And I think the reason for that is if you change the markup returned from one of your components, change the structure of the markup returned from one of your components very drastically. For example, if you're returning a span in one of the components, and suddenly that span is replaced by another component that creates a completely different tree. I think that's when this particular behavior happens. But this will happen when you are rapidly changing code. This doesn't happen if your code is not changing.
So for the most part, you don't have any visual difference between what's been rendered in the initial static HTML and what comes after React takes over, right?
Right.
It's perfectly the same.
Yeah.
Okay, right. Thanks.
Yeah.
joined the campaign, right? No. Okay. Anyway. So while Jay is setting up, I'd just like to acknowledge all the hard work that has been put together by the HasGeek team in getting this whole event up and running. I just like to invite some of my colleagues over here. Please, a big round of applause for all the uncertainty that we've handled in getting this event through, and obviously a big round of applause for all of you to show up in such large numbers today. Can I please have some of you come here? Is Karthik, who's been tweeting about how it's so stressful to handle video at conferences. I think it's even more stressful to handle people's uncertainties, but we've managed to get all that through and you're here today. There is Anish, Sandhya, my colleagues Rita, Jyotsna, Jaya, Vidya, all of us who've been working through all the situation and trying to make sure that everything right from the time of checking into the event to actually sort of like, food, merchandise, everything is sort of like spot on. And of course, if you have any feedback, please feel free to like come over and talk to us. So a big thank you. This show wouldn't have been possible without you. And of course, a whole battery of volunteers who are here today. So I'm not going to take much of your time and I'm going to just let Jay take over now. Thanks a lot. And guys, if you're here today and you've managed to make it all over here, we request you to also take a little of your time and support this campaign that we're running. We're saying no to violence, let's take back our city, and let's not succumb to what's happening. So do take a moment, please tweet and share this with your friends, and let's make Bangalore safe.
Hello? Hello?
Check, check, check. Can you hear anything? No. Check, 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 check.
Hello? Hello?
Check, check.
Check.
Give him a hand mic maybe.
Yeah, let's give him a hand mic to get started. But this is working, it seems. Hello? Yeah, this is working. Just turn it off.
By saying something.
Hello? Yeah, I think it's. Thank you. Well, good afternoon, everyone. I'm Jay. So I work at ClearTax and I kind of lead the web team there. So what I'm going to talk about today is we've spoken a lot about how fast you want to load your page and how you want to optimize for the time to first paint, time to first byte, and so on. So what we'll see in detail is like once the application is loaded, how can you measure and optimize the rendering of your application. So before we deep dive, we'll just quickly rush through a few of the concepts which kind of happen when a rendering is happening in the browser. So just to, I think this has been mentioned before by Ankit in one of the previous talks. So during the critical render path, so your browser kind of requests the HTML. It fetches the DOM, passes it, creates a DOM tree. It also fetches CSS files, and if there are inline styles, it creates a CSS object model out of it. Also, if there is, I mean, we often do like load a lot of JavaScript, add HTML from JavaScript, and also add more styles from JavaScript. So once the DOM and CSS are created, the browser kind of creates something called a render tree. So render tree is actually a visual one-to-one map of what you see on the browser. For example, if you have any elements that have a display none property, it kind of eliminates that and so on. So once the render tree, the browser knows what needs to be rendered, it kind of creates, calculates the layout for the whole render tree, which means it kind of calculates the dimensions of what should go where. And then finally it paints, flushes out after the layout are done, it kind of paints all the pixels on your browser. Essentially what the browser does is it kind of writes to the screen buffer via the graphics engine, and then your operating system kind of renders the pixels. So just to summarize, if you have a simple HTML like this, where you have under head meta tags, link tags, then a couple of paragraph tags inside your body. So it kind of calculates the DOM as well as the CSS OM, which accompanies that. And in the render tree, if you see, wherever we have display none, it has been eliminated, and so on. And once this is calculated, the browser calculates the layout. So remember always to ensure you add the meta tag for width equal to device width, and also the initial scale, whatever you want, so that the browser can take what is available width. And based on that, for example, here the first div has a 50% width, and then another div inside has another 50% of that, which is like overall 25% of the whole viewport. Then it kind of flashes out, once the render tree is created, and the layout is calculated, it goes ahead and throws the object out for a paint. So just to analyze a little more around this, I'm just running a video for the sake of saving time. But yeah, to look at how your application is rendering, one of the best tools you can use is the Chrome developer tools. For example, let's look at a site called Diverse UI, where it has a bunch, it has a page loading and a lot of photos that are loading in it. So if you see the dev tools, when you open it, you have a tab called timeline as well. So if you open that, you kind of have various options to what you want to profile here. You can look at like network at the top, network JS profile. Then you can also grab screenshots of what is happening during the time that the page loads. You can also track memory, how memory is utilized during the rendering of this, and also the paints and so on. At the bottom, you also have like if you actually hover on the timeline, you can actually see when you actually check screenshots, you can the DevTools actually captures the screenshots, and you can actually see at what point your page actually loaded and started loading other images and so on. And if you can also on the timeline, you can actually click on it and kind of it's like a sliding window. You can choose where you want to track, and at that point, whenever you focus, it kind of also gives a flame chart below of what is happening on various threads. So for example, here on the main thread, we have a bunch of stuff happening at that near the end. Let me just zoom in a little and show. So if you see this point, you kind of also see like there is an FPS graph here. There's also a memory graph, I mean CPU utilization graph. There's a tiny network graph above the screenshots as well. So just zooming back. So the other thing is like, I mean, this also gives a consolidated view. If you check on the network checkbox at the top, you can see, I mean, apart from the network tab that you might have used a lot for looking at the page load times, it actually gives that view here as well so that you can compare it with the flame chart, with the network loads, how it behaved, and so on. At the bottom, so let me just move the video a little. Yeah, at the bottom, if you see, there is a summary pie chart that is given, where you can actually see what time like scripting took, what time rendering took, what time like paints happened, and what time the page loads happened, and so on. There's also one very interesting tab there called bottom up, where you can actually see exact, like a vertical event log of what has happened during the timeline. You can actually group it by activity of what happened. You can group it by domains, and you can analyze which domain is taking a lot of time. I mean, it gives the total time taken for each. If you have some notorious domains which kind of take a lot of time, you can actually probably block them and remove them from your site and so on. Also, you can see the call tree. The one more interesting part is the event log, where you can actually see what happened. Like the flame chart shows in a horizontal manner according to other panels that you have vertically there. But here you can actually see at what point each of the events happened. Like when did the loads happen? You can actually filter it just to see what kind of loads happen. You can see a lot of send request events there because it kind of is loading so many photos a little lazily. So if you switch to scripts, scripting, if you just check the scripting tab, then you can actually see that there were a bunch of timers fired, and also through JavaScript there were like requests started, mainly probably for the images there and so on. Similarly, you can actually see at this point the layout events happened, whenever you add new styles, how the styles were recalculated and when it happened and so on. Similarly for paint and so on. So one thing is like so far good performance is not just loading fast, but also running well after the page has started loading. Right? So now now we have seen how the page loads and kind of monitored what happens. A lot of parse HTML events happen, a lot of send request events happen, layout events happen, and so on. But typically once the application is loaded, as the users interact, you essentially have your JavaScript kicking in, kind of it adds newer markup or style elements. And this kind of forces the browser to, if there's new markup added or new styles added, it needs to do a layout calculation again, and then kind of push the data out for painting. So one of the things that happens in the browser is each of these, I mean, for painting, it kind of paints in different layers, multiple layers that are stacked together. So once you actually render a layer, you kind of have to have a composition of these layers in the right order so that it can be sent to the GPU for painting the actual pixels. But how long do you have for doing all this stuff, right? So, I mean, one basic concept, I'll quickly run through it, is like you all have heard of device refresh rates. Essentially, most devices refresh your screen at 60 times a second, which practically means you kind of operate at need to operate, your device operates at 60 FPS, which means per frame, if you calculate, you kind of have 16 milliseconds. So a couple of terms that you need to always bear in mind is the frame timing, which is when the frame needs to be, I mean, it's the time by which your application needs to take care of keeping the frame ready. And then after that, you have to calculate layout in Paint and kind of produce a frame. And that is the budget that you have, essentially. The budget, what we've already seen, is 16 milliseconds. So let's go back here and kind of, DevTools also gives an additional feature for you, where you can actually, if you hit escape when your DevTools is open, it kind of opens a bunch of options. You can choose the rendering tab, open it. There is something called FPS meter there. So once you select that, it kind of starts an FPS meter at like top right of your application. So here you can actually see, for example, when I load the page, you can actually see what FPS it's operating on and so on. Right now, I think it is somewhere around 5.4 FPS. We need to check a little more. Okay, so that's how you can actually measure during each of your interactions what is the frame FPS you're getting, and you need to ensure you're close to 60 FPS, and best thing would be if you're always operating on 60 FPS. Else we kind of, when you skip frames, and for a frame to render, if it takes more than 16 milliseconds, you kind of feel a little jaggedness, which you call as jank. Given that you have to complete all these in 16 milliseconds, we'll kind of now analyze each of these phases and how we can debug and kind of better our code for these. So when you're doing only paint-only changes, which means like if you're changing just a background image or just color of a font and so on, the browser kind of skips the layout because it needn't recalculate your elements again, positions of your elements. It's just the pixels wherever you're changing needs to be redone. Ideally, painting is also kind of a little tedious job for the browser because it needs to push all the pixels to, pixel information to the screen buffer, and from there it needs to ensure it hits 16 milliseconds time frame, right? So ideally, if you can avoid layout and paint, it is something that that's the space you want to be if you are doing some animation. Say, for example, if you have a hamburger menu which kind of slides in and slides out, and so on. So let's look at like how, if we are getting a janky experience, how can we go about it? Yeah, so first let us look at the JavaScript part, how you can profile and see where you need to concentrate, where you need to focus to improve on. So from the timeline, in the summary, you can actually see like this is for the entire page load, during which you had like 668.4 milliseconds that is used up for just scripting, like JavaScript execution, JIT, and so on. Okay. So you can actually group by category here and then expand the scripting tree. You can actually see which file is taking how much time for execution and so on. So you can actually, some of them are like extensions that you have. So you can just ignore those because it's something that's on your browser. The other thing is if you focus on, so if you focus on the red ticks at the top of the timeline, let me just zoom in a little there. Yeah, sorry. So the red ticks at the top, they kind of show you like where frames have been missed and long frame rates have been present. So at that point, if you focus on your window to that particular instance, you can actually see the full flame chart of what file. So these are like color coded by files, and you can see what executed for how long and so on. So this gives you a lot more insights into what is happening at that particular instant of when your rendering is happening. So one of the ways to avoid this is, if you see, if you remember that rendering life cycle, the first one is your JavaScript kicks in. So at that point, you need to ensure that your JavaScript starts executing at the beginning of the frame. So in 16 milliseconds, you need to start at 0. So request animation frame is a utility function that you have. We can give a callback to execute your JavaScript. It kind of ensures that whatever JavaScript is in that callback, it gets executed at the beginning of the frame always. So it kind of, you can request animation frame, it returns an ID. You can also cancel the animation frame if you don't want to, if you want to stop the frame and so on. The other thing, interesting thing that you have is request idle callback. This was something that was introduced recently. So what this does is, through your rendering lifecycle, there are paint times, there are script execution that's happening, there is layouting that's happening. There's also some time when the CPU or the main thread is actually idle. Okay, so at this point, you can actually utilize So for example, if you're doing some, say, analytics calculations during these 16 milliseconds, which means you're adding, analytics calculation is something that will not really result in a frame paint, which means you can actually defer it for later. So that is where this request idle callback will help you, where you can actually register a callback where you can execute whatever JavaScript which doesn't result in a frame paint and so on. Okay. If you have more of computation that is happening, for example, say WebApp, it kind of does a lot of encryption. It can probably offload it to a web worker so that your main CPU, main thread, is actually freed of that computation time or that much CPU usage. So essentially, you create a new worker and then interact with your worker with a post message mechanism and so on. So now we have kind of understood what we can do with JavaScript. There's a lot more techniques that you will hear more about through this conference. These are some basic techniques that you can adopt straight away. The next thing that you have to look at is the rendering part of how style and layout happens. Similarly, I always love this bottom-up tab here in the summary below the timeline. So you can actually see, at what point there are layouts happening, and at what point styles are recalculated, and so on. It gives a nice log, and it also gives how much time each of these events took as well. So if you look at the event log and just filter rendering, filter by rendering, you can actually see which file triggered which event and how long it took, and so on. So this actually gives you good analysis of what is happening where, so that you can focus on, you can prioritize how you're kind of optimizing your JavaScript and so on. The other thing that we often do is something like this, where you interact with the DOM, get the position of an element, and probably change some height and width of it afterwards, and so on. So when you kind of do it in this fashion, where you're actually reading something from the DOM, then kind of altering the DOM, it kind of triggers, when you read again, it triggers layouts. And when you write something, it invalidates whatever layout was triggered and kind of cancels that calculation because you're doing some changes again. Which means you're actually just wasting the browser's time, where it is trying to calculate something and you're kind of canceling it with some modifications that you're doing. So one very simple way to avoid this is ensure you're clubbing your DOM reads at one place and then all the writes at one place, so that the reflows are triggered at the end. Yeah, that's at one instance. You can also leverage request animation frame for this, and so that you can ensure whatever JavaScript modifications you're doing, it's at the beginning of the frame, and the layout calculation kind of happens later. So when you kind of adopt some simple techniques like this, you can actually reduce the number of style recalculations and layouts that happen to a very less number. Okay. So this is just an example that is there, but probably live stats, you can debug your application better. The last thing that you need to look at is how the paints happen. Right? Again, you can filter your event log by paints and see for what paint, how much time is happening. So here, I think some of the composite layer painting, it took like 13.8 milliseconds, which means it kind of has only about 2 milliseconds to do everything else, which ideally more often than not kind of results in a long frame. So the other way to see when paints are happening is when you hit escape again. It also has an option for enabling paint flashing. So yeah. So here what happens is, whenever you reload the page or whenever you want to track an interaction, you can enable these paint flashes so that it gives you insights about when a paint is happening and so on. For example, it was enabled and I've reloaded the page. So you can see a bunch of green rectangles appearing on the screen. So which means those areas have been painted by the browser and so on. So for example, whenever a new image kind of was received, it has to recalculate, load those images there and so on. So that's where the paints happen. So as I said before as well, you need, painting means essentially flushing out pixels data. So if you can avoid it, it will be great during, say, animations. Of course, there are phases in your applications where you cannot avoid a paint, but you need to ensure that it's minimal. So one of the, say, if you're doing an animation, you can actually, some of the style properties that, like transform on opacity, they kind of only result in a composite instead of a paint as such. So what this does, and also there's one more thing that was recently introduced, which was a style property called will change. So what this actually does is, whenever you add will change to an element, it kind of creates a new layer for that element. So the rest of the page is in layer below, and when this layer is pulled out of the old layer, whatever animations you're doing, it will only paint this particular element, because that's the only element that's present on this new layer. And the rest of the old elements that you have in the previous layer are not touched. So this kind of reduces the number of pixels it has to repaint. So that way, it actually optimizes and gives you a lot more leeway into the 16 millisecond frame budget you have. So one last thing. So we've talked about layers a little slightly now. So you can actually understand. So layers is also like, you need to be cognizant of how many layers you're actually having there. So as you have too many layers, each of these layers start occupying more memory. So especially in a small memory, devices with low memory, you kind of exhaust the memory that is available for the browser, and probably it ends up crashing. So let's look at one of the sites called Stripe. This page, I think when it loads, so let's start the video. So when it loads, it kind of has a bunch of animations when the page loads. So we can see, and let me skip a little. Okay, so one of the things is, as you have this site here kind of pulls out elements that it's animating to different layers. So in DevTools, you have a nifty tab called layers, which I think in Chrome Canary, I'm not sure if it's enabled by default now, but yeah, you can enable, go to Chrome flags, enable DevTool experiments. You actually get that layers tab available for you. So here, if you look at the top right, it kind of gives a diagram of how many layers are there in the application. So if you see, there are like bunch of layers in this page. So at the left, if you see, there's a tree view of how many layers are there, and if there are layers inside layers, it kind of has a tree view and so on. And at the bottom, it also shows what is the memory estimate for that layer and so on. For example, here, the whole page, that layer kind of occupied 15.3 megabytes, which may be huge in cases where it's actually a low memory device. One of the cool things it also has is, at the top, it has a rotate icon. So if you enable that, you can actually rotate this diagram view and see in 3D how many layers are actually present. So let me try to, so if you see, that's the depth of layers that are there. So if you see, like this is a stack of layers that this page has, which are probably too many for this, unless those elements are getting animated later and so on. So you've understood the layers. You can actually now debug at how many layers you're having in your application. And at each animation, you can see there'll be newer layers that can be added and then removed and so on. We talked about paint occupying a lot of time during your frame budget. So few of the browsers like Chrome, they enabled something called GPU rasterization. I think in Chrome, it's available from 37 version onwards. So you need to just enable this with a meta tag, where you say, obviously, width device equal to width, device width, and then minimal scale equal to 1. It kind of activates the GPU rasterization. So what is rasterization is essentially all these layers are then, I mean, how it kind of converts all these layers to pixels. And GPU rasterization actually brings down the paint time from about 100 milliseconds per frame to about just 4 to 5 milliseconds per frame. So this is something that you can definitely activate in your web applications if it's really necessary. Yeah, because it can, without any work that you're of yours, you can actually reduce the paint times by a lot. So just to summarize what we've kind of looked at is we kind of understood what happens during the rendering life cycle. So it's like JavaScript kicks in, it kind of triggers a bunch of style changes and newer HTML elements, which kind of result in a layout calculation. Then it needs to repaint once a fresh calculation is done, which is pushed to the compositor to actually flush it to the GPU to render the pixels. We also talked about how we can look at what are janks and how we can kind of debug and look into what are, when long frame rates are occurring and so on. We kind of debugged a few scenarios of each of these phases during the rendering lifecycle, how you can optimize it. It's not in detail. You'll probably hear with a lot of case studies that are happening through this conference. We're also having a birds of buff talk in the afternoon, so you can probably join and we can discuss in detail about this. The other thing also we saw was how to debug your layers and see how many layers you're having and how can you reduce the amount of layers that are not useful always and so on. And also nifty GPU rasterization, how you can just enable it to get a huge performance boost. So what next? A lot of techniques are happening to reduce the page load time is break down the page into pagelets. Some people have coined this term called pagelets, where it's like part of a page which can be flushed and rendered upfront so that for the user, the perceived performance is actually a lot better. Okay, so this also means you kind of lazy load or stream in additional pieces of markup that you have and kind of keep adding it to the page so that for the user, they can start seeing something, and when the layout and paint render happens, they can start interacting with the application without waiting for the complete whole page to load. For example, if you see Facebook, which has a lot of functionality loaded on the home page, it actually does this a lot so that the users can start interacting with pieces whatever have been loaded already. The more we dive into JavaScript, the more we introduce JavaScript, the other part that also happens is you need to execute more code, the browser on the fly, and which means a lot of JavaScript JIT compilation happens, and which means it can occupy more of your frame budget. So you need to be cognizant of that. So that's where kind of native apps hold the edge because everything is in binary and there's no real compilation or execution that is actually required. So there have been efforts that are going around WebAssembly where you want to package binary data for the website and so on. Yeah, but always remember that whenever you're facing some performance problem of your rendering, always measure first and then optimize later. So unless you measure, you just don't go by standard patterns, like prioritize what you want to do after measuring the data that you have. I think that's all I wanted to speak about. Like you can open for QA. Yeah. Yes. Thank you.
Hello. Yeah, one thing that you haven't mentioned is there is a UX part of performance, right?
Right.
There are a lot of websites when they're loading, some content comes up.
Right.
But the moment you go to click there, right, the page gets relayed.
Right.
The layout changes and then you're clicking somewhere else. So what tricks can you use to make sure that your page layout and the sizes remain more or less constant while stuff comes in?
So one of the things that you can definitely start measuring the data and see when the paints are happening, at what parts of the page the layout is getting triggered. So if you're interacting on something and there's a layout that's getting triggered, which means before, the interaction JavaScript executes and starts another, maybe it can skip a frame and kind of, people call it something called screen tearing, where half of one frame loads and another frame jumps in, and a lot of, you don't see normal behavior there. So the best thing is to optimize and see what is happening and ensure you're not really reloading when something is happening. I think as a follow-up to the previous talk, you asked a question around if you're rendering React from the server, how do you ensure that there's no reload from the client-side React? So when you use render to string on the server using React server, it kind of inserts a React checksum attribute to the DOM that it renders. So using that, the client-side React uses that to see how much has already been computed and doesn't ensure it repaints those. So that is something that you can look at, especially if you're using React, and ensure that it's not always triggering layouts unnecessarily. Yes.
There are no more questions. Hello. If there are no more questions, as Jai pointed out, we're doing a Birds of Feather session this afternoon at 2:50 p.m. in the Backend on what should you measure when you measure performance. So the speakers from this morning and some of them who are speaking tomorrow will be there, and we'll have a discussion over there on various aspects of performance.
Thanks a lot for listening in. I'll not stop you from being more hungry.
Yeah, all the mics are working.
Hi everyone, if you could please settle down. I have a couple of announcements to make before we resume the program. Okay, so we have a birds of feather session starting at 2:50 at the banquet hall, and the speakers are all on your schedule. So that's not going to be live streamed, so if you guys want to attend that, you're welcome to go over there. The food coupons for day 2 will be handed out tomorrow morning at the registration desk. You've all been given feedback forms. Please fill them before you go home today. And the submissions for flash talks are now closed. We'll be announcing the schedule soon. Okay, our next speaker is Arnav Gupta from Coding Blocks.
Check. Check, check, check. Yeah. So It's on.
From the basics and a little bit about what OS hooks we can put into Electron and how we can build, ship, maintain cross-platform projects in Electron. So just to start with, I'll just tell about the architecture of Electron and what are the components in it. But before that, how about, let's say, in 5 minutes, how you can make a simple Hello World desktop app using Node.js. So Electron has made it really very easy. So it's as easy as you go install the NPM module called Electron. Earlier it was called Electron pre-built, but from I think a couple of months before, it's now you can just use the package name Electron. While you're installing that, if you want, for example, so since Electron is a native module, so since if you want to install the 32-bit version on 64-bit OS, for example, you might want to do that on Windows or on Linux. So you can also give the architecture name and download accordingly. You basically, just like any Node.js project, you would need a package.json file and main.js, which is going to be our main script, which is going to run, and an index.html file. So this is the one which will be our UI in our app. Okay. So one very important thing that we need to add in a Electron project is in our package.json, if we add the key entry called main, and this basically tells which script is going to start when you start the app for the first time, right? So you just point it to main.js. Let's just look at the script and we will understand it in detail. But you create a function called create window, and we create a new browser window of a given width and height, and we load the URL of our file which has our UI, which is the index.html file. And whenever the window is closed, we just nullify the intent. We require Electron into browser window and app, and we have a simple event called ready. So whenever you open the app, we have the app becomes ready, and at that point we can load the UI of it. And inside our index.html, we just have just a simple hello world and the version of what version of Node, what version of Chrome, and what version of Electron is running. So just about this much, and you run it, you will get this on your desktop screen. So this will be just like any desktop app you open. It will have its own window, it will have its own menu, and on it you will be seeing whatever was there in your index.html file. So to understand basically what is Electron, how it came about. So I guess everybody knows about Atom, right? The Atom, the text editor made by GitHub, a very good text editor for web development. So when GitHub was building Atom, they wanted to build Atom using web technologies. So they basically did was they forked the source code from the Chromium project, which is Google Chrome, and they removed everything in the browser, for example, your history and your URL bar and all of that, and just made a simple shell inside which you can run a web app. So just if we try to understand what are the basic differences in Chrome and Electron. So here is how the way things work in Chrome, for example. So we all know that in Chrome, Chrome brought about multiprocessing. So basically each tab has its own process separately, and there is one main browser process. So if anybody of you have noticed, when you open your task monitor on your operating system, first time you open Chrome, there will be two chrome.exe processes, and further on, you keep on opening tabs, there will be like n tabs, there will be n chrome.exe processes and one main one through which the OS level things are accessed. So your V8, which is the JavaScript rendering engine, the WebKit, which is your HTML rendering engine, an instance of each of these are created inside your renderer process, which is there for each of your tabs. The APIs with which you are doing network communication or storage or your GPS, the location, and the user interface of the browser where you have your everything, your back button, your URL bar, and all of that, that runs in the browser process. Then in the internal API, basically at the C++ level, there is something called a resource message filter, via which communication takes place between the renderer process and the window process. So this is the kind of architecture that Chrome uses for their browser. So what GitHub did when they were building Electron was they forked libchromium content. So libchromium content is the part of Chrome inside which your V8 and WebKit part is rendered, like basically the document API and not the browser API. So they forked that, and inside that we are able to run our HTML and our JavaScript and all of that stuff. And so this is how basically the architecture of Electron looks like. So instead of the browser process, now we basically run a Node.js process inside which we have all our native APIs, everything that you can do inside Node.js without any restriction like you have on the browser side. You cannot access files which have not been put into the upload window. All of the restrictions are gone. The sandbox is not present anymore. It can have full access to the operating system. It can do network storage work. It can access the GPS. Anything that's available to Node.js is available to the main process. Each window, when we're using Electron, basically we are talking about windows instead of tabs, because, for example, like you're using Microsoft Word, you can open up multiple windows for different documents. So like that, we have different windows. So each window works very similar to how tabs work in Chrome. And instead of the resource message filter, there is a JavaScript level API here, which is called IPC, which stands for inter-process communication. So this is how basically the architecture is set up inside Electron. So how basically the processes are different. They are running on to this part, the top part, that's running on a separate instance of V8, the way Node.js runs. Any JavaScript that you put like inside a script tag in your HTML, which is going to come up on your browser, that is going to run on a separate V8 instance. So these two things cannot directly interact with each other as such. So for that, the IPC exists. And via the IPC, we have got basically there are certain things, like there is the shell, the screen, the clipboard. These share a common context. Everything else we have to do very similar to how we use in Socket. How many of you have used Socket, socket.io? Okay, so Socket, you have a basic idea of how you can send events from the client, get them on the server side, send events from the server side and get them on the client, because it's the event emitter API. So here it's very similar in the inter-process communication inside Node, inside Electron, sorry. You create a channel, which is just like creating a WebSocket, and then you can subscribe to particular messages, which is like creating a on function, and you can receive messages, which is using, in Socket you have emit, here we have got a send function. So you send a message, inside the message you can send any kind of an object, any kind of data you can send, and via that you can basically interact with any one of your renderer processes. Each of them will be different IPC clients, and there will be one main process which can interact with it. So for example, you want to drag a file into your app and it should save it somewhere. So you will have to send the object of the file from your renderer process into your main process to be able to save it to your file system, because your renderer is just like any web app. It does not have access to your file system. Your main process has access to your file system. Similarly, you can also do asynchronous stuff via sending callbacks instead of sending objects directly. So both the things are available inside IPC. So everything that you can do in a web app, whatever you can do with HTML, JavaScript, CSS, that is possible. Beyond that, when we are talking about desktop apps, there are certain more things we want to do. For example, creating menus, creating a notification tray icon, and having our app run in the background. So all of these things, there are various APIs available inside Electron to access them. So first of all is menu. There are two kinds of menus. One is an application level menu, which is basically when you open an app and you see file, edit, view, all of those things. And then there is the context menu, which is available when we say in our browser, we right click on a word and we get spell check inside it. So creating menus is a very easy thing in Electron. You create a template of your menu, give a label to each root item, and then you can create a submenu, give labels to each item, and you can then assign any function inside that will take place when you click on that thing. You can also assign radio buttons and selectors inside your menus. So there's a menu object inside Electron. Inside that we have got a set application menu function, using which we can create application menus. Then, for example, if we want to create context menus, for example, the option shown here, this spell check, by default, the render process does not have something like a spell check, but we want to add something like a spell check. Then here we have to, as you can see, create the menu from the remote. So the remote, when we do require Electron, we are basically getting the reference from our main process, because this code is inside our render process, inside the JavaScript that will be running on the UI. So here we need to get the reference of menu from remote. Then we can create the menu, and simply you can then add it to the context menu event, which happens every time when you right click on any part of an HTML, the context menu event comes up. You can fire up that menu and show the options from it. Then comes trays. So a tray is basically like on the Mac, the top right part of the notification tray, Windows right bottom part, notification tray. So if you want anything inside your app to keep running without a window, something like a background process, so then you can use trays. There is a tray API, and mind it, this part again, it's HTML only, because everything that we are doing here is going to be just like a Chromium window. So it's just like a Chromium window here. You're writing it in HTML. It's not a default native OS UI as such. Then we have got notifications here. So by notifications, notifications work very similar to we have in HTML5 apps. Just using your HTML5 notification API, that will work, because the front-end part, anything that's available as part of HTML5, that's going to work here. The latest version of Electron uses the same libchromium content API as is available inside Chrome version 44 and above. Then we also have the recents API. So if your app is something like the Atom app, which can open files, so you can have recents, which will work even if your app is accessed from the quick launcher in Windows or from the dock in Mac. Then we have got launcher menus. Now, this part is something when we are going to do cross-platform, this differs for all the 3 platforms having launcher menus. So basically, if you have put, say, Firefox in your quick launch menu, you will see that you right-click on it, you get 2 options. One is to open Firefox, and another is to open it in private browsing mode. Similarly, you have Chrome in your dock, you will see there will be 2 options, one to open to Chrome directly and one in your incognito mode. So how to launch app in different modes? These things happen in different ways. So for Windows, there is an API called the jump list API, which is very similar to Windows native development you're using in .NET. There is an API called jump list. Similarly, you create a jump list. Internally, like the object of a jump list will be very similar to a menu object. You can create a label, an icon, and a task, but you will have to add it to a jump list instead of adding to a menu, and it will work like this. You will get options like this here. In OS X, it works entirely differently. So here we have to add a menu to the app itself instead of using jump list, and those basically come up here in form of options. And finally, in Linux, there is no requirement to add anything inside your Electron app as such. So in Linux, when we save our app, a shortcut in a .desktop file, there we can add different tasks to it, and like the 3 you can see: previous, change wallpaper, live auth wallpaper. So this is something that's that happens outside of Electron as such. So how basically do you debug Electron? So obviously, in the renderer process, you open the developer tools in the window. But your main process, that is not that straightforward to debug as such. But what you can do is, when you are running the app, you can do Electron and add a flag called debug or debug BRK. So using debug, it is a simple debugging port is opened up. Using debug BRK, it also adds a breakpoint on the very first line of your JavaScript execution, so that when you open your debugger, your app is actually paused. Then you can add your own breakpoints and start working on it. So you do this, and then you can simply create a script like this. You start your app, use the debug port 1337, for example, run node inspector. And then you can also do is you can use Electron itself to open another window to debug it. Or you can, like here, you can write Electron, you can write Chrome, you can write Firefox, anything. You can use any web browser to debug it. But usually, most apps use a script like this. So the app runs, and another Electron instance opens up to debug the main process. Coming to how you can actually distribute it. So at this particular state, you have got, say, your HTML files, your JavaScript files, your CSS files, that is creating your UI. You have got your Node.js scripts running your backend, but you are able to run it only after you have installed Electron locally into your system. But how, when you have to distribute it to your end users, then a lot of things come up. First of all, you need to rebrand it, because the Electron binary as such comes with an icon, the Electron icon. It looks like the Atom icon, and the process and the application in your recents, everywhere it will be called Electron, although it's your app. So that we need to change. Then we might need to package it. So like there's going to be a lot of source code files. You can package it in form of ASAR. ASAR is an it's just like a tar file, but it's an Atom archive. Then we can package all of that together into OS specific binaries, exe for Windows, .app folder for Mac, and a binary file for Linux. And then we can also create installers for it. And finally, we can also enable auto updates into it. So when we are enabling auto updates, again,
when you create your app for the first time, it's going to contain your source code, plus it is also going to contain Electron, the binary itself. And the Electron binary itself is going to be 40 MB in size. So when you're going to program auto updates, you would want to only update the change in your code and not update the whole app again, because the whole app will, just the Hello World app itself takes 40 MB in size. So the package structure looks somewhat like this when you basically build your Electron project. So for example, the name of the project, if it is Electron, this could be whatever name of your project is. In Mac, it creates a .app folder. There will be contents, resources, app, and in that you will have your source code files. Or you can just package all of these things into an app.asar. Asar is, just like said, it's just a tar archive. It's not any proprietary format. It's not encrypted. Source code is easily visible inside this. So this does not provide any kind of source code protection. It is just a bundling thing. For Windows or Linux, there is no .app concept here. You can just put it in a resources folder. So this resources folder basically becomes your distributable file at this point. Then you'll need to rebrand the Electron binary so that it does not, you run your app, it does not show the Electron icon and the Electron name. So rebranding it is very easy. In Windows, Mac, Linux, and all three of them, you can just change the name of the binary. From electron.exe, you can name it whatever you want it. And inside Windows apps have the icon file embedded into the exe, so you can use any kind of a hex editing software for Windows and change that icon. There are a lot of tools available. We're going to just cover it, which does this automatically for you. So there is Electron Packager and Electron Builder. Electron Packager, what it does is it creates these exe app and dist folders for Windows, Mac, and Linux respectively. Electron Builder works alongside Electron Packager and creates a Microsoft installable or a DMG or PKG for Mac, or it can create a Debian or RPM package for Linux. Using Squirrel, you can configure auto updates. Using Squirrel, you can configure auto updates in such a manner that only the source code gets updated, just your HTML, JavaScript files get updated, not the Electron binary all over again. Both of these NPM modules are available in form of a global install for a command line method. You can also install it locally and use them with Grunt or Gulp or whatever is your favorite CI tool. In the future of Electron, there is just one very important issue being discussed these days is about that thing, that the Electron binary is 40 MB in size. So the Electron developers are thinking of making something like the Java runtime environment. We can have an Electron runtime environment. People can have like, my app works on Electron minimum version 1. So if there is Electron version 1 or above available with the user, so only the HTML JavaScript part gets downloaded and it gets run by the Electron binary already present on the user's setup, which had been the case with Chrome apps already, but they are now slowly getting shelved off. I think they have disabled the APIs for new apps already. There are certain UI kits available like Photon and React Desktop. So just like CSS frameworks basically makes your whole app look like the Mac environment or the Windows environment. React Desktop has both. There is Photon Kit, which has a larger Mac framework library, can create a whole Mac app kind of feel, but Photon does not have Windows or Linux shell, but they are developing it. So the things that we discussed today, the APIs you can get on github.com/championswimmer JSFoo Electrons example. So I have created it step by step, adding each component, the menus, the notifications, all of these things. There's a demo here. You can also check out a lot of tools and libraries available for Electron at Synresaurus's repository called Awesome Electron. So you can get about what components are available, what tools are available, what build packages are available, all of that stuff. So that's it for the presentation. If there are any questions from anybody.
we have a lot of modules, right, in Node. So Electron is one of them.
Yeah.
When would I use it? Like, see, a normal hello world example can be done in a very simple way. So when it is required?
So first of all is if you want to make something cross-platform and don't want to deal with Cocoa for Mac and .NET for Windows and look at GTK for Linux and all of that stuff, you can just make your whole UI in web and you can ship it to all the 3 operating systems. Some very good examples are Visual Studio Code is built with Electron. The Slack desktop app is built with Electron. There is also some unofficial Messenger and WhatsApp desktop apps. So they just run whatsapp.com, web.whatsapp.com, but everything is cached into your local folder, so you don't need to sign up all over again. Notifications come as native notifications. So that you can do with Electron. You want to create something like Atom, that is also possible.
Also, can I use any other library like jQuery with it?
So on the renderer side, you can use anything that you can do with a web app. You can use any front-end library that you want to.
What if I want that it should not, it should basically disable the node environment if I'm writing?
It should disable the node part of it.
Yeah.
So that you can just distribute it as form of a simple web app. Like this only, so what Electron as an extra is providing you is hooks into the operating system.
Okay.
You can run it as a native app, you can put a tray notification with it, it can keep running, you can like have, say like when you close the window, it hibernates and it comes back, so the state is preserved. Like.
Okay, thank you.
Yeah, somebody.
Hi. Right, on your left. Hi, can you hear me?
Yeah.
Right. So great talk, by the way.
Thank you.
So I wanted to ask you about the whole file reading process. So when you're using, say, Atom at this point, if I have a bigger file when I want to open on Atom, it has a bit of a tendency of crashing.
Yeah, so the performance part
that?
is that it is, at the end of the day, the whole thing is going to be loaded into a V8 engine on the renderer process. And any performance issues you have with V8, so that is going to come up here as well. Like if you cannot open a file inside, say, Chrome, you cannot open it inside Electron either. So that is there. That problem is definitely there.
Right. I've got another question for you then.
Yeah.
So the dream is to build one web application which can run on the browser as well as on the desktop, right?
I didn't get you.
Sorry. So the dream is to get one web application which you build, which runs on the
for both
browser.
the things, right?
Right.
So I'll tell you what you can do. A very good example is you create the backend in Node.js as a web server separately, and you create the front end separately. Okay. You basically, when you are deploying it as a web service, you're just creating, say, sockets or REST connections between the two, right? So here in the Electron app, your Node.js script can run its own server as well, right? And just you're saving your files on the server. Instead of that, you use the file system API of the user, save it in his documents folder or something like that. So there are a lot of examples. So recently I was making an event management system, and it is available both via web service as well as an Electron app. So inside the Electron app, the server-side script is also part of the Electron process.
Thanks.
Hello. Hi.
Yeah.
Thanks for the talk. Should I speak? Yeah. So in order to port an existing web application, for example, right?
Yeah.
What kind of effort does it require in general? Let's say it's a medium-sized web application and you want to port your existing application to a desktop application.
So the front-end part is not going to take any effort because you're just loading your HTML file and it works right away, right? And if it internally uses a server, a backend part of it. So if your backend is, say, written in Node.js, then I would recommend you port it to Electron itself, because it's going to require only a few changes in the files where you're saving and all of that, where you're creating the server and the port and all of that. So instead of creating a REST server, you can use IPC to communicate between the backend and the front end when you're doing it for Electron. But if it is not, if your backend is not in Node, then your desktop app can communicate over the internet, no issues with that.
Yeah, so these are the things that you would do when you are starting your project, right? So for example, if you have an app, are there like very complicated things that do you reach a dead end where you cannot move forward in order to create a desktop application?
So my experience with Electron has been that mostly I face a limitation with performance issues because Node can handle things at a certain speed and a certain size, of course. So for that cases, you can always package some native libraries into it. For example, if you want to write some part of your code in C++ and compile that in forms of native modules for each of the 3 operating system versions. So your node can just call the C++ program and run it. So you can have, there are some libraries available which have Golang and Node.js bindings.
Okay, great, thank you.
Hey. So you said there are OS specific hooks, right? Like OS specific APIs which we can use.
Yeah.
So is it possible that I'm creating for 2 OS,
yeah.
I write different modules for separate OS, and
yeah.
while building I get the correct OS like this?
Yeah, you can just do process.os and it gives you Darwin or Linux or Windows, and you can put an if-else condition for that.
Module I'll have to check. It's not like that while building it will automatically take the module.
That you can put inside your gulp or grunt task, because Electron packager and builder, they build separate packages for each operating system. So you can configure that part of your gulp or grunt task list.
Okay. Hi. Here.
Where? Okay.
So you told about the debugging part.
Yeah.
So is it possible to debug it remotely?
If like you have a static IP address or you can port forward your laptop, then yes.
No other way?
No other way, no.
Okay.
Hi, hello, on top here.
Yeah, okay.
So basically, can you hear me?
Yeah.
Yeah, so basically, jsjargons.com if you've seen. So, so the backend is an Express app connecting to Mongoose. So do I keep it, do I package it along? So it is, on the front end we use technologies that we can package it while building the app, right?
Right.
But on the back end, since it's an Express app, do I keep it local to this particular Electron app?
Keep the Express part in your Electron and connect to Mongo over internet. That's what I would suggest.
Oh, you still want to hit the DB online, right?
Like, is your
Mongoose,
DB user specific or your DB is centralized? If your DB is centralized, then it has to be somewhere else, not on the desktop, right?
A little part of it should be user specific, and then the others, the generalized data should be.
So you can use a SQLite DB for the local part here,
Okay.
but the centralized MongoDB you connected over the internet only.
Okay, and we also have service workers running.
So that will work perfectly. The
Is
service
the
workers
Chromium of Electron supports it?
Yeah, it does. There is
service
a
workers too.
If you're using Electron 1.3 and above, then service workers run on it.
Oh, okay. Thank you.
So, if there are other questions, then I can take them offline.
Yeah.
Right?
Time up. So, thank you, Arnav.
Can you guys hear me?
So the next speaker is Akash Goyal.
Yep. Are you guys settled? Hello. So this talk is going to be about Cheapass.n and all the fun I had while building it. First of all, thanks to everybody for coming up for this talk and to HasGeek for putting me up over here. That being said, my name is Akash Goyal, and as of today, I work at instamotion.com, where most of my work revolves around enabling payments across devices, across internet connections, mostly for Tier 2 and Tier 3 Indian cities. This is how I can be found on the internet, and I happen to love the web and the web development that comes along with it, mostly owing to the amazing community that the web has. I also happen to work on Cheapass when I have enough time and inspiration, that being a side project. So in its very current form, it's a very simple to use price drop alert service, which accepts a price drop, a product URL, your email ID, and as and when it figures out that there's a price drop alert that happened, it shoots you an alert, through your email ID or through a push notification. The service was launched about a couple of years back, more than that. And ever since then, I've been sort of single-handedly owning up to different roles that come along with maintaining a product, be it product management, be it support, social media management, sales and marketing, and whatnot, right? So it's been a pretty fun ride since then. So I would love to give you a brief idea about the scale at which Cheapass is currently operating at. So to back that up with some numbers, it's being used by about 5,000 active users as of today, tracking more than 30,000 products in total. It has sent over 5 lakh price drop alerts and helped people save about 10 lakh rupees in total. Now, you don't have to take my word for it. Here's a sample report from Amazon since when the service has been running. You can see about 1,000 products have been bought by people ever since the service was started. And this is just on Amazon, right? The total amount of these goods purchased were about 25 lakh rupees in total, right? And Amazon paid me a tiny commission for helping them make more sales. Ever since the service was started, it garnered a lot of interest across a lot of hot platforms. It made it to Product Hunt, Hacker News, stayed up on Hacker News for more than 5 hours on #1 spot. It made it to React Rocks, and a bunch of other publications. Sorry about that. Which mentioned Cheapass as one of the best price tracking services for Indian websites. It has also been appreciated a lot on Twitter. A lot of folks with a lot of following have recommended to use Cheapass to their followers, right? And what this has done is brought in a lot of organic use to the product. A lot of people saying a lot of good things about it. People having genuine reach, a lot of genuine users coming in because of that. Somebody pretty happy with buying cheap shirties from Cheapass. So before I go on to the core of the talk, I would like to take a brief moment to thank all those people who work behind the scenes, writing free code, open source software that Cheapass currently uses. So Node.js, Redis, MongoDB, Webpack, React, Redux, Grunt, jQuery, Babel, whatnot, right? A bunch of technologies powering Cheapass servers. All right, so in this long journey, I have learned a lot of things to be honest. So let me cut to the chase and present the 5 top tech learnings which I had while I was building this. So a lot of backend folks or Node.js folks or folks who have used require.js must be aware of this thing called dynamic require. What it basically is that you put in that require statement within a function, and you call that function as and when you need that, right? Sort of lazy loading a module as and when you require that. And if you compare that to statically loading a require module, it basically puts it up in memory as and when the node process boots up, right? So look at this harmless little function, whose entire task is to send an email, which depending on a condition, it will either require the SES module over here, or it will fall back to the the regular way of requiring things. Now, raise your hands if you think there is something which can go wrong with this code at scale. How many of you think that something could go wrong with this code? Okay, no one really. All right. So what if So what if I give you a little hint and say that if you call this function 1,025 times in a synchronous loop, in a for loop, there is something that could go terribly wrong with this. So what really happens is, for every single dynamic require that you do, a Unix machine opens that file in memory, right? And when that happens, every single Unix machine has a upper limit to the number of files that can be simultaneously opened on that process, right? So how I discovered this was when I was sending mass emails to folks who were using Cheapass about new features that I had built. This code worked pretty well. The number of users were in less than 1,000, and when the number of users went beyond 1,000, my code just stopped working one day. So it was a pretty interesting find. So all I had to do was honestly to pull these dynamic requires up as static requires, and the code scaled pretty well. So the dynamic require is a pretty terrible idea at scale. I mean, if you're not really sure of what it does, be very careful of what you're trying to do. the databases. I mean, as a front-end engineer, I've hardly ever touched databases and backends, right? And when I was starting Cheapass, the concept of good schema designs was pretty alien to me, to be very honest, right? So this is what I came up with very initially. So if you look at this schema, I'm using MongoDB, a NoSQL solution. And what I've done over here is I have put in one schema within another schema, which is available as an array inside that, right? And that schema, which is present over here, is nothing but product price history, right? So every single time Cheapass goes out to figure out what the price is currently, I sort of need to bring this array into memory, add a new item to that, insert this whole document back, like sort of update that document back, right? So at scale, what I figured was arrays as updatable document value turns out to be a pretty bad idea. Why? Because insertions, updations, aggregations, whatever you're trying to do with arrays, that doesn't really scale because MongoDB gives you enough power to do things with documents within a collection, right? But when it comes to processing things within arrays, which are stored within documents, it doesn't really help you that much, right? So all I really had to do was pull out all these items from array into its own collection within as their own documents, right? And then MongoDB assisted me immensely when it came to doing a bunch of operations, since these are price values, right? So to figure out, is this item a good buy at this price or not, right? So a lot of maths had to be done in the backend. So what I realized was creating multiple documents. All right, some random game, anyways. So it's okay to have bad schema designs to begin with, Scale teaches you a lot of things and you will be able to refactor your schema as you go. So don't really think about, is this a good schema or not? I mean, just go with the flow and just work on the side project you are working on. So let's continue the same database example further. And let's say I want to process all those price points which are stored in the database in whatever format, doesn't really matter whether they're stored as documents within a collection or as items within an array, right? So this is the Cheapass homepage, which shows you every single item which folks are tracking on Cheapass website. And it sort of has some logic to it. It sorts it by the most hottest products. It shows whether or not this product is a good buy at this price or not, and a lot of factors that come in, right? So a lot of processing has to be done in the backend to figure that out. So this is some initial code which I wrote to process this data in the backend. So forget about the clutter and focus mostly on the find and the async each and the find once, for instance, over here. So what the find actually does is it copies all the relevant results in your memory, right? And what I mean by that is that whatever query you supply to the find, that will basically go to the database, pull out whatever the relevant results are, and put that into your node memory, right? And when that happens for Cheapass, it's every single product which exists on the platform, right? So a .find is not a very helpful operation when you're trying to do something like this. So I talked to a bunch of folks at the workplace, and they recommended me, why don't you go ahead and use something which a database exposes instead of an API which a database exposes instead of you relying on pulling everything in memory and then processing it, right? So what I did was use this thing called aggregate, which works directly upon a collection. You can pass in a query over here, which I have done. Say I have asked it to group by some minimum price, right? And believe me or not, what it did for me was it brought down the time to process from 4 minutes to about 8 seconds. And this is an year back. This was tweeted back in 16th of May 2015. So I mean, this code helped me scale at that point in time, right? And that code is still powering the products that you see on the Cheapass server. So it was a pretty good, interesting find, which as a front-end engineer, you would probably never really encounter. So pulling data in memory to process is a pretty terrible idea at scale again. I mean, you have to be really careful of what your find statement is bringing in memory. Spawn with care. So we tend to spawn a lot of processes in the backend, right? So say, for instance, we want to generate a PDF document for an invoice. So how will you do that? No matter what backend you're using, you will have to create a new process which will do this particular job for you and store that at some location, right, for your primary parent process to read from. So what I was doing was using something called as capture.js. Now what capture.js does for you is, it's a wrapper over phantom.js, which helps you in taking screenshots of the page. And you can even pass a selector to that while you're trying to spin up this process. So what happened one fine day is that Amazon changed their homepage. And what happened because of that was capture.js had a existing bug in their systems, wherein if you pass a selector and it's not found on the page, then it basically does not talk back to the existing node process, which spawned it. Right? So for the simplicity of this discussion, let's say there is some sort of inter-process communication happening between Node.js and Phantom.js at the moment. And this communication just got disconnected, right? Didn't happen. So due to the code that I had written back then, simply relying on the fact that Amazon's DOM will always be present, my code spun up a lot of such processes. And when that happened, as soon as I would start up the server, the memory would be flooded with capture.js processes, Phantom.js processes, right? So never rely on systems you sort of didn't build. This is my key takeaway from that again. I mean, if you are spinning up a new process, make sure you clean up after you are done. And otherwise, make sure that you put a good end to it. Never leave it hanging out there. So this brings me to my next point. Never rely on systems that you didn't build and you don't have ownership over. So Cheapass sort of relies on a lot of third parties to be up and running. For instance, Flipkart should always be running, Amazon should always be running, and whatnot, right? So here are my top 3 learnings out of that. One would be cookies. So what happens is backends can track whether or not you are sending a cookie along with the request that you made. And if you're trying to make a server-to-server request, then your request client does not send a cookie by default, right? So what if the backend server at Amazon decided one fine day that, if the client is not sending me a cookie, it means it's a bot. So let's just block this request and throw a bot page at that. And that's what happened one fine day. However, what they actually do is they will send back a cookie in the first request that you made in its response. So all you can really do is, grab that cookie from the first response, make another request with that cookie, and make yourself sound like a genuine user. It's also called as a cookie jar. Any patterns that you are trying to have while you are making, requests to a third-party server, that is a nightmare. I mean, if you consider, if you say make 30,000 requests at 12 p.m., 6 p.m., 9 p.m., 12 a.m., then pretty sure there are smart folks at Amazon who can figure out that, this is a bot server who is making requests. So that has happened several times with Cheapass. I mean, I'm not really sure if it's a legit way of doing it, but what I did was, rotated the IPs, random proxies, user agents, and, made sure that I avoid the honeypot while I'm crawling. Content security policy is a very interesting new concept in the new domain. Flipkart recently implemented this, where what they did was they ensured that only secure origins can be injected onto their page. So if you happen to rely on bookmarklets or extensions, then you do need to push in some JavaScript onto the parent page, for your code to work. So you're pretty much screwed if that's enforced. I mean, there is no way around it. But thankfully, Flipkart reverted their decision very soon. So yeah. So those were the 5 top tech learnings out of that. Well, as I told that, I was also responsible for the growth of the product, making sure that people came in every day to Cheapass and used that. Here are the 5 few growth hacks, as I would like to call them. Okay. So genuinely offer privacy. I mean, people claim a lot about privacy. People say that they're not selling you data and whatnot, but I don't know. I mean, I never rely on them, right? So what happens at Cheapass is everybody gets a unique dashboard link. Nobody's dashboard link is same. Everybody gets a unique price tracking link per product. If you and I are tracking the same products, you and I will have 2 different URLs for the same price drop alert that you have been tracking. There are no passwords to crack. It's a OTP only login, right? So if you as an independent developer are trying to maintain a project, then why do you really want to have the hassles of security in that project, right? Spam for profit. If you're trying to grow a product, you at some point in time will need to send out emails telling people about what new cool things you're doing with that product, right? But I honestly do not, again, appreciate people sending me emails, random emails, right? So how do you go about this problem wherein you really want people to come back to your website and you also do not want to spam them? So what I did was I captured live deals from Amazon, Flipkart, etc. in real time, and sent them along in these emails which I was sending. So this is a real price drop alert email that was sent. I basically captured through that capture.js process a screenshot of a live deal that was on Amazon at that point in time and shot them an email. And it said that industry standard of open rates is about 4 to 5%. People are really happy if it's 8 to 10%. And Cheapass emails have had about 40% open rate consistently, and that's pretty good. Tiny incentives go a really long way in India. I mean, what I did very initially to grow the product was I partnered with FreeCharge. I bought a few thousand rupees of coupons, and I asked people to post about whatever they are buying through Cheapass on social media, basically rage about us on social media, right? And they actually did, right? So people posting pics of whatever they have been buying, right? People buying iPhones, some dresses, all for the sake of some 25 or 30 rupees or 50 rupees of coupons. People do that. Creating more clients is really easy. We as developers often tend to miss out on the fact as to how will the consumer want to consume our product, right? We build a website or we build an app. We don't really care about where is my janta lying? How are they actually consuming my product, right? So what I did was I created several different clients for people to consume Cheapass the way they want to, right? There's a website for it. There's a bookmarklet for it. There's an Android app. There's an iOS app. There's a Twitter bot which tweets out real-time price drop alerts. Right? So same endpoint consumed by several mainstream clients, which people like to consume on a daily basis. There was a one-time effort in building the iOS app. I collaborated with the designer, got the design done, coded the React Native app myself. And once this was shipped, the Android app sort of rewrote itself. It wrote itself. I could reuse the 100% design of the previous application I had built, and the React Native components could be used up to 80%. I had to rewrite very little code to power the Android app. For instance, here are the iOS and Android screenshots. I mean, they look pretty much similar, except that you see a pretty native component. You see native components on both the screenshots. That's the beauty of React Native. Here's the Cheapass alerts bot I was talking about. It has sent about 1 lakh tweets already. And it's a bot, and some 232 people track it, follow it. To end the talk, I would like to give you some gyan with whatever I've learned over this last couple of years. There is no perfect product. Never really rush behind a perfect product. You will never really finish that. It's okay to have outdated libraries. What the technologies that I showed you initially, they are all outdated currently on production. I mean, I'm still using Node.js 10.32. I'm using some MongoDB version 2.32, and the latest are, Node is 6.0 right now, more than that probably, right? So it's okay to have outdated libraries. I mean, your code scales. It's okay to not build everything you can dream of in the first cut. I mean, take your product as people want it. And it's great to get that feedback from consumers, because the revenues which I showed from Amazon, that wouldn't have happened if somebody didn't ask me to build for Amazon. The product in itself has been evolving for over 2 years now. The iOS and Android apps were basically read-only apps to begin with. Only when somebody asked me, why don't you build a mechanism wherein I can add a new product through the Android app? I was like, cool, let's build it. And I did that. Right? And build something and ship. You will never really finish that side project you've been working on. So if you really want something done and something of yours out there, just build and ship it, because there is no perfect time to do things. Just do it. That's it. Thank you. Any questions?
Hi. Am I audible?
Yeah, sure.
So you mentioned that you had some problems with arrays in MongoDB.
Right.
Yeah. So I just want to, can you please explain a bit into detail that what were the problems you faced? Because like I have very minimal experience with Mongo, and like except array upsert, I was able to do most of my operations. So just
right. So what I want to tell you about arrays is that every single absorption you are trying to do on an array that requires you to pull out that array in memory, and then probably insert an item and that insert it back, right? And if you're trying to do a lot of processing on those array items, then MongoDB does not really give you aggregation level APIs, which it gives you with documents within a collection. Right? So if you put those array items, say, within a document, within a collection, then only you can consume, say, .aggregate API, which MongoDB exposes. So that's where I told we're in, 4 minutes to 8 seconds, sort of a improvement in processing.
Thanks.
Yeah. That's it. Thank you.
Thanks, Akash. So before we get on to the next talk, just few notes. We have a BOF session, the Birds of Feather session, happening in the banquet hall. And separate food coupons will be handed out for tomorrow at the check-in counter. And the next talk is by Maninderjit Bindra. This is a sponsored session from Microsoft.
Hello. Yeah, thank you. Hi, I'm Maninderjit Bindra, Mani for short. I'm a senior technical evangelist with Microsoft. A bit about myself, I've been developing applications for more than 16 years now. And as a part of my job, I work with startups, customers, help them build scalable applications on the cloud. In case you're wondering about the t-shirt, I'm also the Docker community mentor for the Mumbai Docker user group. So today's talk, I'm going to be talking about using JMeter for load testing and what we can achieve using JMeter, combining it with the power of WebDriver plugin, and why we should do that. Some of my experiences working with startups, I'll share those along the way. So very quickly, I'm just going to discuss, I think many of the sessions have already covered the aspects of why measuring performance. I'll just add a couple of points from my perspective. Then we look at JMeter, what Apache JMeter is, what Selenium WebDriver is, how they work in tandem. We'll spend most of our time there, and there'll be, I'll show quite a few demos of things, how they work. After that, we'll discuss that ideally in most cases, why we should use cloud-based JMeter testing. We'll discuss some tooling in that space. And towards the end,
We'll discuss that why it's not sufficient to just worry about performance at the end when you see the performance issues. Tools like JMeter, they're open source, they're free, so just test using them and include these tests as a part of your automated build process or your release pipelines. Yeah, that will really help. So we'll look at how we can do that as well. So before here, so why measure performance? I mean, if you can't measure something, you can't improve it. And normally we develop code based on best practices, and that doesn't always work. So the GitHub repository, which I'll be sharing in the next few slides, that has a link to a presentation by the likes of Kyle Simpson, which is called JavaScript Mythbusters, where they bust a lot of JavaScript optimization myths, one of them being string.concat versus array.join. So till you don't actually test it, things, you cannot not be sure of the performance. And many times I've seen it. So in the startup world, you build a site and then it becomes popular, and then you start getting the load, and then you find out that at that load, you have some things which are breaking, right? So earlier you find that out, the better. How do you measure performance in a repeatable way? Well, this is maybe level 2, but basically if you're comparing application configuration, so you change some JavaScript code and then you want to compare that with the previous version. So to do that in a repeatable way, there are two things. First is that the test should be automated, right? And the second one is the environments themselves should be created using some kind of infrastructure as code, because that is the only way you'll be sure that both these tests are run against the same environment, or you're aware of exactly the difference in the environments. So one of the JMeter tests I'll show is using Docker containers for that part. Okay. JMeter, Apache JMeter is a load testing tool, so you can simulate user load. So you can say that first you define your test in a JMeter file, wherein you can define, okay, call this particular API, then do this, then this next task, and then repeat this for 1,000 users and ramp up the user over 5 minutes. So basically, now what you're doing is, when you ramp up the users from 0 to 1,000, you will see the difference in the response times, right? So when my application had 10 users, the response time was milliseconds, right? Less than a second. But when the number of concurrent users goes to 300 or even 100, that's when you'll see the response time going, or you'll see errors appearing. That is what happens, and that's why we should test early, right? JMeter does some things which a browser can. For instance, you can follow redirects, but it is not a browser in the sense that it does not execute client-side JavaScript. And that's where we use the WebDriver plugin. So using the Selenium basically automates the browsers. Using the Selenium client libraries, we'll have a look at the examples of this in the next slide. But using the Selenium client libraries, you can do tasks like, okay, load the page, go to this text box, add this value, submit it. So you can actually simulate what the user and how the user interacts with the your site. And using the JMeter plugin, all that you can capture using your response times. So this is the GitHub repository. I'll quickly go to the different sections of this towards the end, but this has all the application code, which for the applications I'll be load testing, as well as the JMeter tests for all the tests I'm going to demo. So the application which we'll use for most of these tests, it's the Chirp application, which is basically, it's a mean stack application. It's kind of like a very, very light Twitter-like application, which basically, I'll just show it to you. So you can log in, you can register, right? And then you can just type a very short message, right? So this is the application we'll be testing. And if I was to just test this using JMeter, how I would traditionally do it is I would test the APIs, right? So this particular JMeter test, which I've loaded, what I do here is for once this I do once, I randomly create username and password. Then using the HTTP sampler, I register the user, right? Then the user logs in, and then for 5 times, he posts a message, right? So this is how I simulate. So if I run this test, okay, what it will do is, it will actually start firing these HTTP requests, right? So this is the login, the request, the response, and it will start monitoring all kinds of statistics, how long it took to load. And one key part of this test was, I mentioned that you ramp up to 10 users in a period of 20 seconds. When you actually do this for your site, it will perhaps be 100 users over 5 minutes, right? So that it ramps up gradually, and you know at what point your site is going to crash. And then you know the breakpoints, and you investigate further. If you look at some of the reports, so this test is finished running. So it's given me, for each of the operations, what is the average time, what is the 95th percentile, which is a key metric which people look at. So the 95th percentile, what is the response time? So for one of these operations, it's 480 milliseconds. And the error rate, which is again a key metric. So normally, if you test your site for the first time, I've seen it happening most often. You will see the error rate spiking when you first time you load test your application. I'm just going to open another load test. Okay. So this time I've included the WebDriver sampler, right? So till this runs, what is actually happening is, in this test, we are actually simulating the user interacting with the browser. How did we do that? We did that using the WebDriver plugin. Okay, here in the config I mentioned, okay, I want to test with Firefox. And in the sampler, the code which I've written is open the login page, then in the find the username field, add the username, okay, and then submit. Normally, when you're adding in a load test, you would perhaps only want the WebDriver test to check the load time for key pages in your application, okay? But this is just to demonstrate what all you can do, right? I mean, of course, with Selenium, this has always been there. Maybe we'll just look at another one. So, both these JavaScript files are there on, as I said, on my GitHub repository. So I'm just, I've deployed this array join in a separate Docker container and the string.concat in a separate one, and I'm just, testing that using WebDriver. So the loop count, I've kept it low, right? So if you look at the name of the page, name of the host, that will be different for the two calls. But what we are doing is, this is one way in which you can compare. This is a quick one I wanted to show in the demo. So at the end, the aggregate report will show us that, okay, so how much time? So the string.concat is consistently faster. So as I said, that was one of the myths busted in that tutorial. So yeah. Another thing I wanted to show you guys is the Selenium IDE. Okay, so what we can do with the Selenium IDE, suppose I go to bing.com, okay, I search for JMeter, go to images, I go to videos, I come back to web. So basically the Selenium IDE is recording all this, okay. Now I will stop recording, okay, and so all the clicks, it identifies basically each of the buttons, each of the elements I click. I can now actually replay this. So yeah, it will do exactly that. And the really cool part is here. So now we have a JMeter plugin for the Selenium IDE. So you can actually just record and download the JMX file for your load test right from here. But this creates a lot of extra requests. I don't, I write my own. But yeah, you can do this to quickly get started, to record your journeys and get going. Okay. What else? I'm going to go back, switch over to the slides again. I'm going to just quickly go through the slides, and then again I'll go to some of the tools which I will be discussing. So why do we need cloud-based JMeter tests? You need these at a later stage. Initially, you can just start with the JMeter. But what happens is, can you generate 10,000 concurrent connections from your local machine? No, right? Because your bandwidth locally will become a constraint. You will not be able to generate that much of load. Traditionally, how this was done was using test tracks with several inducers which generated the load, which was quite expensive, both in terms of maintenance cost. But now with the power of cloud, so BlazeMeter is one very popular tool which I've used, where you can just upload the JMX file, and you can then choose the location you want to run the test from, and then fire the tests. You'll get a good response. You'll get an indication of when your application really needs to scale, how well it does that. Visual Studio Team Services is again Microsoft's cloud-based tool, which cloud DevOps tool, which can do anything from iOS to Android builds to all tasks. It also has JMX load testing, where you upload the JMX file and you run the load tests, and you get all these cool metrics about your error rates with that high performance when you have a lot of load against your websites. So as I said, when you need to test your application against really heavy load, you need this, right? Also, when you want to test from a particular location, region where your users typically log in from, it's a good option. This is like why you need to include it in your build pipelines. So if you don't have a build pipeline, I mean, then it's fine. But if you are, you have a nightly build going somewhere, it is a good idea to have the basic JMeter assertions, which are like your response time assertion and your size assertion, which basically tell you that what is the size of your response. So if I hit a particular your home page, what is the size in bytes of your response, and you can set a threshold for that. Beyond that, the build will fail. I mean, the JMeter assertion will fail and the build will fail. And it's really simple to do. It is not expensive at all. So, I would suggest at least those basic tests can be included in your build pipeline. So in this example, this is a case of a Java app using Visual Studio Team Services, where we do a Maven package. We build the Docker container, deploy it to the Docker containers in a different environment, and then before going to prod, we do a load test. So, but again, this totally depends on what your situation is, whether you want to go in for such an extensive pipeline to start with, maybe not. What I'll do is I'll just quickly show you some of these. So this is the GitHub repo. I'll just quickly show you. So all the JMX files are here. This is the, if you just do a installation instructions for the the chirp application installation are provided below. So this is the repository. You do a npm install. I've given the installation instructions, and then you can just fire the JMeter test against that. The other one where I'm doing the string concat versus array join, that is again over here. Okay, I've given the link to that as well. Yeah, here. This is the presentation, Kyle Simpson's presentation, and this is the repository where I'm just writing that JavaScript. So this is the, just wanted to take you through this repository. And just a quick view of Visual Studio Team Services. So as I told you, this is a build where I'm doing an npm install, a gulp. And if I just, the list of tasks available here, you can do JMeter tests, you can do Android build, you can do iOS build. I mean, a lot of the stuff. So it's, as I said, it's a cloud-based DevOps tool. If you have a Jenkins build, you can get the Jenkins build and use VSTS for release management. That is also possible. There are, of course, a free free tier for you guys to try it out if you want to. And here I'm using, this is the whole QA, PVT, prod. I'm using a different tool for the load testing here, but we can use JMeter as well. I think I'll take questions now. That's pretty much what I wanted to cover. If you have any questions.
So when you say JS, you mean JS on the server side or the front end?
So normally the JMeter samplers, they just give you, they don't execute the client-side JavaScript. But when you include the WebDriver plugin, so you saw that user ID password being typed in, that is an Angular app, right? So it won't work. So with the WebDriver plugin, it executes the client-side JavaScript as well, and you can capture the responses.
So you can capture everything which is done by Angular, technically.
By anything which is done by the browser. So basically what WebDriver does is, it drives, so the WebDriver executables are provided by the browser manufacturers. So I mean, Firefox provides its executable, you can do same from Chrome.
Right. So what I'm trying to ask is, if you have a dialog which is coming up using JavaScript,
yes,
WebDriver wouldn't get to know, right? How would WebDriver come into place?
So how will the user interact with that?
You say he's clicking, there's an AJAX request, there's a response.
Exactly. So you can handle AJAX through WebDriver as well, right? Okay. But when you are writing your load test, do you want to capture those things, or you just want to capture the client-side JavaScript execution time or load times? That is up to you. But you can do that. You can do AJAX pretty much to that. Okay. You can do this with Selenium, but the thing is, when I'm doing load testing, right, your JavaScript is executing very well, right? But as soon as you reach 100 users, if you got everything, say in a CDN, your static content, everything is fine. But if everything is being served by the same server, including your static content, you don't have the correct expires headers. Even the static content request will go there and you'll see errors. So that's why with load, you just using Selenium, you don't induce load, right? Absolutely, correct. Correct. That's why. So I mean, you don't, for every few requests, if you include this, you'll need whether the client-side JavaScript, it might test some paths which are not tested by your JMeter API tests. So, for instance, you don't have any API tests, you don't have any unit tests, but where you normally start is the UI, Selenium test, right? So if you write that Selenium test and you, it will cover a lot of the paths which your API tests do not cover. So you will identify those errors. Nothing is foolproof. This is a good way to have this kind of load testing is a good way to include in your, I mean, normal build process, to keep a tab on how your page load times for your key pages don't exceed a certain threshold, because anyway you're running these JMeter tests. As a part of that, even testing the JavaScript client-side performance. Okay. Thank you.
Thanks, Maninder. The next talk is by Cherry G. Matthew.
Testing. Testing. Right. Thank you. Testing. Very good. Right. All right, so good afternoon, wonderful ladies and gentlemen of Bangalore on this warm, sunny afternoon. My name is Cherry, and that's Push down there. And I'm a kernel programmer, and I normally talk about parallel instruction sets and hardware gates, and Santosh likes to think of himself as an unprofessional gamer. I don't write a single line of JavaScript. What am I doing at a JavaScript conference? Well, it happens to be the case that we're both engineers. We think we've got degrees. And we also like to think that we like to program and solve problems. And we both happen to use this device. So that's what brings us to a JavaScript conference in the context of a mobile phone. Now, what is the problem that I, as a user of Emacs mostly, and the keyboard, found when I was using my mobile phone? Well, to understand this, you have to understand how the brain works a little bit, and I have a very basic background in neuroscience. So I'll talk to you about episodic memory. Episodic memory is any memory, basically, that you have a sequential memory of. So I went to Commercial Street, and then I stopped at the corner, and then a bike knocked me down, and then I got up, and oh, there was that interesting person there that I wanted to meet last week, and so on and so forth. So you can remember these things in sequence. Normally, episodic memory is in the context of me. If you played first-person shooter games or things like that, you remember it from your point of view. So they're normally autobiographical. Episodic memory is not limited to human beings. Animals are demonstrated to have them as well. For humans, times, places, associated emotions, who you were with, a lot of things that you can explicitly state in a narrative. That's what episodic memory can be described as. What you wouldn't remember is how many times you were at a place, what were the car plate numbers. Imagine you were walking down the street. I just pulled it off the web from somewhere, but it's intended to be a crowded street that you can't remember too much about. And you're down this street. What can you remember? Could you remember landmarks? Could you remember that particular telephone pole that you maybe locked your bike on? Could you remember what you ate? You ate your favorite food. You met someone interesting. You can remember people. What would you not remember? Do you remember the exact date? This was a year ago. Do you remember what date you were on at that place? Maybe not. Do you remember the names of all the shops in sequence that you walk down that street? Probably not. So episodic memory and sort of the other types of memory that you coach yourself to remember are sort of, they work differently. And what does this have to do with mobile phones? Well, this is what happens to my mobile phone when I go over the weekend and come back and turn my phone on. You know, I've got 157 new messages and so on and so forth. Now, the problem is if I click on any one of those buttons, it's going to open up that many messages. I'm going to have to scroll through it. I'm going to have to read through every single message. The cognitive load is higher. You have to basically, in many cases, read and respond. So, for example, in the real world, if you're walking down a street, you could probably remember things while you were driving. Try doing that when you're reading the contents of your mobile phone. So it's cognitively more expensive, right? You probably don't want to do that. I'm not giving you that advice. Please don't do that. So this is to say that the mobile phone, the modern mobile phone, if you want to use it in social ways, is very interruptive. You get these WhatsApp group messages at 1 a.m., wakes you out of your sleep. It's really interruptive. And in many cases, people don't use the notifications anymore. They just like put it on quiet or just swipe it out and then go and check back later. And that's okay, except what if you had a critical message in there, right? So if you had a message that your mum sent you asking for the number of somebody quite urgently at 1 in the morning, maybe that's really important. Maybe you should have read that notification, right? So how, this is a problem, right? And I mean, look at this. This is human-sent messages, and now look at this. Pizza offers, PNR numbers on the IRCTC train. I mean, how many of us have been on the train and the conductor comes up and asks for your number, and you're like, sorry, sir, 1 minute, let me check. It's really hard. You have the interface is pretty broken, unless you use something like Ixigo and so on and so forth, but we'll come on to that in a minute. So, we're all programmers. I'm hoping that we write JavaScript. And hopefully we have a problem-solving mindset. We want to, crack some interesting problems. The problem here is that we want to use the same machine. When I was in college, a machine of this power would be very expensive and probably fill quite a big room. You want to apply this machine to go through your data and organize it for you in interesting ways without losing access to critical information, without losing that emergency call from your mum, right? So that is the problem that we were trying to look at. It really irked us, and maybe we had a lot of time on our hands, but we were trying to solve this problem, and we came up with Decant. Now, in the Western world, if you say decant, normally people say wine. In India, normally people say coffee. It doesn't matter what your favorite drink is, but basically the idea is that you have a vessel full of stuff. Some of it you like, some of it you don't, and you want to carefully pour it out into another smaller vessel, and the smaller vessel will then hopefully have more useful information in it. This is what your PNR numbers would look like when your train conductor is coming to have a look at your tickets. Now, this is one way of doing it. And your pizza codes, what are the offers like? These are not sorted, by the way. This is very rough and ready proof of concept kind of stuff. But the idea, what we want to talk about is how do we organize this information in a way in which I have control over the data that comes into my phone, right? That's the problem that we're trying to solve here. So this is one way to look at it. Now, apart from the notification problem, you also have the problem of search. So I've got this information now, and I want to look up information that was in my phone that somebody sent me an interesting text message about an interesting thing 6 months ago. I want to look it up. Hang on a minute. That's going to be a lot of scrolling on your phone. So I want to look it up. And I don't even remember whether it was on WhatsApp or Telegram or SMS. I can't remember this stuff. How do I do this, right? So and the problem is compounded by the fact that these private applications do not talk to each other. The databases are not common, and they cannot be common. So this is problematic, both from a programming and from a usability point of view. Now, what we looked at SMS, because that's where we started, that's I don't use any social media except for Twitter now because I'm required to. But anyway, but SMS was a good starting point. And basically we said, how do we structure this thing? So if you want to have a look at the code, have a look there, and there's an easy way to do that later on. Now, what is a solution? Well, we thought, why not apply the most popular language out there? JavaScript runs on every damn computer today. It runs on your browser, it runs on your phone, it runs on your IoT, it runs on like everything, basically. And why not get people to write their filter applications, the applications where they want to look at this data? Why don't we use that language to do this, to solve this problem? And second, there are no rules. A bunch of engineers in whatever company that sells your mobile phone cannot dictate the rules on how you should use your own data. That data belongs to me. I would like to use, break the rules. There are no rules in this game. And where do you start? Well, the notification system is where you start, because every single application on your phone talks to the notification system. Good stuff. Right. Now, how do we break the problem of having different silos of application not talking to each other? Well, this is where the case of the current ecosystem comes into play. So Exigo, for example, is a really good application. You can look at your PNR numbers, and then you can get live information of trains running, and then you can put it together in its own interface. Now, what if the SMS format changed? What if you were looking at email? What if you were looking at human content? Right? So every single data source has its own unique format and its own unique statistical layout. This is where the plugin writer can decide, I'm going to own PNR numbers, I'm going to own email, I'm going to own pizza offers, and so on and so forth. So there's an ecosystem of application developers writing plugins, pretty much like you would for Mozilla, Firefox, where you'd have plugins do this stuff. Here's an example if you were keen on pizza. So you can have a better look at what's up today. Now, JavaScript. I am not a JavaScript programmer. The JavaScript programmer is right down there. But it's pretty self-evident. It's fairly simple. This is like version 0.0001 of the API. There's no API yet. But we're playing with this. A bunch of functions, very self-explanatory. Have a look at the code. This is an advanced stock, so there's no spoon feeding. But let's have a look at the application in action. So these are my default messages. No, I'm lying. It's not my phone. So what we're going to do is to start this is the developer interface for Decant. Obviously, it's not user-ready yet. No one's going to use this thing at this point. What we want to do is to generate SMSs so that basically you don't have to pay for every SMS that you have to test. That would be a very expensive testing platform. So you want to generate your own template tests, and that's what the screen essentially does. Hopefully at this point, would have generated a bunch of pizza spam emails. So there SMS. So there we go. There's a whole bunch of pizza spam SMSs in your inbox, right? Now, I do not want to look at this stuff. I want to look at it in a more interesting way. Now, notice that there's a bunch of plugins over there. We actually have written 3 simple ones to start with, and hopefully there'll be more coming along the way. What the information that we're looking for is from Domino's. So let's have a look at what Domino's, is looking like. Well, you've got the offer type and so on. There's a bunch of tags over there, and you've got the columns that list. This is horrible. I hope I'm not offending any UI designers sitting in here. But this is a start. This is how it starts. Large projects have started at very small, interesting places. But the cool thing is that you can play with this thing. All you need to do is have the application running, and then you can just write JavaScript code, bung it into a directory, and it's ready to roll. So that's essentially the run-through for Decant, right? Now let's get back to the episodic memory problem. Here I want to digress a little bit, and I think I ran a bit faster than I initially intended to. But really, what we're showing here is just the first step of a huge number of possibilities. Ideally, you want to see something, you want to be able to access information by describing it in very simple ways. Look at these keywords over here: shop, Commercial Street, cuddly toy. What if you wanted to find that shop on Commercial Street with the cuddly toy you noticed when you were snacking on your favorite snack and not trying to drop your armful of shopping? So you don't remember the date, there's a load of other things that you don't remember, but you want to do this. Well, everyone's now going to say word to vec, word to vec. Yeah, you can use NLP if you like. Great. The possibilities are endless. The point is, we want to start doing this in a way in which we as programmers have access and control to our information, and hopefully, this could develop into something more for the developers. So it's an ecosystem possibility. I've run this through people from around the world. I just returned from an overseas trip, and people are really excited to see this stuff. There is value in it, and there's potential in running this. Maybe not in this form, maybe not Decant, but the pattern is definitely valid. So if anyone of you around here wants to start a company, this is a great, it's something interesting to look at. I'm not running a company, by the way. What next? So we do not have a roadmap. This is a couple of guys sitting together and writing some code, right? Or at least one guy writing some code and the other guy basically telling him, well, I like that and not like this, right? You want to write your own plugins, maybe have more SMS applications that are able to be parsed. SMS is easy because the government mandates a certain format. So it essentially is a regex, regular expression that you can put onto that data and you can categorize it. Other unstructured information is a little harder to categorize. UI improvements, or rather a UI. We do not have a UI at this point, obviously, so something interesting can come out of that. We've looked at a couple of libraries. It all looks very promising. We definitely need a framework. So the current framework that we have is about 6 functions that the JavaScript code calls, and it basically needs a lot of iterative cycles, obviously. So this is what needs to happen, and obviously, that needs to happen. So if you've got your QR code enabled fancy phone, now's the time to take a picture. We're going to have a hackathon kind of thing after the event in the banquet hall. So if you're interested, come along. If you want to just keep an eye on what's going on, click on that issue and follow it. I'm hoping that people use GitHub. I'm a latecomer to this party, but it looks like it's interesting. So click on that, and you can follow what's going on. Thank you. I've got 4 minutes for questions, I think.
No questions. Okay.
How are you running the JavaScript on the Android device?
Right. So we run an open source application library called Rhino, which is developed by the Mozilla Foundation, I believe. And what it does is it translates on the fly JavaScript, and it's a Java application, so it runs on Android. So yeah, works easily. Now, bear in mind that this application only is for Android at this point, but there's nothing stopping it running on any other mobile phone like the iPhone or Microsoft phone or whatever it is. We just need the equivalent of a Rhino for that on that platform, and it'll work.
Any other questions?
Yep.
And I'm just curious that after a time it is being developed like fully, won't this be having all the notifications clubbed, and again the same problem goes into cycle?
So this is why it's important that it's open source, because people can pick and choose. Well, it's a bit like the Play Store, if you like. It's a terrible analogy, but where there'll be loads of plugins, and you can choose what you like. This particular demo that I showed you does not have the filtering for the notifications, because it's a little risky to do that on a real application at this point, until we figure out how users are interested in the prioritization of notifications. And so, you don't want somebody complaining that they, missed something important because of the notification filter. But certainly, if you have control over the plugins, and they're all open source, I don't see any reason why they shouldn't be open source, but the framework itself is open, and people can choose, so it's basically a free market of stuff out there. And what I'm envisioning is something similar to the Arch user repository. I don't know if you've used it, if you're a Linux user, where people just basically bring in all sorts of things, and it's rated by user feedback, and then the best ones with the best ratings basically are the most popular and used the most. So that's where I'm coming from. Yeah. Okay, I hope that answers your question.
Yeah.
I think there was a question somewhere around here.
Hello. Hello.
Hello.
How different is the idea from the slice and dice in data analytics, drilling down of information?
Data analytics. Do you mean sort of
like have a lot of data and just filter it down and drill it down? Means how is this Decant very different from that aspect?
Decant does not do that for you. Decant provides you with a central framework where different plugin developers can talk to each other. So if you write a plugin interface that does that, great, it'll work for your data. But until somebody actually writes that plugin, it's not going to happen. So does that answer your question, more or less? Yeah.
Thanks for the session. And one question, what about, suppose, for an end user, how he is going to configure? He need to be a developer or have a basic understanding of JavaScript. So how about coming up with a marketplace for Decant, where the developer can push their plugins and the end users can consume it?
This is definitely a possibility. Come to the hackathon and we can chat about it.
Okay.
So all these are possibilities. I mean, at this point, we've basically just thrown out what we have. You could probably have a marketplace. You could start your own plugin-based company. I don't know. The possibilities are endless. What I know is that this level of integration is not available on this user interface. I haven't seen it anywhere, and most people that I've spoken to have told me that they haven't seen anything like it. So, normally I would ask for funding and then try and get some money and go away, hide away somewhere and try and make some money. But I'm throwing it out there because that's what Elon Musk does, and I'm a big fan of Elon Musk. So, hey, Hi, I think I'm out of time, I think.
Okay, awesome. So before everyone heads out for the tea break, I just want to announce the list of Flash Talk speakers. If you're here, please just raise your hand in acknowledgement. Tushar Mathur, Sunil Pai, Sauvik Basu, Roshan Hadal, I want to say. Okay. Sneh Ganju, Akhil Agarwal, Supreet Pal Singh, Sridhar, Ankit Maini, Prashant Sannan, Nemo, thanks, and Vivek.
I don't want to move it. Oh, now it works. Okay, perfect.
Check. How is this? Can you hear me? Am I on the speakers, Karthik? No? Okay, so is this better? I think this is better, dude. Okay, how is this? Is this as bad as last time? It's the same? Okay, is this better? I think this is better. No, it's the same? Yeah. You minimize again, right?
Hi everyone, if you could please settle down, we'll start in a minute or two. Okay, welcome back everyone. Our next speaker flew in all the way from Mountain View to be with us. Please welcome Paul Backhaus from Google.
So yeah, I turned it all the way. Yes? Okay, perfect. Okay, so yes, I'm Paul, and I work in the DevRel team, web DevRel team at Google. But right now, my specific focus is on AMP. So I work with the AMP team on solving a lot of problems for the mobile web. Now today's talk, and I said I don't have an intro slide, would have been a good idea, is not just about AMP, but about AMP and PWA and how to combine those two and how to effectively work with those solutions. So first, why are we even building for? Well, a couple of things. It's cross-platform, it's composable, it's indexed, auto-versioned, easily deployed, secure, linkable, and really limitless, open for everyone to play. Some of the characteristics that really make the web what it is and why I like it so much, still to this day. And before we jump into specific problems and solutions, what is the ideal user journey that we think the web should look like in 2016? So in this case, we have an example of a shop. And first thing is, you start with a search. Well, you find a search result. It's actually an AMP page. You click on a search result, immediately, in an instant, it loads that search result page. Now you explore the category, you pick your favorite, and then going forward, you see, well, okay, it's unfortunately out of stock. However, there's a button to get a notification when it's in stock again. So you get notified when it's in stock. So then the application asks you for your permission to send you a push notification. And then finally, you stay up to date. Now going forward, at some point, you go on a train, you lose the connection, but you continue exploring because, as it turns out, the app works completely offline, even though it's on the web. So even without exception, you get all the things you got before. Now, at some point afterwards, a couple days later maybe even, you get notified by the website, see, okay, my product is in stock again. You click on it, you can buy directly, you go to the cart, add it to the cart, you check out, and you pay directly with Android Pay or any other payment solution that you have on your phone. And also, you get signed in automatically because you signed in before. So there's no process of entering a password, doing anything. So yeah, after that, one tap to pay, and I realized that this might not be a reality today in India, but we're working on it. So there are some complications in India. And then finally, because you like the app so much and you want to consume it further, you want to browse further, you add it to your home screen. You can access it as much as you want to, like a native app, and then you re-engage whenever you want to. So that, to us, is really the ideal user journey. Now, how we implement that journey is a completely different story. So why isn't everyone building this for the web? What are the problems that are holding us up? Well, first, you got slow loading, non-responsive content, especially, and that's kind of the bane of my existence, is content shifting. I really hate that when you load an image, the image loads, and you jump around with a paragraph and you can't read anymore. And of course, what's the solution to this? Well, no megabyte-sized images, no render blocking ads, no 100K lines of JavaScript. And now you probably all, well, duh. I mean, I'm not dumb, right? I'm a developer and I know what to do. And I actually believe you. You probably know what to do. However, your manager doesn't care because your manager has a job to do and he is desperate because he wants to make more money because his site doesn't make enough money. So he's gonna force you to add that new beacon or new analytics library because it measures things differently than the other analytics library. And you need both on the site. It's super, super important for some reason. So you give in even though you know there's a better solution. And unfortunately, it wouldn't be all so bad if it wasn't the web. If you were in a native environment, right, in a restricted programming environment, you could probably force the beacons or the analytics scripts or something to restrain themselves and not cause any havoc on the site. But on the web, it's like giving your key to 100 different strangers. What could go wrong? So that's a really big problem. It turns out, and this is really, really new data that we published just a few days ago, the current situation is actually pretty bad. The current situation, and I think this is worldwide stats on what we've measured on DoubleClick, was that a mobile web page makes 214 different requests. The average load time is 19 seconds. 50% of that is ad-related, and 77% of mobile sites take longer than 10 seconds to load, which is really unfortunate. Now, on the other hand, you also got missing device capabilities. So and this is kind of obvious, for a long time you couldn't have payments on the web, which is why the ad model is so overused, and because there really wasn't, there never was a technology built into the web that could monetize differently. Like paywalls had to be built afterwards, and there's a lot of different versions of them. And actual monetization with credit cards or with banking was never part of the web in the first place. So that one is kind of an obvious one. We just need some more capabilities to create re-engagement, to do other things. So solution. Part one to the solution is AMP. At least we think it's a solution for the problem. Now, what does AMP do in a nutshell? It allows you to build really high performance web pages, and it gives you a rich catalog of web components, pre-built library components that you can embed into your site. And it's basically HTML. So it's not just a completely new standard. We didn't reinvent the wheel. We just added web components where they make sense. Now you would say probably, okay, why did we replace image with AMP image? Well, I'm going to go to the reason very soon. There's a very good reason, believe me. Now, the publishing flow for AMP pages usually goes, you create it in your CMS or you create it manually, You might or might not create two versions of the same page. One is your full version page, and the other version is the AMP HTML page. They're linked with the canonical tag. And then they get cached, because that's one of the biggest amazing features of AMP, is that it's a container format. So it allows the publisher, it allows the integrated platform that loads the page to say, okay, I can actually load this page standalone, and there's probably no dependencies that will mess it up. So a cache on top of it can cache the entire page and then deliver it much quicker to any support. For instance, in this case, Google or Twitter or Pinterest. And then finally it gets consumed. There's a strong ecosystem already. A lot of members are joining soon. Bing just joined. WordPress is supportive. Feedly now redirects traffic to AMP. Those are just one of the new ones. And the Google canvases that support AMP, because I work at Google, I know some of this better than the other ones. So first of all, you get, this is what we started with, the top stories carousel, where we integrate AMP, rich cards in search, news and weather app, and soon, and this is kind of important, blue links in search. So those are just the organic search results that you get in search. And if we find out that there's an AMP page equivalent of that page, or the page itself is AMP, we will open it in a viewer almost instantly because it's preloaded. So AMP pages are really just web pages. It's HTML plus CSS. There's no one-off JavaScript. Instead, custom elements and sandboxed AMP iframes that can contain everything. And then in addition to that, there's the AMP open source library, which I usually talk about, the JavaScript library. It's the same everywhere, of course. It's highly cacheable. There's just one version of it, so far at least. And it defines behaviors for custom elements, manages the rendering, manages the loading pipeline to optimize performance. I say, wait, okay, no JavaScript? We're JSFoo after all. That kind of makes me sad. So yes, we had to take some of the toys away in order to make pages really, really fast and get them into a controlled environment. So the three sources of speed in AMP is, one is the format, second one is caching, the third is pre-rendering. So in the format, sure, you have an average mobile site. We just looked at the numbers of what that means. Of course, you can hand-tune your site. And if you hand-tune your site and you're the only one deciding what comes to that site, you can do a very good job. In fact, you can do a better job than AMP, most likely. AMP obviously has a lot of the performance benefits embedded already, but it's a generic solution that, that can always be surpassed by doing something handcrafted. But the point here is that we can do this at scale. We can optimize a lot of pages at scale, even if developers don't really know all of those techniques. And so you get a single HTTP request to fetch the entire document, and then fonts, which is an exception. CSS is inline in AMP, and a maximum of 50 kilobytes that we enforce in the validation process. There's only GPU optimizable animations, minimal style recalculations because we control it everything. So AMP triggers only 2 style recalculations during a typical page load. And all scripts are asynchronous. So this is the main AMP library script. Instead of a synchronous load, you get an asynchronous load. And this is one of the most important things that most people don't know about or discount, is the static layout engine that we've built. So each element has a static proportion. So even before, here we go. Yes, so even before we know about what the assets actually are, even before we get the images and the videos and everything else, we don't have a situation where extended component downloads block page layout or assets block page layout. So in this case, just going back quickly, we can lay out the entire page without knowing any of the assets because the sizes are all constrained. So third-party JavaScript is only allowed in sandbox for iframes. So you can still use iframes to do whatever you want to, but they get deprioritized, so the content gets prioritized all the time. So how does the resource prioritization look like? Well, we optimize the resources in the viewport, and we can only do that because we can statically lay out the page as soon as we have the document, even without any assets. This is why the pre-rendering works so well, because we can pre-render the viewports and not just the whole pages. Now, second one is caching. And again, caching works because the AMP format is validated, and it's very clear that probably nothing bad will happen if you load an AMP page. Now, the AMP cache that we offer is built on Google infrastructure, so it uses all the edge servers that Google has. It's free, which is a nice benefit, and it's used by Google and a lot of other properties, but we are opening up the spec of how to build an AMP cache to other companies. So it's very possible that we'll see other companies do the same. And speed source number 3 is pre-rendering. So pre-rendering really can make loading instant. Again, we pre-render just above the fold, and that's why clicking on an AMP page feels so quick, because we preload not just the one page, we preload a couple of pages that we think you could click, because it's so cheap to preload them. So 3 sources of speed: format, caching, and pre-rendering. Now, we solved the first problem. We now don't have slow loading content anymore. It's very responsive, and the content doesn't shift anymore because of the static layout engine. But we haven't solved the device capabilities problem. And for the device capabilities problem, we go to part 2. And in this case, if you look at a native in comparison to web access, you have on one hand capability, and you have on the other hand reach. So the web is actually extremely good at reach, as you all know. Native is very good at capability, naturally, because they don't have to standardize anything. They can operate on a much faster scale and are much closer to the actual hardware. However, what we wanted to achieve when we started building progressive web apps, or created the term progressive web apps, is sort of a hybrid that gets us from the reach to extended capabilities as well. So how do we get there? Well, first, reliability, super important. Sites need to be reliable at all times. Push notifications, home screen access, and very new, simple sign-in and one-tap checkouts. So offline, right? No one likes that one. So bad offline dinosaurs. When you're on your user's home screen, there's really no excuse to show that dinosaur. So you really should always be available. What we do for that is service worker. So service worker is a sort of a proxy that is almost like a web server on the client, and that intercepts requests if you want it to, and can cache any kind of assets that you give it to. Much more flexible than app cache has ever been, and allows you to go completely offline and actually pre-cache stuff like an application shell. So not only does it offer you basic offline capability, but you can cache the shell of an application almost like all native apps do, and then the shell loads instantly on repeat visits. Dynamic content gets then pulled in to shell. Then we get push notifications. They are built on service workers, so you get a push subscription endpoint, and the service worker reacts on push and shows a notification. Here we go. And finally, you get a notification on the actual device. How does it work? You get set up and you check if the user is subscribed. You wait until a good time. You ask the user to subscribe. You send the subscription. You save the subscription. And then if you want to send a message, you generate the message, send to endpoint, send to browser, and then the browser receives it. If you receive messages, a push arrives from somewhere in the service worker. The service worker boots up if it's not running anymore on the device. And then messages are handled and the notification is shown. So the key here, going one back, the key here is that notification is going to happen even without the browser window open, like with any other native app, because the service worker can keep running in the background. Now, home screen access. This, again, is super important if you want to engage with your users. So home screen access you can do by using a web manifest. I'm going to show you a quick example of how that looks like later. But basically, you get a prompt. You can add it to home screen. And that's much easier than before, where you had to go into the Chrome settings or other browser settings and find the menu entry first to add it to the home screen. So what are the latest problems we're solving? Well, first, signing in is a huge pain point for users. 54% of users will quit before doing yet another sign up, and 92% of users will give up if they don't remember a username or password. So that's why we built the Credential Manager API, and that one allows you to save the info for easy access later. And first-time users get prompt to save that into SmartLog. And then returning users can actually be signed in automatically without having to ever type a password or even see the login form in the best case. And then the next problem is a checkout problem. If you have too many steps on mobile, fill out forms to enter credit card details, etc., it's really bad conversion. So how do we fix this problem? Payment Request API. I already talked about it briefly, but essentially you get in the best case, a one-click scenario of enabling payments on phones and on the web, hopefully as well. So which to choose? You want to do AMP? You want to go really fast? Well, that works for many companies like the Washington Post. They get a better user experience with AMP. The load times increased dramatically, over 88% improvement. And the reader loyalty and retention improved as well, which is really interesting. So AMP works really well for the Washington Post. On the other hand, housing.com, where we have 2 talks tomorrow, which I'm going to check out and I'm really looking forward to, reported that with the PWA, they got a 38% increase in conversions and 30% increase in page load performance. So yeah, on the one hand, you get instant delivery, optimized discovery, and unfortunately no user scripts, and almost only static content. It's really optimized for static content. But then on the other hand, you got progressive web apps, and they give you installability, app-like features. However, they're slower to deliver, especially on the first load, and they're not easily embedded, so you can't build a viewing experience in the platform as easily. So instant first load or native-like app? Well, I say both. Why not both? So how do we go from AMP to progressive web app? Well, level 1 is to start with an AMP experience, because you really want to get content to users instantly, and that's ideally the most important thing for you, because if that's not happening, well, you can give up immediately. So you want to get an instant first impression to the user. Well, you have a lot of tags to try out. To do that, now, first of all, you need to determine if you want to do just one AMP page, or if you want to do a paired approach, where you have the full site or another site. You can then validate the page. If you inserted some components and not sure if you did it the right way, you validate that page. Now, the validation also is done by the AMP cache. So chances are, if your pages don't validate, they will never appear on any of the third-party platforms that support AMP. Now, this is a feature, not a bug. The feature here being that we can be reasonably sure that AMP pages are all conformant and fast and doesn't do anything bad. So you can do it right in Chrome DevTools if you want to. You can use the web interface on validator.ampproject.org, or you can even use a browser extension. And if you're hardcore enough, you can do it on the command line and optimize it for a lot of pages. So how about AMP for desktop? Well, I think we did kind of a mistake, to be honest, when we named AMP Accelerated Mobile Pages, because the mobile in it really doesn't mean anything. I mean, it means that you would probably get the best benefit on mobile because you have high latency situations, etc. But you can absolutely use it for desktop, and in my opinion, you should. There's no reason why not. You can build responsive design all the way. So in this case, you could, for instance, use a layout property in AMP and this works on any AMP component, to set the size to fixed responsive, fixed height or fill. And responsive is really nice because it has a fixed aspect ratio, but resizes to its parent with something that not trivial to do in CSS and requires some hacks. And then you can use sourceset in every browser, and even browsers that don't support them because we polyfill it. So you can do really nice art direction and use different images for different browsers and different environment. Finally, element media queries is another very interesting idea, where instead of doing a CSS style sheet media query to disable things, you can do it on a per component basis, on a per element basis. You can say, only show this element in a certain restricted environment, on a certain resolution. So you can easily switch on and off elements on the fly. So let's get working. So what we want, okay, first of all, this is the AMP homepage. And I have this sidebar here. And the sidebar has a language picker. So, and then if you click on those things, you get sort of an accordion effect. So this is what I want to build. AMP sidebar to the rescue. I found the component by searching through the docs. Sidebar does exactly that. It's a sidebar. The cool thing is that we have an event model that allows you, even without JavaScript, to say, if you click that button, open that sidebar. And so when you click on the hamburger, it opens the sidebar, and you put anything you want in that sidebar. Sidebar works on desktop, on mobile, and what about the dropdown? Well, there's no AMP dropdown. So what do we do? Well, there's AMP accordion, but I don't really want to build an accordion, do I? Well, if I look at AMP accordion on ampbyexample.com, which is a nice site that one of our team members built, you can see that, sure, you can make a style like an accordion, but in fact, you can be a little bit hacky and also style it differently and just have one entry, and basically, it kind of looks like a dropdown. And if I change the markup and actually give it a height, a fixed height, and no overflow, I can make it behave exactly like a dropdown, and that's what I did. So now you get the dropdown. And really, it's just an accordion. Sometimes you have to be creative to work around something. And of course, sometimes also makes sense to add a new component. If you discover something that really doesn't work, then we should add a new component. So this is great. But how about this menu? On my own website, which is completely AMP, I wanted a menu that looks completely different. So what I did here is I went a little bit crazy, and I created a label, which is the hamburger icon. And then I created an input with a type checkbox that is hidden and controlled by the label. So if I click the label, the checkbox toggles. And the element right next to it is the menu. So in CSS, I then have a JSON selector to toggle the menu based on the actual checkbox. And this works pretty nicely without doing any JavaScript. So you can toggle it by clicking. Optimizations, well, only include the AMP scripts needed for the page's tags if you can. Otherwise, you end up with a huge bunch of stuff. And only load the CSS you need for a given page. And again, if you can, I have to say I was lazy so far on the AMP page itself. I actually don't do this. And I use the same CSS over and over. This is not good practice. So make sure that you try that. Those are just a few examples of how to work with AMP, but more can be found on ampbyexample.com. Now level 2. Now we have a pretty decent AMP page probably. Level 2 is accelerate subsequent loads with Service Worker. And yes, you can use Service Worker on an AMP page. So the first way to do it is to use a library like SW Precache, which is the easiest way to do it without Service Worker experience. So SW Precache, you scan directories, cache all files you find, cache files within the URL pattern. This is to cache the actual AMP project library. And then you remove a directory string, and that basically is all you have to do to generate a working service worker that caches all of those resources and makes them available offline. Now on the AMP side of things, in general, you have to use JavaScript to install the service worker, but in AMP, we have a tag called AMP install service worker. And you can you can then load and actually fetch that service worker on the AMP page without using any user-authored JavaScript. Now, the cool thing about this, that this even works in a cache scenario. In the cache scenario, you're not on your own origin, and yet we will establish an iframe and fetch the service worker and initialize the service worker on your own origin, which means that if you click the second time to another page from that cached version of the page that you see on a property like Google, you already go to the service worker one. So the other thing is that in some cases we wait a while until we install the service worker. This is just a gotcha, because we don't want accidental service worker installs. Now, if we take a look at this, we can see, okay, service worker installed, and everything got cached. All right, and now we can go offline, and it will work. So click offline box, reload, and the page is there, except the YouTube video, of course, because that one we can't really cache offline. Everything else works. So that's just one solution without any action on our part, without any JavaScript. But we are JavaScript engineers, so let's get real. So if you want to do it without a library, you install the service worker in the service worker file. This is the install part. I like skip waiting because it says take over from the old service worker. Don't wait until the old service worker doesn't run anymore. I want to update immediately. And then I open my cache and cache a couple of resources that I need for sure. There's a couple, I would put more in there, of course. This is just an example. But you cache everything that you know you need in any given moment if you want to go offline. And then you activate the service worker. This again has a step that says, okay, even though I might be completely new and the page has already an older version of the service worker, claim all clients currently connected to the service worker immediately. And then number 3, intercept requests. So we do that by adding a fetch event. That says every time a resource is fetched, do something. Now in this case we say, okay, respond with something else than the actual normal browser fetch. So as soon as we call this line, you have to deliver something or nothing will appear. In this case, we open our cache. We see if there's a cached version of the page. So we match the request, then look at the response, and we will fetch the promise. We have a fetch promise in here that we'll use in just a bit. And down here, we return directly if we have a data in the cache, or we use the fetch promise. And the fetch promise fetches a new networked version of the same page in any case. So it does that anyway. And that means that we will serve the current version all the time and then get the next version in the background. And then on the subsequent load, get the updated version. So this is a very basic example how to do a offline strategy with service worker and cache pages. And of course, this doesn't only mean you need this for offline, but it also means that it will dramatically speed up every subsequent click. Now, level 3, and this whole example will become important in the next level. Level 3 is add a web manifest to trigger add to home screen banner. So we talked about web manifest before. Again, all you do is, again in the AMP page if you want to, add the manifest. The manifest has a couple of properties. The most important ones being display, which hides the browser bar, the browser URL bar, theme color, background color, and especially the icons are very, very important. Otherwise, if you don't have icons at a certain size, I think 144, then the add to home screen banner will never trigger. So you need that. And the cool thing is that you can inspect it in DevTools. So if you open DevTools and go to the application panel and click on manifest, you see what the browser thinks your manifest looks like, so you can inspect any errors on the fly. So add to home screen action, in this case with Flipkart. Again, how does it look like? You get the prompt, say add to home screen, it's added to your home screen, and if you launch it, you get a nice preloader and jump right in. So what's cool about this is that you just build a PWA. Even though you are still an AMP, and this was still an AMP page, you just build a complete PWA. without writing any JavaScript in the client. And I think that's pretty cool. So we have the first step solved. We have a very fast first experience, and we have an experience that's offline and can be installed to the browser. But now it gets interesting. Level 4 is enhancing your AMP with the service worker. So, and here, it's important to say that the cache that you can store stuff in isn't unlimited. So AMP forces inlining of CSS, as I just showed you. And a typical page header on ampproject.org is about 43 kilobytes, which is significant because if it's 100 docs, which is approximately the amount of pages that we currently have on the ampproject.org site, it's about 4.3 megabytes of additional clutter that I cache with every request I cache, with every document I cache. So this would be a very common issue. But what if we could only cache the body and merge with the head on request in the service worker? And we do right exactly that. So we create a new template called docs blank. This is just the head with the actual CSS in there. In the service worker, we write a function that is called getTemplate. It fetches the actual template from the cache. It gets the text response because we need it later on, and stores it in a variable if it's already done that once. Now in the fetch request that we saw earlier, we expanded a little. So in the fetch request, what you do now is I grayed out the lines that we already did before. What you do now is you clone a network response because then we can manipulate it further. If it's a document, we get the text from the network response, which is the body of the page. And then we match just the body, and you should never do this at home. Please don't use regex for this. It's bad. Ideally use HTML comment or something to do this. But we match the body. We then save the filter response, so the actual body portion of that page, in the cache instead. And by constructing a new response, putting it in the cache, else, if it's not a document, we put it in the cache directly. And finally, this is very similar to what we did before. If there's a response already, then we see if it's a document. We then create a complete response. Otherwise, deliver the already existing response if we don't have a cached one. And otherwise, go into the fetch promise. So how do we stitch it back together? In the create complete response function, we get the template, which is just the text, the part of the page that has all the CSS, and we get the body and stitch them back together and respond to the browser. And this is what happens. By having the exact same result for the client, we get a previous cache size and a new cache size that is much, much smaller than before, which is a nice optimization to do. So again, we did something on the AMP page without actually doing any user-authored JavaScript in the client that helps us dramatically. But now I want to go one step further. I feel kind of nostalgic. So I think one of the saddest parts of my page is that I can't use any of the 90s JavaScript that I love. So I went to this page called Rainbow Arc Scripts, and I found this amazing mouse cursor that I think would be very helpful for all of my AMP pages. And I just can't have it in AMP. And I don't know why. I mean, I should probably file a bug request. So what can we do? Well, I just showed you this, right? Where we stitch together a template and the other one. Well, no JavaScript. Okay, what do I do? Well, how about I get some random stuff in between those two files? Random stuff that AMP doesn't like. How about that? Well, let's do exactly that. What happens? Here we go. We get a funny animating background. We get our amazing clock, which is our mouse cursor. And we still have an AMP page. And it still uses the AMP library. So we now hijacked our own page and inserted JavaScript into it and done whatever we want to. And the crazy part about this is that usually you would think, well, the AMP cache will complain about it. And, well, no, my AMPs will not appear on Google. And yes, what have I done? That's really bad. However, the cool thing here is that the AMP cache doesn't know about your service worker. So the Google AMP cache will see the normal AMP page and will cache it just regularly and think it's valid. But then consumers will see the AMP page on first click and the extended AMP page on subsequent clicks. So you can easily amend your page with whatever you need, whatever you want on your page, and whatever you think is right for your users going forward after the first click. And now this is where level 5 becomes extremely important. And level 5 is kind of alpha. It's the boss level, I would say. And it's completely rerouting the AMP and the actual URL that the user went to an app-like experience, to a progressive web app. So how would this look like? In the case of Washington Post, for instance, they lead you to an AMP page, but then they use AMP install service worker, and then they reroute every subsequent click directly to a PWA that then loads that page you clicked on in a viewer. So they do that in a separate URL space. It's not exactly what I'm envisioning, but it's a very fair technique. There's a couple of techniques that work with that concept. But what I'm saying is, and this is kind of what we're thinking, is the service worker hijacks all navigation. The service worker then serves a PWA shell. The PWA shell initializes a shadow DOM-based AMP viewer, and the originally requested AMP document is fetched via XHR, and then subsequent navigation uses history push state and XHR to navigate within the AMP viewer only. So that still means you only have one URL space, and there's really much less complexity that you would have in a other scenario where you have to implement everything again, because you already have your AMP pages, right? You have all your leaf nodes, all your documents are already there, are already nicely styled. So instead of using JSON and then reconstructing everything complicatedly in the PWA, you can use that technique and embed it in the viewer and strip out the head automatically in the service worker. So I don't have a very fancy demo for you yet on the AMP viewer approach. We're still actively working on it, but there is a demo. And if you want to check it out, in the AMP project source code itself in AMP HTML, there's an example called PWA that does precisely this, that initializes an AMP viewer with Shadow DOM. One of the cool ideas that we had recently is, because we've got the question, what happens on platforms that don't support service worker yet? They will always get to see the AMP page in this scenario. Well, one of our ideas is to then have the AMP library detect that a client doesn't support service worker, and then rewrite all the URLs on the page dynamically to an URL space that you define as a fallback. So that's another solution to always get to the PWA in any case. So phew, that was a lot of stuff. 5 steps to get from AMP to PWA. If you want to learn more, and I hope you do, go to ampproject.org/docs, and you see my face again, and a lot of other good stuff. And then go to developers.google.com/web to learn about general web techniques and also what we do with progressive web apps. And this is a really, really cool course by my buddy Jake, who's also a part of my team. And he created this offline web applications course that helps you to really find out how Service Worker works in detail. I mean, I skimmed over it, but this is actually very helpful. And finally, YouTube, we do a lot of stuff there. There's a new series coming up soon about AMP. And we also have a Slack where you can always ask us questions, but of course you can ask me questions here. And finally, some Twitter accounts. And that's it. Thank you. Stay in touch. And I think we have about 4 minutes if anyone has questions.
So are you suggesting that the first point load performance can be moved from a server-side app to a AMP project-based implementation, and the rest is always PWA-based thing? So are you suggesting that instead of going for a server-ended approach, go for an AMP approach for the first load performance?
Yes. Yeah, that would be my recommendation. Because you will never get the same speed with a PWA. And the reason is not that the PWA theoretically cannot have the same techniques, right? I mean, it could also be as small and using the same characteristics. The reason is that it doesn't have the same static layouting system out of the box. So the platform that embeds AMP is not able to preload the first viewport.
And another thing is with server-ended approach, the limitation you told is that the server is only at one place, but with AMP you have a distributed network of cache.
Yes, that's
like
right.
a CDN.
Yes.
So is that the only advantage, or you have any more advantages than that?
I'm not sure I understand the question.
So if I go to a server-ended approach without using AMP, still my content is coming. The first load of a website content is coming from one server situated in one part of the world. But with AMP, I'm getting a distributed cache. It's like a CDN effect for my original web content.
Yes.
So this is one very big advantage that I get with AMP. So are there any more things that I get with AMP?
Mm-hmm. Yeah, I think so. I think that's a good advantage. I mean, if I understand your question correctly, the fact that you're going to the AMP cache on the first request gives you a lot less load balancing to do on your server. So it's a lot of traffic you save. And you can still use analytics to track those clicks if you want to.
Hi. So actually, here in the back.
Over there, yes.
Yeah. So initially you said that the pre-render is based on user behavior that you have earlier, right? Like whatever you pre-render is actually based on what the user actually clicks. You have some behavioral patterns for that, right? What amount of that page is actually pre-rendered? Like say if I have in the navigation, I have 10 different tabs which actually load 10 different pages altogether, like a e-commerce website. How much of it will I pre-render if I don't have the user behavioral pattern or something like that?
Oh, so the pre-rendering only refers to the current leaf page. So by pre-rendering, I mean that not many, so it's only the current page that gets pre-rendered. So what it means is if you, let's say you do a Google search for something like flower, and okay, that's not really a good news term, but I don't know, Obama, right? And then you get 10 different AMP pages as recommendations to click on. Then in most cases, it would be not really doable to pre-render and pre-cache all of those 10 pages that are coming from different origins. But because of AMP can cache just the first viewport, it does that. So it doesn't cache subsequent navigation, if that makes sense. It only caches the first navigation. Yeah.
Hey Paul, I'm here. Great talk back there. I have a few questions actually. Like you said, as far as I understand, like service worker caches the pages as and when we visit, right? Mm-hmm. So like if I'm about to create an application which has, things which are loading all the time, like automatic feeds or news sites or blog feed, for example. So how is PWA really useful in that situation? How is PWA useful in that situation? Because like caching will not help in that, right?
Well, I mean, sure. You mean if you have a very interactive page that requires a lot of interactive data? Is that the question?
Yes.
Well, you still have the service worker is still very effective if you use it the right way, because you can cache the entire app shell. So every UI element of the page you can cache. Of course, you can't cache the data,
correct.
But it's still, at least you can improve the perceived performance of the loading experience much, much better. Because on most native apps, right, you see some of them are actually even slower than web apps, but you see the actual layout of the user experience immediately, and then content dribbles in. This is not really improving the time it takes to get the data on screen, right? However, it will feel much faster.
Okay. And one more thing, like, is there any specific change that we have to do in the UI architecture for rendering this, or like normal, the way we do is fine?
Sorry, is there what's special?
For using this service workers or PWA, like, do we have to bring in any new architectural changes in our application, or?
No, I mean, the only requirement is HTTPS.
Okay.
So your page has to be in HTTPS.
Okay, and you said something about this smart locks, right? Like that saves the username and password of the user as in when he types in. So you understand what I'm saying?
So
smart lock,
yeah. Smart lock is a Google feature that is basically a password manager And it works in combination with the credential manager. So the credential manager can also work on its own. So in Mozilla, for instance, they would use a different password manager. But yeah, it's built on top of that.
So I wanted to ask that, all the websites from which people visit links, Google, Facebook, and Twitter are three of them. So Google has started with AMP, and then later on Twitter and Facebook has also added the instant article standard. So isn't this like breaking down the standards a lot of the web? Because if you want, like, you are a website like Washington Post, you want it to be instantly available on Facebook as well, on Google as well. That means you have to write a lot of custom tags, which are not like an HTML standard or anything.
Yeah, so a good question. I think I think we're running out of time, but I'm going to answer this quickly. I think the answer here is that on the publisher side, they're very similar. So different endpoints, right? So you usually, if you want to generate for all of those endpoints, you have a CMS that will export for multiple endpoints. However, the approaches are very different. One is living and hosted in a relatively closed ecosystem, and the other one is really just a JavaScript library and a validation system that is very open web friendly, in our opinion, and can be embedded anywhere on the web. It's really just web pages with a little bit special magic on top. So our hope is that AMP will just be used as a library going forward and hopefully work. So for instance, in my blog, right? My blog, there's no two versions of the page because I don't need any JavaScript on the page. It's a blog. So I just use AMP as a library and that's it. So it's all using AMP. With instant articles, I couldn't do that. So yeah, that's my take on it.
Hi. So I want to ask about the service worker notifications. So in service worker, we have been using service worker notification for almost 6-7 months now. There is this certain problem we have been facing and we couldn't find the solution. In service worker notification, there is a callback that you register on push, right? So in that callback, I get only subscription ID of the user, correct?
Mm-hmm.
And based on that, I make an API call to fetch the data from my server. Basic notification system, that's how it works, right? Now imagine my website hosts two kinds of products. Let's say we sell hotels and we sell flights.
Mm-hmm.
A person came to my website and registered a notification. And let's say he registered the notification from the flights product page.
Mm-hmm.
Now I want to, because I have his service subscription ID in my server, I would want to send a hotel based notification also. But I cannot context switch it because of I only have one parameter, that is subscription ID. So is there a workaround to it? Maybe I can register two service worker to my website at the same time, maybe.
So I don't know the specifics of the push notification side. However, the people are working on a way to add multiple service workers on the page. Yes. So this is coming. We'll be able to add multiple service workers to a page. One of the interesting techniques here is foreign fetch, which you can Google. It's called foreign fetch.
Oh, yes,
It allows you to have a service worker that controls other pages that are not his own. And there are also ways to install two service workers on the same page as I believe going forward. So I sadly don't have a perfect answer for you, as I don't know the specifics of push notifications. But yeah, I hope it works. All right. Well, thanks again. And come meet me afterwards.
Thank you, Paul. Our last speaker of the day is Ayan Ghatak from Fusion Charts. I just want to remind everybody that the 5-minute flash talks are after this talk.
Yeah, hello? Hello? Yeah. Hello?
Yeah, that's it's far. Yeah. Sorry, can I just pull it? Yeah, that's fine. Can you shake it?
Yeah, hello?
Yeah, okay. Timer 45 minutes, yeah? And we will only after 30 minutes.
Will we? Yeah, yeah, yeah.
So then there will be time for Q&A.
Yeah. Hello? So am I audible? Yeah, it's working. So hello, good morning everyone, good evening everyone. Okay, so I'm Ayan Ghatok and I'm working as a software engineer at Fusion Charts currently, alright. So at Fusion Charts we had been building charts, gauges and maps which we will be licensing, which we license to our 26,000 customers and around 700,000 developers worldwide. Many of you over here might know about Fusion Charts as a Flash-based charting company, right? But about 6 years ago, we have completely transitioned to JavaScript-based charting, and since then we have been making charts in JavaScript and HTML5 only. So last year, what happened? We got a customer requirement to deal with large amount of data. Now, dealing with large amount of data is a pretty general use case as of now, right? Because we all often have to deal with large amount of data at one point or the other. So the question is, can we visualize this amount of data on our browsers? Can we explore them? Or just can we make some sense out of this large amount of data on our browsers? So, well, yes, the answer is yes, but the options are pretty restricted. Why? Because the rendering capabilities of the browsers are quite limited when we are talking about in context of this large amount of data. So how to tackle these limitations? We can have two approaches. One, we can handle the data. Second, we can handle the browsers. So first, I will be speaking on how can you handle the data. So this is a perspective one we will be speaking. So as we know, browsers are not quite comfortable to handle a large volume of data. Is it fine? Okay, sorry for the interruption. So browsers are not quite comfortable to handle large amount of data. So can we just think about, like, can we scale down the entire data? So what happens if we can somehow scale down the entire large data? We will be reducing the number of elements, and specifically speaking, we will be reducing the number of visual elements if we try to plot them out. So if the requirement around the data permits us, then we can actually go for data crunching. So here we will be just giving a brief introduction of what are some of the common data crunching techniques. So I'll give just an overview of them, not discuss them right now in detail over here. So let's first go with data aggregation. All of us, many of us are aware of what is data aggregation, right? So in this data aggregation, we do not change we actually visualize or treat the entire data at a go. And the information is not changed. Only what is changed is the level of depth on which we are viewing the data. Say for example, we are trying to see daily sales of a e-commerce website. So instead of daily sales, we see the monthly sales, or we go on a step further. So in data aggregation, what we are changing the depth of the details for viewing it. So this is one of the way we can reduce the data. Second is like filtering. We apply different kinds of filters and conditions which will actually reduce the entire large data to smaller subsets. So this is one way we can reduce our data. Sampling is but picking up a small data set from a large population and getting it representative of the entire population. So this also helps, and you know, like the data analysts and the statisticians love this sampling part, and they had been using for long. So all these kinds of optimizations actually work if the requirement around your data, what's happening? If the requirement around the data permits us. What does happen when it actually doesn't permit? Let us analyze that part. So we had large data, right? If we are talking here about large data, we see a couple of patterns there. So what I'll just mention two of the patterns, which is the most common ones. This is working. Oh yeah. So these are the two common patterns, right, which we speak when we are speaking in the context of large data. We see lots of clusters. So if you actually plot or visualize large data, we see clusters, you see gapping, and there is also distributions, like some data will be tightly distributed, some there will be loosely distributed. We see a lot of patterns. When the patterns gets repeated, we see trends, and there is also an exceptions part, which either there is an exception in the patterns, or there is an exception which we call as the outliers in the data. So this was about the importance of large data. But what we are missing is some of the meanings. Even if you are speaking about large data, we also miss some of the meanings if you actually crunch the data. Let us say if you have a, what benefit if we give if you are treating the high volume. Data is actually large, the chances are pretty high that you are answering much more specific questions. You can ask your data a lot of questions, and you get there's a high probability that you get a lot specific answers, and you have the freedom to go atomic. So from any level you can drill down to any minute details. So that's how we can go atomic to any level if we actually have the entire large data, and that is the thing. So here we will be revisiting all of this in the live visualizations, which will be coming later. But let us speak about the other side of the coin. Let us speak of the other perspective, that is, this was the how we handle the data. Let us see how can we handle the browsers, okay? Or what if the browsers can render all of the data, high volume of data, right? So not only that, even if it can handle, at what extent it can actually handle that. So we will be seeing a live demo for this. So here we have data of the weights and the prices of a large set of diamonds, and we want to see how the price of the diamonds is actually varying with its weight. So let's check out this live version. All right. So is it visible? Okay. So you see this is quite faded, right? All right. So we see visibly we see this is how about approximately there's a million data point over here. It's down with opacity, so we can't actually judge much. But see, there's some amounts of plot over there. All right. So this is how a million data, if we actually render on the browsers, looks like, right? So before I dive into the technical details, like how we can actually render this kind of data, high volume data on our browsers, let us see if the problems, whatever we were speaking previously, is actually getting solved. All right. So we will be exploring this entire visualization, previously demonstrated visualization, using one of the common data exploration mantra, that is Snyder's man mantra. So what he says is, like, first you give an overview of the entire visualization, allow the user to zoom and filter, and then you ask the details on demand. So let's see how this visualization helps, how it helps us, right? So first you see there is a lot of patterns over here. So you see there is some spikes, and this is the overall pattern. So if you actually see there's a lot of clustering in comparison to this part of the screen. It's so much clustered and clustered over here. So all we need to do is just, you know, zoom a portion of it, and you will get a visual that this is the clustered visual what was coming before. On a detailed look, you see there is a white distinct line over there, or a portion of there. This has got a special kind of meaning. This is a gap pattern which we are speaking about. So there's a discrete gap inside the visualization. It can have some different interpretations, but this is how it helped us in analyzing the clusters and gaps which we are referring. What about the distributions? See, some parts are very tightly distributed, and if you go over there, there are some very loose distributions, right? So we also have distributions. We can see different types of distributions over here. We get a lot of trends. So see, this is one of the trends, and at some part of the trends actually broke. The width of this is actually smaller than that. So often we also there is some exceptions on the patterns. Right. Apart from that, we also have some outliers which is so much far, and only you can realize these outliers only when you zoom the stuff. So when you see an outlier, the natural inclination is, what is that point? Why has it been plotted so far? What is so spatial meaning about it? And this kind of details on demand, attaching a tooltip or any such activities help us. Let us see how filtering, the Snyder's-Man mantra we had been referring about filtering. So how does actually filtering helps us? Okay, I can actually, sorry. So if you see that gap what we were speaking, so this is a discrete kind of gap. Now, this is not a quite uniform behavior. If you actually filtered the different data sets, so these are actually different data sets, you see for some data sets, this is not discretized. So filtering also gives us some inference, some hint which were not very obvious in the initial phase. So to summarize this Snyder's-Man mantra is that what we got is like we got a glimpse how actually visualizing the entire large data is actually giving some more insights, more inference out of it. So do you think like this all rendering in even as large as 1 million data point was a straightforward rendering, right? Definitely not. And if you're an SVG is never an option for this, because like for every plot, every circles, if you are thinking that we will be having a DOM element, now that's not an easy option, and that won't happen because it will be too much hazardous for the browsers. And we switched to canvas rendering. So we thought about, okay, let's try with canvas and try to render the as large data as 1 million data point. So what was our experience about when we tried with canvas? Right. So canvas was pretty fast when we tried rendering around 1,000, 2,000, 5,000, 10,000, even 30, 40,000. Something really peculiar happened when we tried rendering around 50,000 data. And what happened is we didn't get any script error, we didn't get any kind of error. What we got is like a blank visual. So it was pretty strange for me, like what's happening. So if you have to understand that, then it's just a simple, like we all had been working with canvas. So how does canvas works? We need to understand that. So we give set of instructions to canvas, say move to this point, draw a circle, move to that point, draw a circle. Like this set of instructions we give on keep on giving the canvas, and at the end, all while this process, the canvas starts remembering or memorizing it, saving in technical terms like saving it in its context. All right. So what happens when we actually give this sequential informations for around 50,000 data, the canvas loses its context and it fails to render or visualize anything. So we actually land up getting a blank screen. So that's how overtasking of canvas led us to the context. So we already saw that we could have rendered more than 50,000 data, but then how did we stretch the limit? So this is how we actually thought about, like, let's do it like this. It's nothing but a batch processing. So you have an entire data, you divide the entire data into smaller number of chunks, and then you visualize it. Say I have to render around, say, 10 circles. So instead of giving all the 10 commands, I give it in a set of 2, and every time I give the command, I ask the browser to render itself. Now this is so what happening is like there is a progressive rendering occurring over here. So you see this actually progressive rendering gives us 2 advantages, right? The browser didn't have a blank visual as we were talking previously, and second time the first visual was coming in the least possible time. Now that was pretty important, because when you have a large data, you take some time, no matter what, you take some time to render. So you cannot keep your end user to wait until the entire rendering is actually complete. So what do? You give him something to see, and when he is seeing that, on the next couple of iterations, we render the entire part of it, right? So having said that, like, this might be entirely not scientific to represent a smaller chunk of data instead of the larger one, but as it's a large data, even that smaller chunk has some patterns or some properties resembling that of the original one or the large data one. So was this all about rendering? So this was the only optimization that was required for rendering part. So was it all about rendering? I guess not. We had been speaking about clusters. When I tried to just render it, it was giving us so much faded view, I can't even see anything. So we needed something which will help us to analyze it better. What was it like? We needed the feature of zooming, right? So how can we actually technically have this zooming feature inscribed, right? So how can we have it? See, like this was the this was the clusters we were speaking, and we were not getting enough details out of it. So what we did is we zoomed in this part, and we get something very interesting out of this clusters and gaps out of it. So technically speaking, this was pretty easy, right? Because zooming means only you have to do is to multiply every coordinates of your plots with some scale factors so that it grows big. So if you say if you have a say 100 into 100 pixel area, so when you zoomed 10 pixel into 10 pixel window out of it, all you need to do is to multiply the entire coordinates with 10 times. So actually it grows 10 times bigger. So that's all about zooming. It was pretty easy. What about panning, and why do we need to pan actually? So when you say you actually zoomed in a small region and you find something interesting out of this, now we look whether this kind of pattern, whether this kind of gaps or anything like that occurred in some adjacent place. So our natural inclination is, after zooming, we seek for panning across. So how can we actually pan the data or scroll the data? All right. So this it represents the currently visible window, and after zooming, this is the effective canvas area, the zoomed canvas area, whatever speaking. So there was kind of two approaches for panning. One, we could translate the pre-rendered canvas. What was the previous one we were speaking? So you zoom 10 times, I redraw the entire canvas in a 10 times scaled version, and all I need to do with every mouse move on panning to translate the entire canvas. That is the most smoothest operation we can have while this panning interaction. But this has got a severe drawback. What is that? Say you have a large data and you want to drill down to a specific plot. So it's like zooming 100 and 1000 times, something like this. So if we actually try to make our effective canvas area 1000 times the size of our device screen height or width, that was a pretty impossible thing, and the browser failed to do so. So this approach of increasing the total effective area was not going to work if we actually plan to if we actually plan to pan in this manner. So what was the next option? Can we render the entire plot on demand? So say if you so you zoomed only a portion, and that part of the portion of the canvas gets rendered. So that was pretty good for zooming, but when we actually tried this for panning, what happened? For every mouse move, the coordinates gets replaced, and for every mouse move, we have to actually re-render the plots. Now that was really expensive, and it was a pretty bad UI, so because that was not happening. So what we thought is, let's move to the solution. Like we can apply this 9-grid algorithm over here. So what is this 9-grid algorithm is pretty interesting. So we never draw the full canvas. What we do, this is a visible area. We first draw this grid, and next what we do, we draw the 8 adjacent grids next to it, each one in the background. So the user never sees these 9 grids at a time. User concentrates only at the center grid, and while he is busy in seeing this center grid, the rest 8 adjacent grids actually is already been rendered or pre-rendered. So when the user actually starts panning, say to the right side, what happens is this center of the visible grid changes to this, and only this only these 3 incremental grids needs to be rendered. So this was actually working pretty fine. So if I have to explain this over here, so what happens is, like if you have to, so when I'm at maximum, user can start from this leftmost point and scroll up to the rightmost point, right? So at maximum, you have to render at least one grid out over here, right? So if we do that, then only it solves the purpose. So that's why we chose for this 9 grid, and we don't need more than 9, because at maximum user cannot shift more than one grid at a time. So this was the incremental rendering that actually helps us the problem of mouse lag, of zooming even in the nth level. So that's pretty cool, right? Now, so let's recollect the Snyder's mantra once again. What we had previously was like we first gave you the overview of the plot, overview of the visualizations. Then we actually zoomed and filtered and showed that there is some interesting patterns out here. And now the next thing, once we actually zoom and filter, things becomes interesting for us, because these plots were so small in the initial view, we didn't even think of having any details out of it. When we actually zoomed and panned it, we found that this is an outlier. What is there? So we get interested out of it. We try to fetch some details out of it. So how can we do that, right? So because displaying a tooltip is not a big deal, but how can we do that in Canvas? Because as I already said, we had been using Canvas. So how can I actually have a tooltip over Canvas, or how can you have interactions over a Canvas? So because in Canvas we actually doesn't keep track of the points what we draw. Like in SVG, what happened? We had a specific we know where the plots are drawn, and we can attach the browser events to that and display the tooltip. So we will be using a cool approach over here. So this is how simulating browser events algorithmically. This will help you to add interactions even on a Canvas element. So what you do is like you render a transparent circle over here, transparent SVG circle over here, and on every mouse move we track algorithmically that whether there is any point underlying that hovered point. So if we can track at every mouse move accurate enough and fast enough, what happens on tracking, this transparent circle which was drawn in the left corner of the screen immediately transforms back to that point. And now when it actually comes under your cursor, now as this is transparent, the user do not get aware of this. And now you can actually attach any click event, any mouse over event, any kinds of interactions right on this. So it's like hacking the interactions events on a flat Canvas element. So this was a cool approach. This was fine, but how to track so fast, so accurate? How can we actually track our mouse? With every mouse move, we need to search from a million data point that whether there is a point underlying that point being hovered. So for that approach, we chose to implement this KD tree implementation. So this is the nearest implementation for algorithm for finding the nearest neighborhood. So what is KD tree? It's like a space partitioning data structure where we actually divide the entire portion into k-dimensional space. Here we will be speaking only about the 2-dimension, because that's the point of interest over here. We are interested about x and y. This would be our dimensions. So primarily we will be showing that how to build a KD tree and how can you search effectively using a KD tree, right? So these are the sample points which will be I'll be using to illustrate how to build a KD tree and also how to search KD tree in a pretty fast manner. So the algorithm steps for the algorithm is pick a random dimension, that can be x, that can be y, pick any dimension, find the median point along that, all right? Find the median point, split or partition the data into 2 halves, and then keep on recursively doing that with the alternate dimension. Let's see what we are speaking. So first we are taking the dimension y. Okay, this is the y direction. It keeps growing, increasing in the upward direction, and x increases in this direction. It's a normal coordinate axis convention. So what happens when we find the median across the with the y coordinates for this set of points? One seems to be the median most point, and one comes in the center of the tree, and the entire space gets divided into two partitions. On the next step, for the next set of tree, the logic or the convention is whichever coordinate is less goes on the left leg, and the, whichever is on the greater goes on the right leg. So this part of the this part of the tree goes on the right, and this downward part goes on the left. So similarly, but this time we had to find the median across the x direction, because previously we had we had find the median across the y direction. So similarly, if we recursively iterate the process, we are nothing but partitioning the entire data into alternate grids, right? Each time we are choosing the alternate dimension and finding the median point, dividing into 2 partitions. So this is the corresponding tree, So this is the corresponding KD tree that we've actually formed with this sample number of data. So how can we, so KD tree is already built, right? So how can you actually find what is my nearest neighbor point, right? Say this is the query point, right, in the green over here. So I actually have to find which is the nearest point, right? So what I did is, in first comparison, I compare whether the y coordinate for this query point lies to the is a y coordinate for this query point is less than that of 1 or greater than 1 or that of 1. If, as we see, the y coordinate for this is less than, so if we actually, for just one comparison, we actually discard this entire part of the tree. Similarly, on the next iterations, we find, alright, so we need to find whether the x coordinate for this query point is less than that of the 2 or or greater than that of the 2. So in this way, we find that it is greater than, so we discard the left part of the tree. And on the next, we find that, okay, this is close to 9 in comparison to, what is that, 0.3, I guess. So a 5, yeah, so it's closer to 9. So just you see, if you, sorry, so if you actually see that by making just 4 comparisons, you can we can actually find which is the nearest point we were speaking. So that's the beauty of KD tree. Now this 4 has some special meaning. This tree we had been showing with 10 elements, but this tree has 4 depths which can accommodate around 16 elements. So even if we had a 16 number of elements, just by doing 4 comparisons, we can actually find which is the nearest point. So if you calculate for even 1,000,000 points, so even if we have 1,000,000 points, just by making 20 comparisons, right, then we can find the nearest neighborhood point. So this was working pretty fine, and it was making things pretty good. But what was happening is the building time for KD tree implementation was pretty high. Why? Because for every dimensions when we were showing how we will be building the tree, we were showing that we have to find the median. Now we used to find the median using the sorting. First we used to sort, and then we used to find the median point. Now every time for every depth formation, if we actually have to sort, now as sorting was the most heaviest operation over here, it was taking time. So we decided to do a little tweak to this KD tree, which we named internally as modified KD tree. So let us see how this helps us. Right, so this is nothing but so in this type of structure, what we previously, every point had 2 legs, right? Here we have actually 7 legs, right? So we have 4 tree structure. The smaller nodes represents trees, and these middle larger ones represents the pivot points. So every level has 7 elements, 4 trees, and 3 pivot points. Now how to divide them? Again, division remains the same. Find the instead of median, you sort the array, and then you find what are the 4 points which will actually divide the entire space into 4 partitions. See, so on the first level of building the tree, we divide the entire space into 4 partitions, and in the next level, similarly with alternate axis, we divide it into another 4 structures. But as we didn't have so many amount of elements over here, so you can see in the next level of tree, there is only 2 elements, but as I said, every node should have 7 elements. So I haven't actually drawn all the legs over here, because that would be so much clumsy. Now that was the building the tree part. So if we recollect what was the tree structure for this same elements previously for KD tree, how is it actually different from this modified KD tree? The first observations will tell us that, you know, it has only 2 depths, whereas the previously KD tree had 4 depths. So here the depth of the tree has increased, and as I said, sorting was the main thing that was that was the main time consuming stuff. So as we have decreased the depth of the tree we had an advantage of this tree building time, right? So let's see how how we can search this. So that was the building part, and modified tree actually can build in a much faster way than that of KD tree. What about searching part? So same example, this is the query point, and I'm interested to find which is the nearest neighbor. So on the first comparison, I have to find that whether this point, so we take each pivot point and we find whether the coordinate is less than that of that pivot point or greater than. So if it is, so in this case, for even just by making one comparison that this point is actually less than that of the first pivot point, we actually discarded this entire tree. So just by making one comparisons, we discarded the entire 8 elements, and this is the remaining 2 elements, which on the next iterations we could have just got. So even by making just 2 comparisons, we can have a point that we the neighbor point that we were looking for, right? Okay, so this helps, right? But there is a catch. Previously in KD tree there was only 2 legs. Here luckily we had that by making one comparison this was falling in this tree, and we were not comparing any other trees. But if the point is lying on the rightmost tree, so if the point of our interest lies in this tree, so we needed to make 4 comparisons. Okay, now that's the heaviest thing. While searching KD tree, each level we had to search only once. Here we need to make 4 search in the worst case. So so in a nutshell, modified KD tree although helped us in building the tree in the minimum possible time, rather better than that of the KD tree, but modified KD tree takes a longer time to search, in the worst case scenario. So we had to take a trade-off. So it might be seeming that if we increase the breadth of the tree, if we keep on increasing the breadth of the tree, it will happen. But we needed to take a trade-off between building time and searching time. Okay, so these are some of the references I have been using in this presentation. You can learn about the visualization techniques in the Now You See It book written by JSFoo. The data which has been used is available over this link. We have provided a fiddle version of this of the prototype which we were explaining, and in my GitHub profile I have updated some of the minimum codes, the major roadblocks, whatever we were speaking, whatever the major challenges, how to replicate them. So all you need to do is go over there and just try it out. It doesn't have the exact finish of the Fusion charts zoom scattered chart, but it definitely will help you understand what are the major roadblocks and how we can optimize them. So that's it from me. I'll be looking for some feedbacks and question answers. Thank you.
Any questions?
Hi.
Hello. Yeah.
So whatever now the whole process of this rendering and then decision tree, or whatever that tree identification neighborhood you have done, can you tell what was the volume of data you tested and how much time it took to render or to do all this process and render in a browser?
Okay, so if you try for a million data points, it would have been taking around the first visual will come around 1.5 seconds almost. All right, and in the background it keeps on rendering the rest part of it. All right, so the user actually, we can engage the user with the first visual around 1 or 1.5 seconds.
Okay, now instead of SVG, that canvas concept will will be more performance, what you are telling, right? So when we go for the zooming, is that like the pixel when we zoom, the clarity will go, right, for compared to SVG concept and canvas. So how does that actually, when are you limiting the zooming as well, like he has to go to till that point, or how it is like?
I didn't get you. If you are zooming in?
So now when you use the canvas thing, when you apply zoom on that, as and when getting zoom, the clarity will go of that object. It's not that much clear when you use the SVG.
No. It's not pixelated view, right? It's not an image view. we are actually re-rendering the plot. So it's the same canvas element. On zooming it, so let me illustrate. So say you actually try to zoom this part. So what you're doing, so this is in the zoom mode. So when you are doing this, you are actually re-rendering the entire screen. It's not the pixelated ones, right? So it's down because of the opacity what you it might appear, but it's not the pixelation what we are doing. So that's not the thing. We are again re-rendering, which will keep the image intact.
So at that point only you are applying the tooltips.
Which points?
See, now when the page loads in the starting, so there are a lot of million of data points, right? So that mouse over when you try at that point of time. So maybe because there are a lot of million points, it might not, I mean, we don't know which point we are doing.
Right.
So you are applying the logic, that algorithm what you explained in the...
It is from the first level only. There is
first
nothing
level
like, yeah, it is actually from the first level. So the flow is something like this. First we render the entire part of the data. Then in the background, when the user is actually seeing the entire data, the overview, the first part, the overview of the data, the user is seeing the data. That time in the background we develop the tree. So for that few milliseconds time when we were actually building the tree, that time if the user actually interacts, he might not get the tooltip, because that time we are building the tree. But within next few milliseconds, once the tree building is complete, from that point of time throughout, no matter how much he interacts, the tooltip algorithm just works. All right? Okay. Yeah.
Hello.
It can be anything. All right, so using the standard fusion charts model, I have tested around, it worked pretty good for 3 million data points, but there are some other optimizations which we have to, there are some other features which we have to ship across the product. So we cannot optimize the entire part of it in fusion charts model, but if you sacrifice some of these features, then this entire logic is capable to render around, I have tested it for 8 million data. Okay, so 8 million data, I couldn't create more than 9 million dynamically. So it's pretty good to even render around 8 million data. And you can actually drill down to a single data from this 8 million, have a tooltip. That's the beauty of this entire part, you know. And it's so good to actually visualize the large data. That's it.
Hello. Hello. Yeah, my question was about whether all the charts are drawn in here.
Yeah.
Yeah. Whether all the charts are drawn in canvas or only few charts are drawn in canvas, where this kind of performance issues are there.
All right. So there's something interesting things happening. See, with every legend click, I'm just toggling the visibility, right? So here we have thought about having each canvas for each data set, so that this becomes easy. So on every data click, you just toggle the visibility of that canvas. Apart from that, like this grid, whatever you are saying, you can have 9 grids, 9 canvas for that 9 grids. That's pretty fine. Or you can all do in a single move also. Okay.
Yeah, my question is about let's say if there is a pie chart, right? So
if there is a
pie chart, there is a pie chart, there is a bar chart, there is a line chart.
Okay.
So does the same rule of using canvas for those charts apply, or is it based on the data points you choose SVG?
No, it's nothing to do with specific charts. You can apply, this is a generic logic. You can apply this in any types of chart or any types of rendering. So even if
okay, so the benchmark, as you said, 40,000 data points is for all types of charts, right?
Yeah, it is actually, see, canvas is like more of like painting an image. So the more you paint in a canvas, the greater time it takes.
Okay.
Right. So it's something like this. It's nothing to do with a specific chart type or specific type of visualization.
Yeah.
Yeah, hi.
So for these visualization, do you use D3 or any of the?
No, this is we had been using this with fusion charts zoom scatter model. All right, so zoom scatter, we have built this chart, the scattered chart. It's nothing but a XY chart capable of handling even 1 million data points. So that's it. All right, so D3 is a open source library. It's a great library actually. So we can also do, you can also try out same things in D3. all right? But the problem is here in D3 it's more like a fundamental, all right? It's more like a drawing library. Here you get the backed up product directly. So as we have we are licensed product, we cannot actually disclose the entire source code, but using Fusion charts, like you get the beta product, so when you can concentrate on other things and you get easily done. But everything what I said is pretty generic, and it has nothing to do that you can't use it with this and that. You can definitely try out D3 for this, but again, if it will lack the final polish, and you have to do those things. So that's what we are doing on our part. All right.
Hello. Yeah, my question was about how do you test these charts? Because you guys here, I'm Pradeep.
Yeah, hi.
Yeah. So you guys actually sell these charts, right? So you have to make sure that when you do changes in the code also, the chart works perfectly. So do you do testing? I mean, the testing of the charts?
I can't follow. It's a licensed product.
Yeah. Say for example, you released next version of your product, where the charts are, some improvements are there. Okay. So how do you test these charts?
How do you test these charts?
Yeah, whether they're working fine.
We have our automation systems running. So what testing you're speaking about? The feature testings?
Yeah, all the features.
So we have automated testing that runs on our server. So every day, whatever code we commit and everything, that gets tested, and the next day the QA team gets a report that okay, fine, these features have been broken or this has been improved. And even for the memory part, like whether the time taken to render, because this is a highly performance intensive chart, we actually keep track of the things, that whether we have degraded on the performance or not, in order to give some extra features. So
any testing frameworks you use?
So it's like we have our internal testing framework. We use it for image comparison mainly. All right. So we compare that both images in the two releases, and that's how we.
Do you recommend any open source available?
Sorry.
Do you recommend any open source similar libraries available for testing?
You can try out anything like Karma, or you can try out like unit testing, any frameworks, right? Or even Mocha works good.
Okay, thank you. Please meet the speaker outside. We're really running out of time.
Just one question. Okay, thank you.
We're starting the flash talks now. So quick couple of rules. The talks each are of 5 minutes, and if you're setting up your slides and laptop, they count as a part of your talk. So the first person is Tushar Mathur. Okay. We'll set a timer for you at 5 minutes, and we'll ring the bell at 4.
Check. Thank you.
So, good evening. My name is Tushar. I want to talk about web components and more in line with reactive web components. So, just to give you a brief idea of what web components are, web components is a W3C compliant way of creating components. So you've heard of React components and Elm and Cycle and a lot of Angular, and they all help you make components. And with web components, you can actually, without using any external library, create components and start using it. So that way you get a feature of, just not using Angular, which is 566 KB or React, and then, but still get the best of those components. So the best part about web components is it's encapsulated at component level. What that means is if I want to make an optimization for a particular component, I can just go and do that. I don't need to re-architect my application. For instance, if I'm using React and if I have a performance issue, I'll have to actually re-architect the whole application, use a different version of, say, React, or maybe move to a different version of virtual DOM libraries. For instance, we have React, which is much faster and smaller, but I have to do it at application level. Here, with this approach, you can just do it at a component level, and you can just migrate component after component. So it helps refactoring. It's much easier, and plus they are RFC compliant, so you don't have these observables or signals to help to communicate between components. So, and they can do a lot more than just styles and layout. So for example, React components give you that functionality of writing routers, but what if you could create a component to make an HTTP request? So that's something we can do with web components very easily. So reactive web components is just a simple library which I created. It's not a framework. What it does is gives you a way to write it basically gives you a better way of writing web components. So it's reactive by nature. What that means is you create functions which are pure and they have no side effects. And by side effects, I mean you just give them data and they give you some other data, and they are referentially transparent. So if you give him x, and if it's a function which just does multiply it by 2, it will always do that. It will always give you that value. So you can just replace that function with a variable or a constant and just use that constant instead, moving on. So RWC is basically a way to write these components in a more functionally pure way. And so because the current API which W3C provides is very imperative in nature. And it's inspired by Elm and Cycle, very small footprint, 110 lines. And the concept is simple. You have actions, you have an update function, updates the state, and it re-renders. So what we are essentially doing is we are re-rendering Shadow DOM using Virtual DOM. So, and you can use any Virtual DOM implementation. You can use React, SnapDOM, and it just works. So if you want to tomorrow migrate a particular component which is slow because it's using React, you can just plug in SnapDOM, and just that component migrates to SnapDOM. And it's much faster, and you don't have to migrate the whole app, and it's pretty simple. So you can use JSX if you want, but it works otherwise also. So this is how a standard component looks. For example, if you want to make a component, you give an init function, give it a state, update function, like Redux, makes the changes, updates the state, and you re-render. So, and you can then register component, because which is pretty standard way of registering web components. So what are the advantages? First advantage is architecturally it's simpler, it's easier to understand, it's testable because all these functions are pure, they have no side effects. So for example, another advantage is performance. If you use React or a big library, the performance that you get isn't that great. For instance, this is a swipeable card example that is made by Google people. Very good. And if you see the profile here, it's almost flat, and this is actually throttled to 5x. And this is what is the equivalent in React. And if you see this, it's got all this yellow JavaScript running all the time. And if you use web components, what you can do is you can optimize this, and you can find a middle path somewhere here. So this application uses web components and is built using SnapDOM. And if you see what it does is it actually is the application itself is a web component. So you have a app, FG app, which is just the prefix, and the app itself is a web component, and you can have a lot of things inside it. For instance, you have this HTTP component. It automatically makes HTTP requests. So I can show an example. For example, you are searching for a song, and you'll see as I type, it's making HTTP requests, and it's automatically canceling the previous requests. It also debounces. So you can do a lot more with web components and also write it in a good way using RWC. So yeah, that's it.
Thanks, Tushar. There are no questions after the flash talks. Please meet the speakers outside. Up next is Sunil Pai.
wait. Don't start that. Wait. Wait. You can start when that comes up. Okay? Can you guys hear me? This is the first time I'm doing this when I'm unemployed. So if you guys, I'm open to job offers, I guess. So what's happening? Why is this not? Oh, it'll come now. It should come. There. Yeah. Whoop. Yeah, you start. Okay. So anyone here build user interfaces? I guess pretty much everyone. Yeah. It looks something like this. This is Myntra. Spent a bunch of my life here. Maybe InstaMojo, if Akash is around. I spent half my life here now on my Twitter page. Yeah, and it's quite nice, right? And you guys use one of these frameworks, or one of your own, or homegrown. Even the guys who say that they don't use frameworks. Cool. And you guys make a little diagram of all the pieces of your framework, and I copied this from Google. This isn't the way I would build it, of course. And then you like compose them into components. This is how React would show it, right? And then like you'll use a little tool that lets you mess with the components. This is how you build user interfaces. Cool, awesome. So now what about the tools that you actually use? What do they look like? Do you have a terminal with 4 tabs open? One for your database, one for your app, like a Webpack thing running somewhere, a Node app in another one. Anytime you want to make a change, you have to make a change in your Webpack config or your Browserify config. You have to edit JSON, you have to Google what the API is. Maybe you run a bunch of tests and this is what your test config would look like. You have different configurations for production or whatnot. It's kind of shit, right? How do you hold these things together? Do you, every time you start up the app, do you have to run a few commands? Do some of you guys use Docker? That's kind of useful, I guess. You can start up some things in a VM. Stop tweeting at me, please. Okay. What about your build systems? Do you use NPM scripts? Something like grunt, gulp, brunch, some variant of it. You write a whole bunch more scripts and it's more code that the next person who comes in has to see. Maybe we should think differently. We are, of course, UI developers. We spend hours and weeks and months and years building pixel-perfect interfaces for our users to use, whereas the interfaces we look are kind of crappy. What if I could do this with my workspace? Like, I really want, I mean, I have a composition structure with React or web components or whatever. What if I could mount all my stuff like this? People use NodeMon to like restart on every file change, no? But React gives me like hot loading, so I should be able to change the port there and just have the server change. Why can't I make a menu with my scripts? I have to go and find out in my package.json what the scripts are available. Why can't I have a little page that says, that has 3 menu links that let me do this, or whatever you want, with little buttons to restart your server or whatever? What if I could use a router, one of 5,000 routers, or the very controversial React router launch, the new thing that just came out? Why can't I use that? Because that's a way to route my actions to different places, no? Why do I have to write gulp tasks for it? What if I could start up my app with a URL? Like fundamentally, I say different tasks in my thing point to different URLs, and I can pass query parameters. Why do I have to learn what command line flags you have decided for your thing? URLs are a pretty generic, well-known way of building stuff. Why can't I put a browser into this directly, or a terminal into my workspace? These are questions that I've been asking about my workspace while I've been building it. Any respectable mad scientist doesn't run around 5 different tables, right? You try to get everything together in one place for your tools. It doesn't have to be neat, but it just has to be something that you're comfortable with. This isn't a talk about React at all. It barely has to do with JavaScript, really. But it strikes me that we are in the job of building great interfaces between humans and computers. So this is a talk on human-computer interaction for our own jobs, or for your own projects or side projects. Stuff that I showed you isn't really new. We have the tools for it right now. You guys watched the Electron talk, I'm sure. Cool. You guys watched the Electron talk. These are things that are already possible. In fact, the code that I just showed you is working right here. See? I have a little shell thing that's spitting out what my list is. I have a little server running. This is just an Electron app with a React app running inside it. These are the things that we should be building now. This is what the road to Minority Report, where you're doing all those cool things, is incremental. We should start looking at the pieces that we have and be able to compose them in ways that we are already comfortable with. Use web components, use React, who cares? Just move away from a command line that was outdated about 50 years ago. A thought leader called it abstraction abuse, and he thought he was insulting me online. But I happen to think it's a great punk rock band name. So abstraction abuse for the win. Look at the tools that you're already using for other people and build your own tools with it. Thanks.
Next up, Savik Basu.
Hello. Audible? Is it audible there? Yeah. Okay. Let me know when it starts. Okay. Hello, everybody. My name is Savik Basu. I am a freelance full-stack JavaScript developer. Sorry, I don't have any slides with me. Like with my previous company, we used to have a card for all type of communication, and that's kind of stuck to me. So I think we'll do the same thing. And this is going to be more about a discussion with you rather than showing some syntax on slide. So what I'm going to talk about today is a component-based approach in AngularJS 1.x, 1.5 specifically. So what exactly are components? Nowadays we hear about components in all our frameworks and standards in JavaScript, right? Not just JavaScript, in fact in all the languages. We hear about web components, we hear about Angular 2, the components in Ember.js. So everybody is actually going towards a component-based approach. And so why exactly this sudden change? This is not really a sudden change actually, because in any other language also, if you would have seen, there is always a natural progression of going from a procedural way of doing things to an object-oriented way of doing things. How does it differ? For example, let's say if I have to tell my friend who is new to Bangalore and he's staying in Koramangala, I have to tell him to go to Forum and buy a movie ticket. I'll have to tell him step by step. I'll have to tell him go out of the house, take the right turn towards BDA main road, then go towards Jyoti Nivas College Road, then take the left turn and then right turn, and then you reach Forum. So I have to tell him every step in detail. But when my friend is there in the city for more than a year, I know he already is aware of Forum. I just tell him, dude, just go to Forum and buy me a ticket. So that's the difference. That's the key thing, the thing of handling complexity. When the things are smaller in size, you tend to have a procedural way of doing things, but when your complexity of your application increases, you want to look at things more from the object-oriented way, which is the component-based way. So AngularJS, although in 2.0 is totally component-based, in 1.0, 1.5.x, they introduced the concept of components, wherein you can actually create components as HTML tags and use in your application. But wait a minute, aren't these already there in AngularJS 1.4 and before, like using directives? But not really, because directives, if you look at it, I can create an HTML tag, say my foo, and then I can have my own custom logic over there. But that is not all. I can just create an attribute with the name as my foo. So for example, if I want to create an input box and I want to have the behavior of it to be a currency. So I say that, okay, you know what, this input box is supposed to take only currency values, which means it should have 2 digits after the dot. If I try to enter any alphanumeric characters, do not allow it, maybe show a red color at the background. So these kind of things are behaviors. So basically we are adding extra behavior on a existing HTML. And that was the purpose of a directive, to actually enhance the DOM. But the concept of a component is actually not to enhance DOM, but to create a component. And that mindset difference is what makes all the difference. Component is actually just a sugar coating over directives, but then, so it basically, it says that, you know what, scopes, it will always be true in case of components. Bind to controller will be the default. You don't have to specify your controller names. You can just use a $CTRL by default. And then there will be a good on init and on destroy methods that we'll have over there. So these kind of things is kind of your restricting your directive to say that, you know what, you have to do just this way to behave as a component. Why this is important is, I'll give you an example from my gym. Earlier I used to do a lot of bicep exercises and I used to try to lift as heavy as I can. But I would see that while I'm doing that, suddenly I will move all my body around to try to lift that weight. Then one day my friend came to me and told me that, you know what, this is the wrong way you're doing it. You have to just sit down and then do it, because now I'm restricting you to just move your bicep. So this is what we are trying to do with components. We are restricting the directives. We are saying that, okay, you know what, you cannot just be a general purpose thing. You have to behave this way so that you can behave like a component. So that's the main thing about moving from directives to component. And okay, so now quickly about how to move into a components. First of all, your application, if it has directives, AngularJS applications, try to divide it between components and behaviors. Like the current example I told you, that was actually a behavior. So move all those things into a folder name as behaviors, and move all your other directives, convert them, refactor them into components. Try to have immutability in your components. Try to have one-way binding. And then try to have all your CSS, HTML, and JavaScript of a component together within the one folder itself. So that way it gives you a very clean picture that this is the component that I can use all across my application. So yeah, so that's about it, I guess. And the one last point that I want to just want to say is that if you go this way, moving from AngularJS 1.x to AngularJS 2 will be much easier. Maybe not syntactically, there might not be tools to direct import it that way, but because you have structured your application this way, it will be much easier for you to just change one component at a time and move to an AngularJS 2.0 framework tomorrow. Okay, thank you.
Thanks, Avik. Next is Roshan.
Yeah, can I take it up?
Check. And yeah, just. No, that's okay, I'll use it here. Yeah. Hello, everyone. So this is I've been hearing all the talks, especially around performance. We have had a lot of talks on web performance, and people really asking, how do we do real user monitoring? Google Analytics gives all the metrics with respect to your conversion rates and other thing. So I've been doing this, my passion project turned into serious thing. There's a website called ironmycar.com, which I developed. And it was like, one-man army, I did the whole thing. So, and I'm a software engineer. So user experience design, user interface design, all these things were new to me. So when I started it, so I did use Google Analytics, but I realized that beyond a point, there were limitations to it. I was not able to really feel what the user is doing. And if you really look at the UI practices a typical user designer would do, he would, the lean UX and other practices people follow, they'll actually interview the users, talk to users, and see how they're doing it. So sometimes, so this gives much more information than what a typical tabular data would give. So one of the critical things when it comes to real user monitoring, or to see what the real user is doing, it would be best to see what the user is actually doing. So when I was doing this, I did show it to a couple of my friends, people whom I know, to say, okay, you use the site and I will just watch over and see what you're doing. But the problem with that is people will turn around and ask you, okay, what do I do next? You just cannot avoid that. So then I was talking to many people, and I came across this nice tool. Surprisingly, I didn't have, and it's a pretty old, it's been there for some time. It's called Hotjar. So what you can do with this is, you can actually record your entire user's session, and it will replay it to you whenever you want. So, and when I use this, this gave really beautiful insights. One, with respect to your design as well, what the user is clicking, where he's going, what he's trying to do. And second, sometimes you also get to know how much he's waiting. It also sort of captures the wait times and other things. So I'll just quickly show you. So this is the dashboard. And it comes with a simple, small script. You just have to add it, just like your Google script and all. And then you can further control, how many users have, how many, whether you want to capture all 100% of your users or you want only a slice of it. Okay. So this is the dashboard. So, and it's a freemium model. So basic 300 recordings and all, you can do it for free. So if you're just a startup, if you're just experimenting, you can just go ahead and try it for free. Right? There are heat maps, recordings, and funnels. I think recording is the most interesting thing that I saw. And you could tag it also. Like for example, I have tagged it here. Let's see some of the UI successes, sort of, what I saw. Not sure why it's not filtering. Okay, right? So let's say on 12th August, something was there here. I'll just click what happened here. Right? So see, the user came, checked the home page. He's trying to, this is a recommendation thing that we do. So he's answering the questionnaire. See again went. And it really gives, critical information. See, he tried to see the arrow mark. So one is the user design, and then I'll show you quickly. And you can increase the speed also here if you don't have patience, right? All these things. So this is one. So I'll show you another one where we're talking about. So this one captures, here the user is frustrated because maybe he was on a bad network or something, and it didn't. Yeah, this is the other one. See, this is what had happened is we had done a cyclic carousel. So the user didn't realize actually, he kept clicking and said, why is it coming? You can see the number of clicks. And then here when they are searching, it was taking really long time. I think it was at this point. It's not coming, and in some cases the order was doing. So basically, so it sort of gives a view of what actually the user experienced, and with respect to security, yes, it does take care of sensitive fields. If you marked your fields as password or any secret fields, it will do that, and you can further instrument the code to customize it for your needs. And you also have these heat maps view, which you will get to see where the user was scrolling most, which part, of your entire screen, especially if it's a single page application. If it is too much of scroll, you can see the click and even the move and the scroll on this. And you could even track the conversion rates. See, it is, and then once red is hot, green means cold, which means they are not doing it. And then there are funnels to see the conversion rates. They came to one of the pages, and then they go to the other page. And along with it, of course, you can do other polls and other things. If you are on the page here, you'll get it. Some of the polls. You can do other nice here and there things. Okay, so that's it. Hope this helps. Thanks.
Snake Andrew? Not here? Oh, yeah, no, yeah, okay. Akhil Agarwal?
Sneganju Akhil Agarwal. Okay. Supreet Pal Singh. You're the tweeter.
Yeah, so very quickly in 5, but like now in 15 minutes, I will very comfortably show you how to build a JavaScript transpiler. It sounds very fancy, but it's really not. So what we need to do is we need to convert JavaScript into any other language. So transpiling means one high-level language to some other high-level language. But now I'm going to demonstrate how to convert JavaScript into any language. So I had to pick a language. Which language would I pick? So I'm going to pick English. I'm going to convert JavaScript into English. We are going to do it in 5 minutes. So let's do it very quickly. Some things which I'm not going to explain is NPM, Babel, ECMAScript. Some basic JavaScript latest technologies. So yeah, so this is an NPM package. It includes Babel, and it includes Babel Traverse, and it includes Babylon. So the last two is something which you probably don't know, and that's what I'm going to explain. Babylon is a parser which takes in JavaScript and gives you abstract syntax tree. It sounds very fancy. It's not. It's just a JSON. Okay. For all intents and purposes, an abstract syntax tree is just a JSON which you can traverse, which you can pick up elements from and consume them. And Babel Traverse will kind of help you traverse that abstract syntax tree. Okay, so let's go into the code. This tiny piece of code, we start from the top. So I'm including everything I need. Babylon is the parser. Babel Traverse will help me traverse the abstract syntax tree, and FS will just help me write to a file. Read from a file, write to a file. Okay, so input file, output file. Input file is basically going to take an argument from your command line, which is the file which I need to read the code from. Output file will tell you which is the file I need to write the code to. Okay, and this is where I read the file. Input file, FS read file sync, the code is over here. Okay, it is in UTF-8. I use Babylon parse. Whatever was in that file will now be passed over here into an abstract syntax tree. It's nothing, it's just a JSON. Okay, it's just a JSON, and I'm going to traverse it using the traverse function. Now, there are two parts of it. One is enter, the other is exit. So if there's a code block, right? For example, there's an if statement, you will enter it and you will exit it. If there's a for loop, you will enter it and you will exit it, right? So that's what this does. It will enter and it will exit. Every time it enters something, this enter will get called. Every time it exits something, this exit will get called, okay? And now it has an argument which is path, which is the JSON that you're going to consume, right? And how does that look like? It looks like this, okay? So for my piece of code, I'm just going to declare a variable. So it says it's a variable declarator. It tells me where does it start, where does it end in the file, but I don't have to care about all of that. You can get really fancy, do really fancy stuff. All I'm going to do is this is what's important to me. What is the name of the variable and what is the value of the variable, right? Name and value. How do I get it? I go into path.id.name and path.init.value. So that's what I'm going to pick over here. And you should ideally use template strings, but to make it look simple and easy to read, I'm just going to use normal strings. So I'm going to create a string which I'm going to eventually write to a file. So source string is that string which I'm going to create. So what am I saying? I'm saying variable space, what's the name of the variable, is equal to what's the value of the variable. All right? Following. Variable, name of the variable is equal to what's the value of the variable. So this is my code, right? Variable A is equal to 5. Now I have to go convert it into English. And this is all I need to convert it into English, right? So I call npm test. So npm test does nothing, but it just calls the node process. This is what npm does. It calls Babel to convert it into normal JavaScript, and then it gives an example input and output file. It provides the file's path name, where to pick it up from, and where to give it, where to output it. So this gets converted into this. Variable a is equal to 5. As simple as that. But let me write another one. Maybe it's hard-coded, right? Equal to 10. I save it. I call npm test again. Variable b is equal to 10. Yep, done. Thanks. I'm also going to put this code on GitHub, so you can. This is me everywhere. Supreet. This is me everywhere on all of the internets, GitHub, Twitter, Facebook, whatever. And I'm going to put this code. You can clone it, and you can actually expand it to do a lot of things. You can use it to optimize your production code by converting one type of loops to another type of loops. You can do all sorts of fancy stuff. Everything that you see in the model build system, like Babel, Webpack, uses abstract syntax trees to transpile everything. Okay, thank you.
Check.
Thanks. Next is Sridhar.
Hello everyone. So myself Sridhar. I work at Practo, and today I'll be giving a flash talk on life after page load. So since morning we have been seeing a lot of talks about like initial page load time, and then kind of time to first wait, and then time it takes to let the user to have a first interaction, something like that, right? So now I'll be talking about what happens after the page load. So cool. So I'm actually I'm part of Practo Ray. So Ray is a software for doctors where doctor can actually manage their appointments, and then reminders, follow-ups, and their patient health records to billing, and then follow-up, something like that. So as I mentioned, so calendar is one of the important application at Practo Ray, where doctor can manage their appointments with the patients. They can actually have a look at the day schedule, and then they can have a look at, they can apply filters on over the doctors, and like receptionists can also create appointments for doctors, something like that. So here, doctor can actually, doctor or receptionist can go to next month or come back to previous month or something like that, and check the appointments booked for each doctor, right? So here the problem is, there are two problems. One is, as and when I move to the next view, I keep on fetching the appointments from server, and then whenever I go back to the previous month, again I keep on fetching the appointments. So here there are two problems, right? So one is, there are a lot of data to be fetched from server, and the second thing is not so good internet in India, right? So these are the two things, and this is the kind of after the initial page load. So this is what network time is somewhere around 3 seconds, and then application time is, even though it's less than 1 second, network time is taking too much time, and then making the site slower, right? Imagine if you have databases in your browsers. So thanks to our HTML5 and then all the browsers who have support to it, so we have IndexedDB, wherein you can store some data in your client side, that do in browser, and then you can have a asynchronous. It provides asynchronous APIs, and then it also lets you access the domain, data stored in the same domain, and then you can actually create or open the database store, and then you can actually put the data into the data store by passing the data, and then the success callback and error callback. And if you want to query the data from IndexedDB, you can pass the index and then the key range between lower and upper. and then as usual, like success callback and error callback. So this is the browser support for IndexedDB. So Chrome right after 49 version 49, and then Safari, all those browsers have support to IndexedDB. So even after this, so if you see all these appointments, now all of them are stored in the IndexedDB, and as and when users keep moving to next month or previous month, so we are not making API calls. But we do have one more problem here, right? So imagine if no appointments are stored in IndexedDB, and then if you start fetching appointments for future and then past couple of months, it would block the thread for some time for users to not do any interaction, right? So then comes our web worker. Web worker is a kind of chunk of code which can run on a different thread, and it can also make API. It can make AJAX calls and then send back the message to the code which initiated this, which passed this message. And now I keep on. I keep a check of till when I have a data. And then I keep fetching the appointments in a batches, and then I keep storing them in the IndexedDB. And now, if you look at the load time, right? So with IndexedDB, I can save somewhere around 2.2 seconds. So that's it. Thank you.
Thanks, Sridhar. Ankit Mani is up next.
Hello. Mic testing, 1 2 3, 1 2 3, mic testing. Check, demand draft, net banking, COD. Okay, hi, welcome guys. So I felt that there's a little low energy hanging in the room. I checked outside for a rain check. It was still raining, so I was happy that more people can't go out of this room. Okay, so I am Ankit Mani, and I work at Flipkart. And why is my laptop not powering up? Okay, yeah. With the lack of, don't go by the title, because I lack a great vocabulary, I couldn't find an exciting, intriguing topic for today's talk. So today's talk is about the what the fuck moments which I have while I write code, and some gotchas which like make me lose a lot of time, and we'll be going over that. So the first thing is I heard like React is all over the park, like everybody knows React, and people are writing React, good. So you write a lot of components. And so how many of you use this.props in constructor? Okay, so congratulations, you have just broken your code on IE. Please remove this, just use props. Okay, next I also heard that people use Redux like crazy. So how many of you guys use Redux? Okay, and most of the people have left, so. Okay, so the thing with Redux is, we have all the data in our application right in front end, okay? And there's so many ways we can use that data to have the perceived performance in a lot better way than like anything put together. So you have heard fancy techniques of PRPL, and I don't remember the full form now, but data in your application can go a long way in making the perceived performance a lot better. So like when you open a Flipkart homepage or search browse page, there are tons of products. Similarly, your application might have a list of products for which the API might be different. You might have a different action creator, different reducer. And you might have a different reducer for your normal item, like detailed view. But what you can do is you can populate your different store based on the same action using Redux. So you can handle a different type of action in a different reducer function, which you can then have a background process in which your data is in sync. So by the time user clicks on your detailed product, you can reuse the browse page data and show him a glimpse of the product. So he's like, wow, my image has been loaded. And like you get so much performance gain. Okay, and like we see a crazy pattern. People use Redux, and most of you have like async status to check whether you have fired the API call or not. So in your component, you check like if my async status equals to pending. What I do, I show a fancy loader, right? And when the data comes back, I show that data. Now, we can do better. So what we will do is, instead of showing a loader all the time, we do not do this check.
Instead, we check whether the data is empty or not. Okay, and then we show an overlay, and when the new data comes, it just updates in place. Okay, so this is a great tip which has been given to me by colleague Avinav. He gave the first talk. Okay, and since I work at Flipkart, like, we are not allowed to do things simply. And you know, I'm a very simple guy. So suppose you have to do some interaction, and we try to fit in some animation so that we can put more goodness in it for the user. So I'll try to show a simple example. Okay, I have some time left. If only my password was small. Okay, so why is it? Okay, 1 second. Okay, so just concentrate on the things which I'm showing you. So this is a image, right? And like, you can see a little bit transition which is going in there, right? So earlier when I was asked to do some transition, I was always get confused whether to use CSS transition or JS transition. So after a lot of times, what I felt is, if your transition is like constant, so suppose you're trying to transition a drop-down box, like when you click and your drop-down needs to fall down. Okay, now this transition is fixed. Okay, so you can use a CSS transition, right? But whereas if you are trying to move a card and swipe it, your transition depends upon the user interaction. In that case, you need to use a JavaScript transition, and like, you can use ease out functions. And what I will show you is another thing. So suppose you are trying to buy this awesome shoes on this awesome website. So you try click, and can you see a little wiggle there? So this is also done via CSS transition, because this wiggle is constant no matter how many times user clicks or not. So it is not dependent upon my input. And as we all know, Paul Lewis and Das Surma, we know that anytime you want to do any transition, use transforms and opacity. And do not remember to do will change transform. Okay, but when you do will change transform, you also need to keep in mind the stacking context it creates. And I think all of you know that Z-index works only if you have an element position or if it has a different stacking index. So can you see the problem here? We have these tooltips. We have a tooltip there, and this awesome image zoomer will come on top of it. So you have to keep in control all these Z-index, otherwise your application will break. So what thing we do at Flipkart, we try to store these Z-index as part of variables, so we can clearly know, okay, which layer comes on top of it. Okay, and last but not the least, how many of you put keys on your Webpack React JSX in the map function? Do you use indexes? Please do not do that, because it is an anti-pattern, and React has, so suppose you remove an element and add one back in the middle, React has no way of telling, because keys is the only source of truth. So we had one bug, the key was a string, and no matter what I did, I could not find that, the image could not update, and my code could not go to production for 3 days. Okay, so never put strings as your keys, or numbers. Have a unique ID of your object if it's not possible, or write a unique ID generator which generates a unique number every time you require it. Like, it stores it in a closure or something. Okay, okay, I still have some time. No. Okay, thank you. Thank you so much. I hope you enjoyed my talk. Thank you so much.
Thanks, Ankit. Prashant Sani is next.
Hello? Okay. A very good evening, guys. So my topic for today is re-engineering JavaScript animations. And I would say, why should the designers have all the fun? Okay. So I read a book by the name Creative Confidence, and the book says that anyone can be a creative person.
creativity is all about using whatever problem that you have, finding a innovative and creative solution and implementing it in your code or in your profession, and so that got me thinking, as a JavaScript developer, how can I be a creative person? So I explored on one of the most interesting creative aspects of JavaScript, the animations. So I'll briefly just talk about one of my favorite DOM animation libraries. It's called GreenSock. I would say GreenSock is jQuery of animations. And I'll also guide you guys with some of the basics of animations on the way. So I'll be just hand coding some of the stuff, so please show some love. Hello? Yeah, thank you. Very dry audience, sorry. So we have a very basic HTML here. Hello? So I'll just open this HTML. Oops, you saw something. Okay. Sorry. Okay. So we have some very basic HTML here. And we have the body tag. I'm just commenting out this thing as of now. Okay. We have a wrapper, and we have an image, and we have a heading which says welcome to JSFoo. This is how it looks. Okay. Very simple, basic stuff. So the first thing that you need to include is the tween max, there are a lot of GreenSock includes a lot of plugins which says tween max, tween max light, tween light, timeline max, and timeline light. You can include tween max. That pretty much includes everything. You can know more about the stuff on the GreenSock website. So I'll just start typing my code here. Since we are on a very limited time, I'll just copy paste some stuff from here, and I'll explain the code as I go. So it says tween max. This is the library. Now this is that element. You can pass on a CSS selector here, and you can. This is the duration. So you say, okay, for 0.2 seconds, do something. Now, one of the most interesting things all these animation libraries have, they have all the performance stuff already in place. So you don't need to worry about will change property as the previous speakers said. And you don't need to worry too much if this is using a 3D transform or just using something else. So I'm just saying, okay, just go. So there are two things, from and to. So I'm saying from 100 pixels on the y-axis come to the current position. So this is the current position. So you will see this image moving from 100 pixels down to its current position. Very simple animation. Okay, so how about adding one more tween to this? I would say, okay, animate the h1 tag as well, but animate it for maybe around 3 seconds, and do it for around, do it at 200 pixels from its current position. So you can use 200, you can use minus 200, and it goes something like this. Okay. So there are three things when it comes to animation. There are three things which are absolutely you have to keep in your mind. One is the duration. This thing. This absolutely matters. Then it's obviously the animation. And the third thing is this easing. There are a lot of easing. There are a lot of articles that you can read on a lot of easings that are available on all the libraries. But these are the three things that you should absolutely keep in mind while coding animations. Okay, so how about using a timeline for this? Maybe I'm having two animations. How about keep creating a timeline for whole animation? So I'm just copy pasting this code here. I'm adding it here. Okay, so this code says create a timeline. By timeline, I mean a storyboard or something like that. I say, okay, do this and do this and do this. So I have 3 timelines, and I'm saying, just 2 minutes, I'll be done. Sorry. Okay. So I'm saying instead of having two tweens, I'm saying first animate the image, then animate the h1 tag, and first create this is a constructor function, obviously, then add your timelines here. This. Okay. I was supposed to include a library called Stroll Magic, if you would have heard of this. It's a very, very simple library, but unfortunately there's no time, so I'll be actually writing an article on this. You can follow me on, you can follow on my blog, which is Prashant Sani Spider. You can even, there's no internet, and deliberately I've kept it off so that nobody disturbs me. And this is the last, this is a very simple last demo that I would wanted to show you. Okay. So this is how it goes. Thank you.
Thank you, Prashant. Up next is Captain Nemo.
Hey, still on. Can everyone hear me? Where's the DP1 adapter? Okay, so I'll still start. The title of my talk, yeah, it'll take time because I don't have a connector. The title of my talk is All Software Sucks. Oops. Thank you. No. So the title of my talk is All Software Sucks. How many people agree with the premise? All software sucks. Wow, very few. Hopefully by the end of the talk, you'll be convinced otherwise. Okay, so the talk came about because I realized a while back that the issues that I was facing on my Mac system were not, even though not similar to the systems that I faced on my Linux system, but every damn system has its own issues, you know? If I try to, wow. Projectors suck, by the way. So if I try to play music on my Linux laptop, it doesn't work on Bluetooth. If I try to read NTFS drives on my Mac system, it doesn't work. Google Slides also doesn't work. Not just operating systems, programming languages, you know. CSS often doesn't work. Hardware. Do you know why we invented TCP? Because routers kept on dropping our packets. Hardware also sucks. And now you guys are wondering what's the point of this talk. This is a light-hearted talk. I should have warned you before. I'm not going to teach you guys anything here. Okay, for example, this is my memory usage on my Chrome these days. 25% Gmail, lots of it Slack, lots of it other parts of Slack, and the remaining tiny bit is given to my operating system. So yeah, let's actually try to define suck. What exactly does it mean when a software sucks? Very often, the definition would be A, it doesn't work. B, maybe it's slow. C, it's confusing and the user experience is bad. I'm trying to do something, but you gave me a form that's really, really bad and terrible to fill out, which is why I don't want to do it. For example, if you're trying to pay, why do you want to know my billing address and my shipping address if I'm trying to buy, let's say, an online ebook? Don't do it. Software crashes. Why? It sucks. So now that we know of this hypothetical quantity called suck, how can we actually use it to build better software? So one of the things I realized while making up these slides is all of this suckiness comes from complexity in code. So, you know, there's a magical wizard programmer who's trying to tame this complexity, and that's essentially what we do as part of our jobs each and every day. We try to tame complexity by writing pieces of code. Unfortunately, complexity doesn't want to be tamed. Each and every time you write code, you're increasing the complexity of the system itself. So I did some research, and it turns out complexity does not correlate well with suckiness. I don't have a better word. People have researched about it, and the complexity of a code, if you measure it properly using metrics like cyclometric complexity, which tell you how many branches your code path may take, while it correlates with the number of bugs that people have found in your code, it also correlates exactly the same way with the number of lines in your code. So it doesn't there's a correlation, but there's not a causation. So if you write a longer piece of code, it will have more bugs, obviously. But reducing the piece complexity of a code will not give you better software. So what can we do? My suggestion is to embrace the suck. By this, I mean design your software in such a way that it behaves performantly. For example, if you're writing a writing process and think of Erlang, if a process crashes, you let it crash. You work around it. Assume that your software will crash. Assume that it will break. When you're writing software development, as in if you're writing the release cycle of a program, make sure that you leave out time. Shipping is not the end part of a release cycle. You ship the program, and then you make sure that you fix bugs in it, because there are going to be bugs. And that's the end of my talk. Embrace the suck. That's my message for you today. I hope I managed to wake you guys up. Thank you. Okay.
We have 2 last talks left. Next is Vivek. And there is one other person after that.
Oh, hello. So I'll try to make my talk short but fun. Okay. So how many of you guys have heard of Knuth? Donald Knuth? Okay. How many of you guys have read his books? Okay. How many of you guys understood his books? Okay. No liars in the audience. Okay. So he said a very famous thing. We've been talking about performance all day, and I've been doing performance all my life. So it's like premature optimization is the root of all evil. But you know, for every truth, if you reverse all the things, you should get another awesome truth. So delayed pessimization is the fruit of all good. So what I mean by that? I mean that while you should not consider optimizing so fast when you initially write your code, you should also not be so eager to pessimize your code, saying, "Abhi theek hai, baad mein theek kar lunga." That doesn't work. So let's define optimal. What's optimal? How should your code be? How many of you agree that your code should be maintainable? Okay, good. How many of you agree that your code should be performant, fast? Okay. How many of you agree that your code should be correct? Okay. How many of you write correct code? Okay, one liar spotted. So the thing is that correctness is something that, despite all the Haskell programmers telling us that, your programs are proofs and code is theory and all that, elephant poaching is illegal in India, so those ivory towers should be burnt. Okay. So it doesn't work that way. You cannot predict how a program is going to run. You can never prove a program correct. That's a Turing hard problem. So what we got to aim for instead is try to be as correct as possible while not making it so sucky that it's slow. Because while a crash is bad, a slow thing that works is even bad, because the person wants some result to happen and it's not happening fast enough. So what you should do is you should develop some habits when you write code. Just like you develop a habit of commenting your code and make it maintainable and writing it in a verbose and clear fashion. And similarly, you write your unit tests or whatever stuff you use to make sure your code is correct. You must also develop habits that make your code fast. Okay. So the first thing, there are 6 things that I want to tell you about. They're very short. Habituate optimization, which means that by default you use practices in your language and your framework which are optimal. Like for example, if you're a C++ programmer, you never use post increment. You use pre-increment wherever is possible, because it's just a reflex action. You know that at some point of time a post increment is going to take more time, so you have to use pre-increment. Or depending on your language, like for example in JavaScript or in any language, if you have a conditional inside a loop, it's going to be slow. Put the conditional out, make 2 loops. Fine. Look before you leap. Before you decide that some way of doing things is better, you have to measure. You have to look at other people's work who's done the same thing. Everybody knows that linked lists are awesome for inserting in the middle and all that, but when you measure it, you'll find out actually arrays are faster. That's the way it rolls these days. So even though the computer science says that okay, order of n and order of 1 and all that shit, when you measure it, you're going to find that on today's architectures with caches and memory and all that stuff, the array is actually faster than linked list. So always measure. Look before you leap. Don't just blindly trust some intuition. Write the code, write an alternative, measure, and then progress. Write one to throw away. This is not so much optimization of performance, but optimization of your development process, because you might start out with certain fixed ideas in your mind, you might go down a path, and if you get too attached to that code, you're going to be led down a path that's going to get more and more complex, and you'll find yourself constrained. So instead, treat code as something that is consumed and then thrown away. If it gets into production, cool. If it doesn't get into production, cool. You can just write more of it. None of us here who's a professional programmer will be so bad that you cannot recreate a program which you created before. Even if the source code is gone, you can do it. We all can do it. That's what we're paid for. So don't, this one. Fourth point, just 2 minutes more. Fourth point is, copying is good. Not at runtime, but at compile time. Okay? It's cool to copy stuff which others have invented, but don't do copying at runtime. Okay? Whenever you copy stuff at runtime, if you see 2 blocks of code in your source which are similar, it's time for an abstraction. You should not be writing the same thing twice, right? Because it's going to execute twice. Or whatever is processing that HTML or JSX or whatever is going to do it twice. Abstraction means avoid repetition. Never repeat yourself. Whether it's functional or whether it's objects or whatever, reuse. Okay? Simple is fast. This is a basic thing that's been there from the time of the 80s. The less code you have, less bugs, the faster. Barring the case that you find a much better algorithm for doing your code, it's always the case that when you remove code, stuff gets faster, stuff gets simpler. With the deleted code, bugs also get deleted. So that's the way. And then finally, don't reinvent wheels, but also do reinvent wheels, because you need to know how a wheel works. You reinvent a wheel to understand how it works and see what are the challenges that are required to implement a good wheel. But once you learned it, right, then you don't go trying to make the best wheel in the world, because a lot of people have done it before. So unless you have infinite free time on your hands and you're some like an awesome, top class programmer, don't try to reinvent wheels. Do it afterwards in your side project. Do it once you're done with the production. So that's about it. So thanks.
Hello. Yeah.
Last speaker is Siddharth.
All right. Wow. All right. I'm sorry I grabbed the last point. I know a lot of you are like waiting, like when can we go home? When is this thing over? Right. Okay. Awesome. Let me just zoom in. All right. So, Sunil Pai talked a little about how we really care about how our UI is and how our content strategy is and how it should look and feel. Like we've gone overblown on UX, right? But when it comes to developer tools, we kind of really suck, right? So I'll give you this example, right? This is something that I've done 1,000 times, right? So I sometimes write in Node, right? And I'll do something very simple like express, require, express, right? And now after I've written this, what I have to do is I have to leave my Sublime, I have to go to my terminal, I have to do npm install express save. Let me just, right? And I find this very annoying. Like I'm in between my code, I have to quit this and go to my terminal, install something, come back and carry on, right? So just to solve this simple thing, I created a tiny thing, which is, I call it auto install. So you just run it in your terminal. And now everything I do in my code, for example, I install, say, yargs. Require yargs, right? And you see, like, let me, in the background, it's starting installing it, right? So now I can actually move on and use my code rather than worry about like jumping between my terminal and this, right? And of course, when you remove it, it will also uninstall and all of that, right? And so naturally, after creating this, I did what any developer would do, right? I put it in I basically put it on GitHub and shared it on Hacker News, right? And this is the best part, right? This is the part I enjoyed. The moment I shared it, this was a blast, right? Like people started on, oh my God, why do people still use NPM and what is this joke? And like, let me just go, right? So it was like amazing. And this is my favorite comment. Like, just when you thought dependency hell couldn't get worse, it became automatic, right? So like, awesome. And so like, so there is something though that I learned. So there is an interesting concept called typo squatting, which is effectively people wait till you make a typo, right? So for example, instead of say express, if I make a mistake of saying, say express with a single S or a triple S, right? And this could be another module which is not actually express, right? It's some actual malicious module, right? And somebody could totally use it. So for example, if you say facebook.com, right, which is a totally legit way to hack someone, it actually goes to Facebook. Like Facebook has bought facebook.com, 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 right? Same with Google. Google, write as many E's as you want, right? It's gonna find its way back to some Google domain. Even if it doesn't open google.com, it will open a 404 page of Google, right? So this is something I learned. It was pretty interesting to learn, and naturally I had to like add something, so I added a secure mode which only installs stuff which is popular, right? Otherwise, like, I'll also do this mistake and get into trouble, right? So just something I created over the weekend. You can get it at GitHub Siddharth KP, which is me/auto install. Another thing that I'm working on right now is called cron duty. Again, same concept, kind of tired with ugly tools that we have. This is basically cron monitoring. You log in with GitHub and you set up your crons, and basically it gives you pretty stuff. Like it's same old cronitor, node more of those stuff, but pretty, right? So I'm kind of spending a lot of my time in making our dev tools prettier. If you're interested in the same topic, ping me on, say, Twitter at the same Siddharth KP handle. Let's talk about it. It's something that I'm really interested in. Cool, that's all.
Thank you, everyone. We're done for the day. See you tomorrow. Please don't forget to fill the feedback